はい。Oh shit. Sir, వచ్చి తీసు
mine behind, I'll give back to these guys. Otherwise, idle hands, right? Yeah, no, it's good. Yeah, my mother's elderly, so I look after her. Oh, I'm really lucky she's not. Yeah,
A very warm good morning to all the ladies and gentlemen, esteemed dignitaries and the distinguished delegates. On behalf of the Indian National Center for Ocean Information Services, it's our privilege to extend a warm welcome to the International Indian Ocean Science Conference IIOSC 2025, sponsored by the Ministry of Earth Sciences, Government of India. I'm Dr. Elaine A. Sabo. It's a special honor and a pleasure to compare for the inaugural session. I had the privilege of comparing the very first International Indian Ocean Expedition Conference in 2015 at CSIR NIO Goa. And today, I feel equally proud to welcome you all here at INCOIS Hyderabad for IIOSC 2025.
And I'm Suresh Kumar, delighted to join my co-host in guiding you through the memorable occasion. Together, we look forward to celebrating the decade of IIOE2 and the beginning of important scientific dialogue at IIOSC 2025. The prestige conference brings together the finest minds in oceanography and marine science from across the globe. Over the next 5 days, INCOIS will be the hub of scientific dialogue, collaboration, innovation, as we reflect on a decade of progress under Second International Indian Ocean Expedition, IIOE2.
The International Indian Ocean Expedition 2, launched in December 2015, has been a landmark initiative engaging scientists from more than 22 countries. It has advanced our understanding of the physical, chemical, biological, geological, and climatological aspects of the Indian Ocean.
Through 60 ENDOS project, international collaboration, and the vibrant early career scientist network, IIOE2 has strengthened research, observation, and capacity development. As we now look ahead to its proposed extension until 2030, aligned with the UN Decade of Ocean Science, IOSC 2025 serves as a platform to showcase achievements and the chart way forward.
Today, we are honored to have with us Dr. M. Ravichandran, Secretary, Ministry of Earth Sciences, as our chief guest, Dr. T. Srinivas Kumar, Head, UNESCO, Intergovernmental Oceanographic Commission, Secretariat of the Indian Ocean Tsunami Warning and Mitigation Systems, as our guest of honor, Dr. Sinjay Yu, the representative for the Scientific Committee on Oceanic Research Score, Dr. Nick Dadamo, IIOE Project Coordinator, University of Western Australia, Dr. Jenny Huggett, Specialist Scientist and Head Biological Oceanography from South Africa's Department of Forestry, Fisheries and Environment and IIOSC Officer, Dr. T.M. Balakrishnan Nair, Director INCOIS for the inaugural ceremony. Along with them, we also have Dr. Vidar Helgeson, Executive Secretary for the IOC of UNESCO, and Dr. Brett Maloney, Chairman for Global Ocean Observing System of the Indian Ocean. They both will be joining us online.
I request Dr. D.M. Balakrishnan Nair, Director INCOIS, to accompany the distinguished guest to the dais.
We extend a warm welcome to all the distinguished dignitaries, esteemed delegates, scientists, and the participants joining us from India and abroad. Now, I request Dr. T.M. Balakrishnan Nair, Director INCOIS, to kindly present bouquets to our honored guest as a gesture of welcome.
Thank you, sir. As we embark on this journey of knowledge and collaboration, may I request everyone to kindly rise for the invocation. Let the spirit of ocean science and unity inspire us as we begin. I now invite Dr. Satish Enuri to lead us in the invocation.
एकदन्तं महाकायं तप्तकाञ्चनसन्निभं लम्बोदरं विशालाक्षं वन्देऽहं गणनायकम् ॐ गुरुर्ब्रह्मा गुरुर्विष्णु गुरुर्देवो महेश्वरा गुरुर्साक्षात् परं ब्रह्म तस्मै श्री गुरवे नमः तस्मै श्री गुरवे नमः तस्मै श्री गुरवे नमः तस्मै श्री गुरवे नमो नमः.
Thank you, Dr. Satish. We now invite our esteemed dignitaries on the dais to join for the ceremonial lighting of the lamp, a tradition that signifies the triumph of knowledge over ignorance and marks the beginning of this enlightened journey together.
Thank you, esteemed dignitaries. The lamp lighting symbolized the illumination of knowledge and wisdom and setting the tone for the scientific journey. We now invite Dr. T.M. Balakrishnan Nair, Director INCOIS, to deliver the welcome address.
Honorable Chief Guest, Dr. M. Ravichandran, Secretary, Ministry of Earth Sciences, Dr. Sinchi Yo, Dr. Nick Adamo, Dr. T. Srinivas Kumar, our distinguished representative from IOC UNESCO, SCORE, IIOSC, and other partner organizations, colleagues from the Ministry of Earth Sciences and the sister institutes in India, esteemed delegates from India and abroad, dear early career scientists, ladies and gentlemen. A very good morning to all of you. A warm welcome to International Indian Ocean Science Conference 2025, IIOSC 2025, being held here at INCOIS, Hyderabad from 1st 5th December 2025. This conference is particularly special as it marks 10 years of Second International Indian Ocean Expedition and brings together the global Indian Ocean community to reflect on the progress made and its road ahead. It's also important, as you know, that we have new subcommission of IOC, that is IOC India, that is formed last year. So this is also a special event after this formation of IOC India. So we have a good body to take care of all the research and development activities in ocean science under IOC umbrella. For us at INCOIS, under the Ministry of Sciences, Government of India, it's an honor to host this gathering of scientists, practitioners, and policymakers who are shaping the future of Indian ocean research and services. Over last decade, IIOE2 has enabled collaborative research across more than 20 countries, advancing our understanding of the physical, chemical, and biological, and geological, and climatological process of the Indian Ocean, and linking its knowledge to social benefits and sustainable development. In India, we are fortunate that science and technology enjoys strong national priority at the highest level of leadership. Our Honorable Prime Minister, Sri Narendra Modi ji, has repeatedly described platforms like India International Science Festival that is going to be on next 6th to 9th in Chandigarh as a celebration of science, where India's rich scientific legacy is linked to even more ambitious future. He has been emphasized that India aims to become one of the most trusted centers for scientific learning and innovation, inviting the world to invest in Indian talent and innovate in India. This vision is much reflected in IIOSC 2025 also. The work presented here across ocean observations, modeling, process studies, and applications demonstrate how the Indian Ocean community is using science not only to expand knowledge, but also to deliver tangible benefits to society. Better forecast of monsoon and climate variability, improved understanding of boundary currents at upwelling of fisheries, enhanced prediction of extreme events such as cyclones, marine heat waves, tsunamis, and informed management of ocean ecosystems and resources for the blue economy. Especially our Secretary, Dr. Ravichandran, often highlights that one of the biggest long-term responsibility of the science system is to attract and nurture young minds. I'm therefore especially pleased to note a strong participation of early career scientists at IIOSC 2025. Welcome very specially for all young talents. Your energy, creativity, and openness to collaboration are essential for sustaining Indian Ocean research beyond 2025. So what we require is a operational oceanographic research and more focused on translational or operational oceanography to make more services and products that India wants and the international community wants. What require, when I say from the GOOS side or WMO side, what we require is more operational ocean observation systems which sustains and which is a part of the national infrastructure of many member states. So the theme and the session of this conference mirror the priorities of both the UN Decade, Ocean Science of Sustainable Development, and our national vision of science-driven blue economy. I'm very happy that many officials from IOC is available here, and it is actually marks, I think, how they are with us for making the Decade Ocean deliverables more ready and tangible. Importantly, the conference also looked how IOE2 and related efforts contribute to national and regional priorities, including the Sustainable Development Goals, the Deep Ocean Mission, coastal resilience initiatives, and broader agenda for the science for society. I also invite you to visit our facilities at INCOIS, where you can say where INCOIS, where ocean science serve the society, ocean science serve the humanity. So on behalf of INCOIS, I like to sincerely thank the Ministry of Earth Sciences for its guidance and support, the International Scientific Planning Committee for their leadership, IOC, UNESCO, SCORE, and IIOGOS, and all our partners for their collaboration, and each one of you for your commitment to the ocean science. Over the next 5 days, I hope this conference will deepen our scientific understanding of Indian Ocean as a coupled system, strengthen the partner across disciplines, institutions, and nations, inspire young scientists, take up challenging questions at the science-society interface and help shape a clear roadmap for Indian Ocean science and services up to 2030, fully aligned with the Ocean Decade and our national priorities. Let IIOSC 2025 stands in the spirit of our Prime Minister's message as a true celebration of science where knowledge, innovation, and collaboration come together for a healthier, safer, and more resilient Indian Ocean region. With these words, I once again extend very warm welcome all of you to INCOIS and IIOSC 2025. I wish the conference great success and fruitful deliberations. Thank you very much.
Thank you very much, sir, for your warm words of welcome. Next, we will hear a reflection on the decade of IIOE2 from Dr. Nick Dadamo. Dr. Dadamo is an adjunct research fellow, Oceans Institute of the University of Western Australia, with extensive experience in ocean governance, marine observation systems, and international coordination of ocean sciences. He has made significant contributions to the regional and global marine programs. His work often focuses on advancing collaborative ocean research, strengthening marine policy frameworks, and supporting sustainable ocean management initiatives. Through his association with University of Western Australia and various other international bodies, he plays a key role in fostering partnerships that enhance the scientific understanding and stewardship of marine ecosystems. He also plays a vital role as a coordinator of IIOE Project Office at University of Western Australia before it closed its operation. Presently, Dr. Dadamo is chairing Indo's Resource Forum, which is established to manage the resources of the Indian Ocean Observing System. Over to you, Dr. Dadamo.
Distinguished guests, if I could acknowledge you through Secretary Ravichandran and Director Bala, organisers, friends, young and younger. I'd like to talk about the IIOE2. Now, realising a multidisciplinary, multinational ocean science initiative of the magnitude of the second International Indian Ocean Expedition requires the passionate confluence of many aligned ocean scientists, managers, educators, users of the science, and their institutional hosts. During 2012 to 2015, an IIOE2 was transformed from a concept to a reality 50 years on from the original first IIOE of the 1960s. So I'd like to really just briefly touch on today on the history of the IIOE2 since 2011, and I'd like to thank Professor Lynn Beasley and Professor Raleigh Hood, who's not yet here, for their input to this talk. The green shoots of an IIOE2 started at the 2011 IMBA Science Conference when the SCORE Executive Director Ed Urban introduced the idea of celebrating the 50th anniversary of the first expedition, which occurred from 1959 to 1965. He then had the strong support of the SCORE president at the time, Peter Burkle, and of course SCORE has a long history in the International Indian Ocean Expedition, given its co-leadership with the IOC, the UNESCO IOC, of the first such expedition in 59 to 65. Since 2011, the following 3 years saw a convergence of interest and excitement from leaders and members of a family of collegiately integrated Indian Ocean Science Alliances. They plan not only for an IIOE celebration, but furthermore to realise a fully fledged return to the Indian Ocean in the form of an IIOE2. Now, those alliances were the Indian Ocean Global Ocean Observing System, or IIOGOOS, based here at INCOIS, and that's one of the many GOOS regional alliances that support the UNESCO IOC GOOS mission globally. The SCORE/IMBA alliance, known as Sustained Indian Ocean Biogeochemistry and Ecosystem Research, or CIBER, the CLIVA/IOC GOOS alliance, known as the Indian Ocean Region Panel, or IORP, addressing coupled oceanographic and atmospheric research, and overseeing the design and implementation of the Indian Ocean Observing System, or INDOOS, which was recently redesigned for this current decade as INDOOS 2.
And finally, the IIOSC-led Indian Ocean Observing System Resources Forum, or IRF. Now, Cyber co-chair Raleigh Hood was a key champion in planning the IIOE2, as was Lyneth Beckley, also from Cyber at the time. And Lyneth actually early on proposed what eventually became one of IIOE2's pioneering projects, a revisitation of the 110 East Line off Western Australia. In terms of overall coordination of the planning of the IIOE2, SCORE provided leadership and seed funding, along with IIOGOOS and the UNESCO IOC through its Perth office in Australia, which I ran at the time with the support of successive IOC Executive Secretaries Dr. Wendy Watson-Wright and Vladimir Ryabinin. Dr. Shailesh Nayak, who led IIOGOOS and the IRF at the time, was then also Secretary to the Indian Ministry of Earth Sciences, linking very closely to higher Indian government levels. Dr. Nayak made sure at the 2012 IIOGOOS meeting in Cape Town, South Africa, that IIOGOOS and its government-backed secretariat in India would work earnestly to support the IIOE2 planning process, together with SCORE at the executive level through Ed Urban and Peter Burkle, and along with Cyber, IRF, IORP, and the UNESCO IOC Perth office. Now, that Indian support, I'm very pleased to say, continues today through the current MOES Secretary, Dr. Ravichandran, who himself has a very long history in fundamental oceanographic research in the Indian Ocean. The MOES, or the Ministry of Earth Sciences India, support has been sequentially channeled through INCOIS's successive directors in Dr. Nayak, Dr. Satish Shenoy, Dr. Srivanasa Kumar, and Dr. Balakrishnan Nair, with great support from the staff here, led currently by Dr. Anish Lotlika, and before Anish, by our dear and departed friend, Dr. Satya Prakash. Now, given this early underlying support, what were the critical milestones in the three-year planning process? In 2013, Raleigh Hood and myself were tasked with writing a foundational prospectus for the IOE2, and that gained currency and was complemented by the personal commitment of many members from the underpinning family of alliances of IIOGOOS, Cyber, IRF, IORP, IOC, SCORE, and IIOGOOS. They then supported a three-year development of the IOE2's underpinning respective science plan and implementation strategy documents, which were released during the IOE2's launch in Goa on the 4th of December. And incidentally, I note Dr. Vinay here, who ran the first cruise of the IOE2 from Goa down to Mauritius, and that mimicked the actual first cruise of the original IIOE back in 1959. So that was a nice spiritual connection. So those two documents, the science plan and the implementation strategy, were formed through a series of so-called reference group meetings held respectively in India, China, and Mauritius, and that garnered the aspirations and developed key objectives for an IIOE2 according to stakeholders from the Southeast Asian, Northeast Asian, West Indian Ocean, and in fact the wider Indian Ocean regions. There were many other meetings held at universities, institutions, and opportunistically as part of conferences and workshops. Now, during this time, UNESCO IOC, SCORE, and IIOGOOS all resolved at the formal level to give their imprimaturs and support through in-kind and secretariat funding resources for an IIOE2 out to 2020. So that was the initial 5 years of the IIOE2. The science plan's multidisciplinary co-authorship was led by Raleigh Hood and invited the global community's scientific engagement in the IOE2 across 6 consolidating themes. 1, human benefits and impacts. 2, boundary current dynamics, upwelling variability and ecosystem impacts. 3, monsoon variability and ecosystem response. 4, circulation, climate variability and change. 5, extreme events and their impacts on ecosystems and human populations. And 6, unique geological, physical, biogeochemical and ecological features of the Indian Ocean. Now, to frame the community's operational engagement in the IOE2, the implementation strategy was developed under UNESCO IOC by a multidisciplinary team, but with links to both institutional and scientific stakeholders, and that was co-authored under the lead of Dr. Satish Shenoy. The essence of the of the implementation strategy was to frame an international steering committee, a set of working groups to support, the implementation of science, and a day-to-day secretariat as a joint project office with the respective nodes hosted by UNESCO IOC Perth Program Office and INCOIS here. The steering committee represents all contributing elements to the IOE2, with co-chairs from the three respective co-sponsors being UNESCO IOC, SCORE and IIOSC. The committee endorses projects aligning with the science plan's 6 themes. Its membership derives from key institutional stakeholders in Indian Ocean science, application, knowledge transfer, societal benefit, and also from the principal investigators of the IOE2's endorsed projects, and also from any IOE2 national committees that form to provide nationally coherent engagement in IOE2. And it's also got a place for the IOE2 Early Career Scientists Network. It meets annually with sub-elements free to liaise any time to collaborate or develop new ideas for projects and initiatives aligning with the science plan. So as I say, it's met annually, starting with its first meeting during the IOE2 launch in Goa in December 15, and I'd like to advertise the fact that the next annual meeting of the steering committee will be held in Korea, in Busan, next March, and we have our gracious hosts here through Professor Donjang DJ of IIOSC. That'll be our host in the 3rd week of March. And I hope we have a good gathering there, as we always have in the last few years. Now, the first 5 years of IOE2 saw the endorsement of many projects, including major cruises and the respective East and West Indian Ocean upwelling research initiatives. And for the Western component, we have the leader, Mike Roberts, here. Nice to see you again, Mike. And things were going along quite well in the first 5 years until COVID hit in early 2020. And that actually caused essentially a 1 to 2 year hiatus in many of the IOE2's activities. But pleasingly, the steering committee and project office elements survived. Now, in response to the many projects that were still on the books post-COVID, the IOE2 extended its tenure out to 2025. And even more recently, the IOE2 has extended out again to 2030 in recognition of the great amount of exciting reporting and scientific publishing that needs to be done on past and existing projects, and also in response to the planned endorsed activities penned for the next few years. We've also recently seen the advent of a formal UNESCO IOC subcommission for the Central Indian Ocean, as Dr. Bala mentioned, and which has the IO2 well rooted in its mantra. Furthermore, both Raleigh and I have recently respectively led the updating of the science plan and the implementation strategy out to 2030, with the updated science plan recently approved by SCORE and having some new enhanced foci such as human benefits, enhanced human benefits, climate change and related extreme events, coastal impacts in the context of food security and higher traffic levels, coastal observations through the CoLab initiative, that'll be well covered by Greg Cowie, who's here this week, underpinning science for marine spatial planning, a marginal seas research initiative, and a focus on greater understanding of the Eastern Bay of Bengal region. The one disappointing note that I can't help but mention is the unfortunate 2021 closure of the UNESCO IOC Perth office, not necessarily from a personal perspective, but due to the loss to the IOE2 of its embedded secretariat facility. Now, this was due to the cessation of support from the office's original 3 sponsors, and it's left the remaining INCOIS-based IOE2 project node to take on board a huge amount of added responsibility, for which we're very fortunate and extremely grateful. So I would just kindly and respectfully urge the new IOC Executive Secretary, Vidal Helgeson, to do all in his power to rework the matter with its original sponsors and champion a return for that strategic and operational support to the IOE2 to complement what our friends in India have kept going. On the other hand, and in closing, I'd like to refer to an article that Lyneth Beckley and I recently wrote to highlight IOE2's outputs up to 2024, in which we highlight that research vessels ranging from 35 to 135 metres in length have derived from 13 different countries so far: Australia, USA, France, Republic of Korea, Monaco, UK, South Africa, Kenya, India, Germany, Japan, Indonesia, Norway. Key scientific participants derived from over 30 countries in those pursuits. To 2024, there have been over 50 months of cruises involving contingents per cruise of up to 50 crew and 25 to 100 scientists on board, ranging from senior principal scientists to early career researchers, managers and high school students. Over 50% of the Indian Ocean has so far been traversed. The equivalent values for the research vessels involved in IOE2 so far and in the endorsed cruises range from 50 to 100,000 US dollars per day, and that value totals, the total value of those IIOE2 endorsed cruises based on vessel hire rates and scientific personnel salary equivalents has now reached to the order of $100 to $150 million. There are further research cruises penned for the IOE2's next 5 years, and furthermore, in respect to what those cruises unlock, each project involving a research cruise engages a large team of researchers and students in post-data analysis, scientific reporting, and presentation of results, often for the post-cruise periods of up to 5 years or more. And so on that note, I hope this leaves you with the same positive feeling that I have for a very successful third phase of the IOE2 out to 2030. Thank you.
Thank you, Dr. Nick Adamo, for the insightful reflections on the remarkable journey of IOE2. We now present a video message from Dr. Vidar Elkason, Executive Secretary of Intergovernmental Oceanographic Commission of UNESCO and Assistant Director General of UNESCO, to share his thoughts, a distinguished diplomat and environmental policy leader from Norway. Mr. Helgesen has previously served as a Norway Ministry of Climate and Environmental and Minister of European Affairs. He also held the position of Secretary General of the International Institute for Democracy and electoral position of Secretary General of the International Institute of Democracy and Electrical Assistance, IDEA. And prior to joining IOC, served as Executive Director of Nobel Foundation in Sweden, with extension experience in global ocean governance, sustainability, and international cooperation. Mr. Elkason leadership continues to inspire collaborative ocean actions. Under his guidance, the IOC is advancing goals of UN Decade of Ocean Science for Sustainable Development 2021 to 2030, fostering scientist-based solutions for resilient oceans and coastal communities.
Sådär.
Dear friends of the Indian Ocean and dear friends of the ocean, I'm delighted, albeit in virtual format, at the inaugural session of the International Indian Ocean Science Conference. And I'd like to appreciate and thank INCOIS and the Ministry of Earth Sciences for their dedication and their support for exploring and supporting the learning about our common ocean. The conference is going to highlight the scientific progress and the knowledge generated by the second International Indian Ocean Exploration. It's an opportunity to learn, and there is still so much we need to learn about the ocean. It's an opportunity to take stock, to identify knowledge gaps that continue to be there, and how we can move forward to filling them. And in that sense, this conference and the leadership role played by India in this context is really charting the course for what is needed at global scale to step up, to do more to observe the ocean, more to generate the necessary data that is important for ocean industries, for national ocean planning, for ocean protection, and also for preparing for new ocean hazards, preparing for disaster risk reduction, ensuring that we will have a productive ocean, but that we will also have safety on the ocean and by the ocean. And that is why getting that knowledge, researching that knowledge, sharing that knowledge is so important. I had the opportunity myself to visit INCOIS only a few weeks ago, looking at the tremendous information machinery that you have. Really impressive, really important, really setting a lesson to the world. And therefore, I'm sad not to be at this very conference, but I'm really happy about the strong partnership that we have between the IOC and INCOIS and indeed the Indian government. So thank you very much and best of luck with your conference.
We sincerely thank Dr. Helgeson for his encouraging words. We are now honored to welcome Dr. Sin Jae-yu, a distinguished biological oceanographer from Korea and senior research scientist at the Korea Institute of Science, Ocean Science and Technology, where he also serves as a professor at leading Korean universities. Dr. Yu completed his BS and MS in oceanography at Seoul National University and earned his PhD in ecology and evolution from the State University of New York at Stony Brook. His pioneering research on primary productivity, phytoplankton dynamics, and the ecological impacts on climate variability has resulted in over 70 peer-reviewed papers and several books, earning him international recognitions, including the Pisces Wooster Award. He has advised the Korean government, led many projects such as the Yellow Sea Large Marine Ecosystems, and contributed to global programs including IMBER, Pisces, IOCCG, Coastal Goose, and APN, notably serving as the chairman of the Pisces Science Board and as president of the Scientific Committee on Oceanic Research Core since 2020. Currently, he also serves as one of the co-chairs of the IIOE2 Steering Committee, fostering the collaborative ocean research across the Asia Pacific and beyond. May I now invite Dr. Sin Jae-yu to address the gathering.
Good morning. Please excuse my outfit. My suitcase is still on the road. Dear colleagues, this conference marks an important turning point for IIOE2. It signifies both the completion of the first 10 years since the project began and the start of the next 5 years, during which we hope the project will achieve all that it has set out to accomplish. Looking back over the past 65 years, our understanding of the Indian Ocean has grown tremendously. Yet, depending on one's perspective, our knowledge remains limited. While IIOE1 made major breakthroughs in shaping modern oceanography, there is still much more to learn about this vast and complex ocean. The addendum to the IIOE2 science plan has now been submitted and approved by the sponsors, SCORE, UNESCO, IOC, and IIOSC. It provides clear guidance for the project's direction over the next 5 years. On behalf of SCORE, I extend my sincere congratulations for what IIOE2 has achieved so far and for the important work that lies ahead in the coming years. I expect that many of the discussions during this meeting will help further refine the addendum and shape the course of IIOE2 for the next 5 years. This is going to be a very exciting week for all of us. Thank you.
Thank you, Dr. Sin Jae-yu, for your valuable perspectives. We will now hear a video message from Dr. Brett Maloney, Chairman, Indian Ocean Global Ocean Observing System, IIOSC. It's my honor to introduce Dr. Brett Maloney, Science Director of Environmental Business Unit at the Commonwealth Scientific and Industrial Research Organisation, CSIRO, Perth, Australia. With over 3 decades of experience in marine assurance and freshwater research across Australia and internationally, Dr. Maloney has published more than 50 scientific articles and 2 books and has been deeply engaged in advancing integrated aquaculture, risk and impact assessment, and sustainable coastal development. He completed his PhD at James Cook University and has held senior roles with the Department of Fisheries and the Secretary of the Pacific Community, contributing to fisheries science and management in both national and international contexts, a respected leader and communicator. He has advised governmental, collaborated with diverse stakeholders, and currently serves as a chairman of Indian Ocean Global Ocean Observing System, ICOS. Let us hear Dr. Maloney's message.
Hyderabad. I'm recording this on the Wajak lands of the Noongar Nation here in Boorloo, or Perth, Western Australia. Unfortunately, I'm unable to attend this year's IIOSC due to other commitments, which include ocean science at the national level. I look forward to the summaries and any outcomes of the IIOSC, and I will miss the discussions. I'll start by thanking the local organising committee for the conference and the earlier workshops and all the other activities that you'll be attending this week. I know all attendees from across the Indian Ocean Basin and beyond appreciate your planning and organising efforts, and especially at your wonderful site in Hyderabad in India. I encourage all to make the most of this face-to-face time to have deeper conversations, and especially for our next generation of scientists, our EMCRs. While we are focusing on basin scale science, I encourage all to think about the rapidly changing world we're living in. This is not only changes in geopolitics and economics, but the existential threat of climate change and the many impacts on our oceans, land, and people across the globe. In our oceans, this is more than ocean warming and heat content. It includes changes to current strength and circulation, sea level rise, decreases in oxygen content, changes in pH, changes in solubility, ocean productivity, and many others. And these changes are not just limited to our oceans and coasts. Changes are also occurring in rainfall patterns and distributions. Record rainfall and flood events are more common in some areas, and longer fire seasons are recorded in others. These all put human lives and infrastructure under a threat. And there is more to come. Climate modelling and monitoring has shown increases in CO2, which have now exceeded 420 parts per million, with other greenhouse gases like methane also increasing. We are clearly living in times beyond our data. And society is looking at scientists, engineers and technologists, us, for solutions. We need to move beyond describing systems and problems towards creating and testing solutions for all, a pathway to impact to solution. I challenge and encourage all to think about what our governments, industries and societies need in order to address and solve these challenges and focus our efforts towards them. I wish all of you successful and productive weeks and encourage you to reflect on how your scientific endeavours are assisting in addressing these challenges. I also encourage you to stop and enjoy the beauty and hospitality of Hyderabad and India. Thank you all, and wishing you all a safe and happy end of 2025 and best wishes for 2026. Bye.
We appreciate Dr. Maloney's message and continued support. We are now honored to invite Dr. Jenny Huggett, Specialist Scientist and the Head of Biological Oceanography in the Oceans and Coasts Branch of South Africa's Department of Forestry, Fisheries and Environment, and esteemed officer of the Indian Ocean Global Ocean Observing System, with her distinguished leadership in marine ecosystem research, particularly zooplankton ecology and ocean variability, and her active role in advancing international collaborations across the Indian Ocean region. Dr. Huggett has made remarkable contributions to the ocean science. May I now warmly welcome Dr. Jenny Huggett to deliver her address.
Greetings, everyone. It's an honor to be here, and I think many of you are surprised as me to find myself on the stage this morning. although my career as a biological oceanographer has been anchored in Cape Town at the tip of Africa and the cold Benguela current upwelling system, my love of the Indian Ocean was sparked by my many childhood holidays along the eastern shores of our KwaZulu-Natal coast, and where I used to collect empty ice cream containers, fill them with shells from all along the shore, and washed up coral and seaweed and things like that, returning home with very smelly boxes. Then I had diving holidays off Sodwana and in the Maldives, which further instilled my love for all the creatures of the Indian Ocean. Then I had my first research cruise in the Indian Ocean, thanks to Mike Roberts in 2004 off the coast of Mozambique. And then in about 2013, I gate crashed a cyber meeting in Cape Town, maybe it was 2012, and I was very fortunate to be invited to join this wonderful group of people who, as you've heard from Nick, have been instrumental, led by Riley Hurd in particular, in developing the vision that led to this second International Indian Ocean, which we're here to celebrate 10 years of today. Since about 2019, I've been the cyber representative for IIOSC, and found myself not long after that organizing a workshop on biological ocean observations, and supported by Eileen Tan Chawai from Malaysia. So our focus was on essential ocean variables as lined out by GOOS, the Global Ocean Observation System, and also essential biological biodiversity variables. So we looked at the standard protocols for measuring these, from microbes and plankton to seagrass, coral, mangrove habitats, fish, turtle, seabirds, and marine mammals. And many people contributed willingly their expertise and time to this lovely workshop. And I was amazed by the advances in technology in so many areas in these measurements, from drone footage to estimate seagrass cover, acoustic telemetry tracking fish movements, and then moving on to eDNA and metabar coding of zooplankton to assess biodiversity. And that's an approach that I'm very much supporting myself with my colleague here who's from Durban, the Oceanographic Research Institute, and we'd love to chat to you more about that for your region. But you don't necessarily need the latest technology for observations. The main thing is to get out there to make repeatable measurements with whatever you have to hand. And also, as Nick alluded to, a great initiative that's being led by Greg Cowie is this CoLab, or Coastal Observation in a Box. So that's developing affordable, standardized tools and training for coastal monitoring in areas that are data scarce. So, and also echoing Brett, in this time of accelerating climate variability, ocean observations are more important than ever. So please encourage all your teams, and especially you, the early career scientists, please familiarize yourselves with the GOOS EOVs and EBVs, and they're in the process of being updated at the moment. They're going to be supported by further links to useful references and all the best standard operating protocols. And so please get out there, carry on sampling, carry on observing. Thank you very much.
Thank you, Dr. Jenny Haggard. It is now time for release of the abstract volume. May we request our dignitaries to kindly come forward and release the volume.
This volume represents the collective scientific contributions of the IIOE2 community. I thank all the dignitaries for doing the honor. We are privileged to have Dr. T. Srinivas Kumar, Head of UNESCO Intergovernmental Oceanography Commission, Secretariat of the Indian Ocean Tsunami Warning and Mitigation Systems, as our guest of honor. As experienced ocean scientists with over 25 years of expertise in ocean observations, marine information services, and disaster early warning systems, Dr. Kumar has held senior positions at ISRO, INCOIS, and IOC UNESCO, and served as the director of INCOIS Hyderabad as he established India's world-class Tsunami Early Warning Center and led national flagship initiatives, including potential fishing zone advisory, coral reef bleaching alerts, multi-hazard vulnerability mapping. Internationally, he has strengthened regional tsunami warning systems in collaboration with 28 member states, served as the Vice Chair of IOC UNESCO, chaired IIOSC, and represented India on several high-profile intergovernmental committees. Recipient of prestigious honors such as the National Geoscience Award, Dr. Kumar is widely recognized for his contributions to remote sensing, disaster risk reduction, and marine resource management, with over 70 scientific publications and multiple book chapters to his credit. I now invite Dr. T. Srinivas Kumar to deliver his address.
Thank you, Elaine, for the very generous introduction. Good morning, colleagues. So after hearing two talks so nicely, eloquently, Nick especially, and Bala and all, Sinjay and Jenny, they spoke already, and then I see that most of my speech has gone out of the window already. So if you hear me telling something that is repetitive, please take it as a fact that we are telling you the truth, and then it's just a validation. Okay, so about 65 years ago, Nick mentioned this actually, the first IIOE2 was one of the largest multinational and multidisciplinary oceanographic research efforts ever undertaken. And it transformed really our understanding of the Indian Ocean and set a benchmark for global scientific collaboration. And then IOC, which actually was established in 1960, at about that time the IIOE2 started, it actually took the management of the IIOE1, from SCORE, and then ran the program until it concluded in 1965. And then IIOE1, for those of you who haven't heard about the history of it, how it impacted, what the impact of it in India, it led to the, creation of the CSIR National Institute of Oceanography. We have friends here from NIO attending today. You have been there in 2015 during the launch of IIOE2. So that was established after the IIOE1. And so today, as we inaugurate the IIOSC, we celebrate a decade of IIOE2, which started in 2015. And I think we reaffirm our shared commitment to enhancing knowledge, resilience, and sustainability in this Indian Ocean region. Saying so, I'm also very deeply honored to join you as a guest of honor. And then let me extend my warm greetings to Dr. M. Ravichandran, Secretary of the Ministry of Earth Sciences, our senior colleague, Dr. T.M. Balakrishnan Nair, Director of INCOIS, my beloved colleague again. And then we have colleagues from UNESCO IOC, Vidar, who joined us online, from SCORE, IIOSC, IOC Indio, colleagues from across several institutions in India and abroad. So let me wish a very warm welcome to all of you. Let me take a moment here. I think it's important to recognize the efforts of Nick Dadamo and Dr. Ravichandran, who played a very pivotal role, along with several of you sitting in the room, in actually advancing several activities that we do currently in the Indian Ocean region, be it the Indian Ocean Observing Systems, the INDOOS, the Indian Ocean Research Regional Panel, the INDOOS Resource Forum, which you have heard earlier from Nick. So these all strengthen ocean observation capacities and regional collaboration capacity building across the Indian Ocean region. And I also acknowledge, presence of Sinjay, our colleague from SCORE, Brett from IIOSC, and several other colleagues here. Now, the Indian Ocean is home to 2.7 billion people, mostly developing countries, whose lives and livelihoods depend on its health. And the second IIOE2 was launched in Goa, marking 50 years of IIOE1 initially planned, like Nick mentioned, until 2020, but then now we are extending until 2030. We have had 63 endorsed projects, 17 international research cruises, and then a very vibrant early career scientist network. We see several young colleagues here who have been part of this process since 2015. And this conference is flagship, actually. This is the third version of it, and you again heard that we've had the first one in 2015, but the second one, again hosted by INCOIS, had to go online because of COVID. But then it was very well attended when we actually hosted this online in 2020. Several of you participated. So this is an opportunity again, I think, for all of us to showcase what we have done in IIOE2 for the past 10 years, and then what are our directions going to be for the next 5 years. From a very personal perspective, for me, this moment is deeply, personal, I would say, because during my tenure at INCOIS, as Elaine mentioned, for long years I worked with INCOIS. I had the privilege of hosting the IIOSC Secretariat. It continues to host the Secretariat. It actually hosts the IIOE2 International Project Office. It also supports various activities of the Secretariats related to the Industry Resource Forum and so on and so forth. And I think, INCOIS, I think should be thanked for its contribution, and the Ministry of Earth Sciences for its contribution to the IIOE2 and the broader activities that it supports. As we look ahead, I think IIOE2 until 2030, it's very essential. Again, what we see in the revised science plan that has been put together in a meeting last year. Several of you were here again in 2024, February, when INCOIS celebrated the 25 years, and then it was followed up by a back-to-back meeting on the planning of what IIOE2 should look like until 2030. And then coastal research and modeling, human impacts, marine spatial planning, greater engagement in the Western Indian Ocean region, the marginal seas and the Eastern Bay of Bengal, and enhanced capacity development. I think all of these things have come up as a big focus, which we need to really continue to work on. And the newly established IOC Indio, it is a new subcommission. It used to be a subcommittee under the IOC. That actually is now a subcommission. It's actually, there's a side event which Bala is hosting. It'll be good for all of us to participate and see how we can really integrate a lot of these efforts, which are very active efforts that have been going on for several decades, into how this IOC Indio platform can really help us move things forward in a much active way. I think we should continue to invest in observations, modeling, forecasting, link it to operational services as much as we can, continue to undertake the exciting science that we have been doing, and then invest in digital ecosystems for ocean data and services, build capacities across member states. So from the IOC perspective, let me say, in my role with the IOC and the IoT-WMS, I can clearly see how IIOE2 and IIOSC have been contributing and can contribute to IOC programs related to the ocean observations, the GOOSE, which is currently undergoing a governance reform, and then the major, the end-to-end value chains that it is trying to bring into the entire conversation about how the observations can link to societal services and so forth, and the data management systems, and the tsunami early warning and the other hazard early warning systems, and capacity building and so forth. So it contributes end-to-end to every facet of what IOC UNESCO does. So it's very important for us to leverage upon the IIOE2 and then see how we can contribute to all of these activities, and then moving forward, of course, to the all the 6 ocean decade outcomes. Vidar spoke about this in his speech. So in closing, let me just say that IIOSC 2025, this event is not just a celebration of our past achievements, but let us make it a call to action on how we will work together in the next 5 years and beyond. How actually this collegial group can really contribute to sustainable ocean planning and management going forward. So let me thank once again, all of you for being here, and then please enjoy the conference itself, and then enjoy a bit of Hyderabad while you're here, and look forward to the conversations. Thank you very much.
Thank you, Dr. Srinivasakumar, for your inspiring words. May we now request our chief guest, Dr. M. Ravichandran, Secretary MOS, to deliver the inaugural address. Dr. M. Ravichandran, Secretary, Ministry of Earth Science, Government of India, is renowned oceanographer with over 3 decades of experience in polar science, ocean observation, and climate research. Dr. Ravichandran was associated with INCOIS for about 16 years prior to assuming his role as a Secretary, Ministry of Earth Science. He was Director of the National Center for Polar and Ocean Research in Goa. Dr. Ravichandran has been instrumental in advancing India's ocean and climate programs, fostering international collaboration and promoting science-based solutions for sustainable ocean management and disaster resilience.
Namaskar. Distinguished delegates on the dais, of the dais, Indian Ocean science enthusiasts, young early career scientists, engineers, and other invitees, my colleagues from INCOIS and Ministry of Earth Sciences. Very good morning to all of you. It is indeed a great pleasure to be here as part of this important conference. I know that last conference was in online, and this one, finally, we are able to meet together and see and try to see what are the things we have done and what we need to do. Of course, all of you know that Indian Ocean is a home for roughly about 1/3 of the population. I think all around the Indian Ocean rim countries are hugely affected or benefited from the Indian Ocean region. Mainly it depends on the monsoon, or you can take global climate system or fisheries, or some of the important trade routes or coastal livelihood and so on. Still, I think 2-3 decades before, the Indian Ocean was highly underobserved. First of all, because the country around the Indian Ocean rim countries were not put in money in the ocean observation and many other things. And also it is considered this is a passive ocean, not it's active as we know now. So hence it was not very well understood, not put many observations. But now maybe the IIOE2 and other observing system put in place, we are able to understand many more things what is going on. Of course, what we learned is little. Indian Ocean is warming rapidly, and there are rapid changes is happening. One is a warming, of course, the tropical ocean, the warmest tropical ocean region, and also the sea level rise, and the expansion of oxygen minimum zone, and its effect to deep sea ecosystem and ecology, and sea level rise, and so many things are happening. Still, what we need to understand is, I think, the observing system. I think over the period, maybe last 5 years or so, I personally feel that the observing system is going on declining when compared to earlier years. Maybe earlier means maybe in 2002 it is picked up, then it has gone some level, then again it is coming down. Maybe it is due to the maybe geopolitical reason or whatever may be the things. But we as India, we largely benefited from the observation, not only from in situ, but also in the satellite observations. Because of this observation only, we have able to make it the monsoon forecast from the statistical to dynamical forecast, and we largely benefited because of the very good forecast of monsoon, seasonal forecast of monsoon, and sub-seasonal time scale and all other things. So I think the importance of observation we felt, I think we need to continue these observations in the coming years. And another important thing is, of course, the region. I think as I mentioned that it is what is called the livelihood mainly depends on various aspects of the ocean. I think the blue economy, it is a $1 trillion economy we need to harness sustainably. For that, what we need to understand, what we need to put a technology, or what are the new things we need to do, that all we need to put in place so that we can harness the blue economy component of the ocean sustainably. Of course, we need to have a science-based responsible exploitation or whatever the resource we want to generate. And also we need to have a data-driven resource management plan. For that, we need to have more and more observations and new technology and science and data. I think this basin-wide observing system is so important. It is not only for the particular nation, but the entire region and the global region. It is very important. We need to have a very good data sharing mechanism to have more and more understanding. And also we need to develop, or we have to make a new technique, not only technology, but also new technique like various, if data is available, various AML and other tools, maybe digital twin and other things we need to utilize so that we can reach the importance of the ocean resources and other things to the common man. And also it is imperative that we need to expand the observing system in biogeochemical what is called observations. It is very minimum. I think it is, the ecosystem also is very important. I think we need to have more and more augmentation of observation in the biogeochemical sensors and instrumentations. And also we need to develop, because the ocean also not only resource it is providing, but also it is having various hazards, oceanic hazard like cyclone or tsunami or maybe marine heat wave, harmful algal bloom and many other things. I think we need to develop an integrated multi-hazard warning system to have cater to all the countries in the Indian Ocean. I think it is not only for tsunami, but all the things we need to have a collective mechanism how we can do some early warning for entire Indian Ocean rim countries. And also we need to have the biodiversity. The biodiversity what exists in Indian Ocean, either hotspot or anything, we don't know much. I think we need to have put more effort on mapping the biodiversity and where are the hotspots lies, and how to protect various mangroves or seagrass or maybe many other things we need to protect. And also how do we see that marine litters and various forms of microplastic and various sizes, how we can prevent. And also we need to have of course, each country is planning for global ambition of 30 by 30 marine protected area. How we can ensure that goal, how do we make it? So that also we need to think about certain aspects, because also now the BBNJ also is coming out. And most importantly, the capacity building and training is more important. Because I remember that earlier years, people go to sea, but nowadays most of the oceanographers are become desktop oceanographer or computer oceanographer, not mainly going to the ocean and see what is happening. I learned oceanography not from the textbooks, only from the ocean, most of the cruises. But I'm not finding many of the people now going to the ocean to understand the ocean, to talk to the ocean, to enjoy the ocean. That is missing. I think we need to, especially youngsters, need to come forward to venture into the ocean so that you can understand much more. For that, I think various groups like whatever format, IIOSC or IIOE3 or maybe IOR, Indian Ocean Rim Association, or many other Clivar forms and other people, they have to make some mechanism to have a continuous training. And when you are taking a ship, take all around the countries to involve them so that we can learn from each other. Everybody is having some knowledge. I think we need to tap that knowledge from them. For that, I think we need to have a collective mechanism on joint cruises or expedition. That is very important. And finally, of course, we need to develop an Indian Ocean knowledge hub in the basin-wide, how the health of the ocean is there in different aspects, either physical or chemical, biological, how the ocean behaves and what is the health record of Indian Ocean. We need to make a record. And definitely we need to contribute. Of course, we are in the midway of the decade of the ocean science. For that, how we can contribute to the decade of the ocean science. And so that one, after all, ocean is one ocean, not only Indian Ocean, but we need to have a globally how we can contribute to the various aspects. We need to think about it. And finally, we need to have, of course, I always think that we need to observe, not only for understanding the process, but also assimilate that for better initial condition for the various models. And we need to innovate more and more from the ocean. And we need to strengthen our collaboration, not only within the institute, within the country, country to country. So we need to have more and more collaboration. Finally, we need to aim towards various science and services. How do we do science, and that service, science, how we can translate to the services for the benefit of society. That should be the ultimate goal of our future. In that endeavor, I think there was a Indus Forum, as Nick already mentioned, that there was Indus Forum for the IIOSC and other things. But I am seeing that though it is there, but it is not active. I think it is imperative that we need to activate that more. We have to more energy and other things we need to do, because under the geopolitical scenario, we cannot depend on one country. We need to collectively contribute so that we can have a better observing systems. In India, we have two important missions we have announced recently. One is the Deep Ocean Mission, and wherein we want to have a technology and various observation component, as well as various living and non-living resources mapping, and also energy and water and biology component, all in Deep Ocean Mission it is embedded. And the next 5 years, maybe in 2026, April to next 5 years, we will be augmenting more vigorously on this Deep Ocean Mission. I think it is not only for India specific. I think we want to call all the countries around anywhere in the globe to contribute to the ocean understanding, not only Indian Ocean, in the global ocean understanding, and what are the science we require, what are the technology required, what are the services are required for the humanity. That's what we are looking at it. I think I request all of you to join in this endeavor to make that mission successful. Also, we have started another mission, is called Mission Mausam, that is Mission Weather. So in that Mission Weather also, part of the component belongs to the ocean. So what are under the Mission Mausam, what we need to observe, not only in situ observing system, but also in the satellite. What are the satellites we need to deploy for understanding the ocean, as well as various atmospheric phenomena and various other things we are planning. I think in that endeavor, I look forward, many of the people, maybe we will be sending out the proposals, call for the proposals. Those who like to work, join together collaboratively. It is not only national, it is international. Come together, join together, and come forward with the innovative ideas so that we will be working together for the benefit of common man. I think IIOE has brought out many of the interesting science, but I think we need to accelerate much more in the coming years. I think together, all of us, we will be definitely making significant progress in the coming years for doing science in the Indian Ocean, but also totally in the global ocean. I am sure this conference will have a great success, and at the end of the conference, you will come out with some of the implementable recommendations so that we will dwell upon in the coming years. With this, I once again welcome you all to this INCOIS and this conference, and thank you for participating. Thank you very much.
Thank you, sir, for your visionary guidance. We now move on to our customary tradition of felicitation of our dignitaries. I now request Dr. T. M. Balakrishnan Nair, Director INCOIS, to felicitate the dignitaries. I first request Dr. Jenny Haggett, the Specialist Scientist and Head, Biological Oceanography, Oceans and Coasts of South Africa, Department of Forestry, Fisheries and Environment, and IIOSC Officer.
Me.
Yeah, after you finish.
Next, Dr. Nick Dadamo, Adjunct Research Fellow, Ocean Institute of Industry of Western Australia. Kindly come forward.
I request Dr. Sinjay Yu, the representative for the Scientific Committee of Oceanic Research, to come forward and receive the memento and shawl.
Now, Dr. Srinivasa Kumar, Head UNESCO IIOSC Secretariat for the IoT Developers, our guest of honor, kindly come forward and receive the token of gratitude.
I request our chief guest, Dr. M. Ravichandran, Secretary, Ministry of Earth Sciences, to come forward and receive the appreciation. Thank you, sir.
Thank you, Balakrishnan Nair, Director INCOIS. We express our heartfelt gratitude to all the dignitaries for gracing this occasion. As we draw the inauguration session to close, may I request Dr. Anish Ratlikar, Coordinator, IOE2 Project Office, to deliver the vote of thanks.
So, respected dignitaries on the dais and the distinguished guests, on behalf of INCOIS, IIOE2 Project Office and the Organizing Committee, it is my privilege and honor to propose this vote of thanks. First and foremost, we'd like to extend our heartfelt gratitude to our chief guest, Dr. M. Ravichandran, Secretary, Ministry of Earth Sciences, for gracing this occasion and inspiring us with the words of encouragement. His visionary leadership and inspiring address set the tone for this conference. Sincere thanks to our guest of honor, Dr. T. Srinivas Kumar, Head of UNESCO IoT WMS, for his valuable presence and mentioning the influence of the ocean value chain and the need for the sustainable ocean management. A special word of appreciation to Dr. T.M. Balakrishnan Nair, Director INCOIS, and our local host for his tireless efforts and commitment in making this event possible. We're deeply honored by the message from Mr. Vidar Elkson, Executive Secretary of IOC UNESCO, who could not join us in person but shared his valuable thoughts through a video message, reinforcing the importance of the global cooperation in ocean science. Similarly, we thank Dr. Brett Maloney, Science Director at CSIRO Environment and Chair of IIOGOOS, for his insightful video message and highlighted the significance of regional partnership and scientific innovation. A special thanks to Dr. Jenny Haggett, Scientist and Head Biological Oceanography, Oceans and Coast, Department of Forestry, Fisheries and Environment, and also an IIOGOOS officer, for gracing the occasion with her esteemed presence. Our gratitude also goes to Dr. Shin Jae-yu from Korean Institute of Ocean Science and Technology and representing Scientific Committee on Ocean Research, that's SCORE, for his presence and contribution to advancing the ocean science. A special mention to Dr. Nick Damo, who has been with the IOE2 since its inception and for providing a thoughtful reflection on a decade of IOE2, reminding us of the progress made and the future road ahead. We acknowledge with appreciation the International Scientific Planning Committee, comprising of the chairs of the working group and science teams of IOE2 for their meticulous planning for this conference. Our thanks also goes to National Organizing Committee, which comprises of the directors of all the institutes under Ministry of Earth Sciences and leading oceanographers from India. Their guidance and expertise have been instrumental in shaping this conference. A special thanks to session conveners for their time and efforts for reviewing the abstracts and planning the sessions. Also to the session coordinators who will be ensuring the seamless execution during the session. We are grateful to IIOGOOS and SCORE for providing financial support for international early career scientists, and also to the Ministry of Earth Sciences for providing early career scientist funding, ensuring that young researchers have the opportunity to participate and contribute. Our sincere thanks to the sponsors from government and government agencies and PSU, like MOES, NCPOR, CMLRE, FSI, NCMR, WF, IITM, NCES, NCCR, ISRO, NFDB, State Bank of India, and also from private industries, HP, Spray Technocon Private Limited, Pan India Consultants Private Limited, Samhita Marine, Campbell Scientific, Tidal Technologies, DTP Envirotech Solutions, Swan Environmental Private Limited, Business Octave, and AFCONS for their generous contributions, which have been vital in making this event a reality. Finally, we recognize the efforts of the Internal Implementation Committee, chaired by Sri Pattabi Ramarao, Group Director, INCOIS, and the leads and members of all the subcommittees in various departments. The list is huge, so I may not be able to name everyone, but this is the fourth event INCOIS is organizing in less than a month's time, and there have been more than 250 individuals working tirelessly across various departments. Their commitment and teamwork deserves our deepest appreciation. A special appreciation to our event manager who ensured the seamless coordination and execution of every detail, making this event truly memorable. We wish you all a very highly productive and insightful conference filled with invaluable opportunities for collaboration and knowledge sharing, and hope you make most of your time in this vibrant city of pearls, it is Hyderabad, known for its Royal Nizam's heritage to its modern identity as a global high-tech hub, and of course, the world-famous biryani. Thank you.
May we now request our Chief Guest, Dr. M. Ravichandran, Secretary MOS, to deliver the inaugural address. Dr. M. Ravichandran, Secretary, Ministry of Earth Science, Government of India, is renowned oceanographer with over 3 decades of experience in polar science, ocean observation, and climate research. Dr. Ravichandran was associated with INCOIS for about 16 years prior to assuming his role as a Secretary, Ministry of Earth Science. He was Director of the National Center for Polar and Ocean Research in Goa. Dr. Ravichandran has been instrumental in advancing India's ocean and climate programs, fostering international collaboration and promoting science-based solutions for sustainable ocean management and disaster resilience.
Namaskar. Distinguished delegates on the dais, of the dais, Indian Ocean science enthusiasts, young early career scientists, engineers, and other invitees, my colleagues from INCOIS and Ministry of Earth Sciences. Very good morning to all of you. It is indeed a great pleasure to be here as part of this important conference. I know that last conference was in online, and this one, finally, we are able to meet together and see and try to see what are the things we have done and what we need to do. Of course, all of you know that Indian Ocean is a home for roughly about 1/3 of the population. I think all around the Indian Ocean rim countries are hugely affected or benefited from the Indian Ocean region. Mainly it depends on the monsoon, or you can take global climate system or fisheries, or some of the important trade routes or coastal livelihood and so on. Still, I think 2-3 decades before, the Indian Ocean was highly underobserved. First of all, because the country around the Indian Ocean rim countries were not put in money in the ocean observation and many other things. And also it is considered this is a passive ocean, not it's active, as we know now. So hence it was not very well understood, not put many observations. But now maybe the IIOE 2 and other observing system put in place, we are able to understand many more things what is going on. Of course, what we learned is little. Indian Ocean is warming rapidly, and there are rapid changes is happening. One is a warming, of course, the tropical ocean, the warmest tropical ocean region, and also the sea level rise, and the expansion of oxygen minimum zone, and its effect to deep sea ecosystem and ecology, and sea level rise, and so many things are happening. Still, what we need to understand is, I think, the observing system. I think over the period, maybe last 5 years or so, I personally feel that the observing system is going on declining when compared to earlier years. Maybe earlier means maybe in 2002 it is picked up, then it has gone some level, then again it is slowly, it is coming down. Maybe it is due to the maybe geopolitical reason or whatever may be the things. But we as India, we largely benefited from the observation, not only from in situ, but also in the satellite observations. Because of this observation only, we have able to make it the monsoon forecast from the statistical to dynamical forecast, and we largely benefited because of the very good forecast of monsoon, seasonal forecast of monsoon, and sub-seasonal time scale and all other things. So I think the importance of observation we felt, I think we need to continue these observations in the coming years. And another important thing is, of course, the region. I think, as I mentioned, that it is what is called the livelihood mainly depends on various aspects of the ocean. I think the blue economy, it is a $1 trillion economy we need to harness sustainably. For that, what we need to understand, what we need to put a technology, or what are the new things we need to do, that all we need to put in place so that we can harness the blue economy component of the ocean sustainably. Of course, we need to have a science-based responsible exploitation or whatever the resource we want to generate. And also we need to have a data-driven resource management plan. For that, we need to have more and more observations and new technology and science and data. I think this basin-wide observing system is so important. It is not only for the particular nation, but the entire region and the global region. It is very important. We need to have a very good data sharing mechanism to have more and more understanding. And also we need to develop, or we have to make a new technique, not only technology, but also new technique like various, if data is available, various AML and other tools, maybe digital twin and other things we need to utilize so that we can reach the importance of the ocean resources and other things to the common man. And also it is imperative that we need to expand the observing system in biogeochemical, what is called observations. It is very minimum. I think it is, the ecosystem also is very important. I think we need to have more and more augmentation of observation in the biogeochemical sensors and instrumentations. And also we need to develop, because the ocean also not only resource it is providing, but also it is having various hazards, oceanic hazard like cyclone or tsunami or maybe marine heat wave, harmful algal bloom, and many other things. I think we need to develop an integrated multi-hazard warning system to have cater to all the countries in the Indian Ocean. I think it is not only for tsunami, but all the things we need to have a collective mechanism how we can do some early warning for entire Indian Ocean rim countries. And also we need to have the biodiversity. The biodiversity, what exists in Indian Ocean, either hotspot or anything, we don't know much. I think we need to have put more effort on mapping the biodiversity and where are the hotspots lies, and how to protect various mangroves or seagrass or maybe many other things we need to protect. And also how do we see that marine litters and various forms of microplastic and various sizes, how we can prevent. And also we need to have, of course, each country is planning for global ambition of 30 by 30 marine protected area, how we can ensure that goal, how do we make it, so that also we need to think about certain aspects, because also now the BBNJ also is coming out. And most importantly, the capacity building and training is more important. Because I remember that earlier years, people go to sea, but nowadays most of the oceanographers are become desktop oceanographer or computer oceanographer, not mainly going to the ocean and see what is happening. I learned oceanography not from the textbooks, only from the ocean, most of the cruises. But I'm not finding many of the people now going to the ocean, to understand the ocean, to talk to the ocean, to enjoy the ocean. That is missing. I think we need to, especially youngsters, need to come forward to venture into the ocean so that you can understand much more. For that, I think various groups like whatever format, IIOSC or IIOE3 or maybe IOR, Indian Ocean Rim Association, or many other CLIVAR forums and other people, they have to make some mechanism to have a continuous training, and when you are taking a ship, take all around the countries to involve them so that we can learn from each other. Everybody is having some knowledge. I think we need to tap that knowledge from them. For that, I think we need to have a collective mechanism on joint cruises or expedition. That is very important. And finally, of course, we need to develop an Indian Ocean knowledge hub in the basin-wide, how the health of the ocean is there in different aspects, either physical or chemical, biological, how the ocean behaves, and what is the health record of Indian Ocean. We need to make a record, and definitely we need to contribute. Of course, we are in the midway of the decade of the ocean science. For that, how we can contribute to the decade of the ocean science, and so that after all, ocean is one ocean, not only Indian Ocean, but we need to have a globally how we can contribute to the various aspects. We need to think about it. And finally, we need to have, of course, I always think that we need to observe, not only for understanding the process, but also assimilate that for better initial condition for the various models. And we need to innovate more and more from the ocean. And we need to strengthen our collaboration, not only within the institute, within the country, country to country. So we need to have more and more collaboration. Finally, we need to aim towards various science and services. How do we do science? And that service, science, how we can translate to the services for the benefit of society. That should be the ultimate goal of our future. In that endeavor, I think there was a Indus Forum, as Nick already mentioned that there was Indus Forum for the IIOSC and other things. But I am seeing that though it is there, but it is not active. I think it is imperative that we need to activate that more. We have to more energy and other things we need to do, because under the geopolitical scenario, we cannot depend on one country. We need to collectively contribute so that we can have a better observing systems. In India, we have two important missions we have announced recently. One is the Deep Ocean Mission, and wherein we want to have a technology and various observation component, as well as various living and non-living resources mapping, and also energy and water and biology component, all in Deep Ocean Mission it is embedded. And the next 5 years, maybe in 2026, April to next 5 years, we will be augmenting more vigorously on this Deep Ocean Mission. I think it is not only for India specific. I think we want to call all the countries around anywhere in the globe to contribute to the ocean understanding, not only Indian Ocean, in the global ocean understanding, and what are the science we require, what are the technology required, what are the services are required for the humanity. That's what we are looking at it. I think I request all of you to join in this endeavor to make that mission successful. Also, we have started another mission, is called Mission Mausam, that is Mission Weather. So in that Mission Weather also, part of the component belongs to the ocean. So what are under the Mission Mausam, what we need to observe, not only in situ observing system, but also in the satellite. What are the satellites we need to deploy for understanding the ocean, as well as various atmospheric phenomena and various other things we are planning. I think in that endeavor, I look forward many of the people, maybe we will be sending out the proposals, call for the proposals. Those who like to work, join together collaboratively. It is not only national, it is international. Come together, join together, and come forward with the innovative ideas so that we will be working together for the benefit of common man. I think IIOE has brought out many of the interesting science, but I think we need to accelerate much more in the coming years. I think together, all of us, we will be definitely making a significant progress in the coming years for doing science in the Indian Ocean, but also totally in the global ocean. I am sure this conference will have a great success, and at the end of the conference, you will come out with some of the implementable recommendations so that we will dwell upon in the coming years. With this, I once again welcome you all to this INCOIS and this conference, and thank you for participating. Thank you very much.
Thank you, sir, for your visionary guidance. We now move on to our customary tradition of felicitation of our dignitaries. I now request Dr. T.M. Balakrishnan Nair, Director INCOIS, to felicitate the dignitaries. I first request Dr. Jenny Haggett, the Specialist Scientist and Head, Biological Oceanography, Oceans and Coasts of South Africa, Department of Forestry, Fisheries and Environment and IIOSC Officer.
Me.
Yeah, after you finish.
Next, Dr. Nick Dadamo, Adjunct Research Fellow, Ocean Institute of Ministry of Western Australia. Kindly come forward.
I request Dr. Sinjay Yu, the representative for the Scientific Committee of Oceanic Research, to come forward and receive the memento and shawl.
Now, Dr. Srinivasa Head UNESCO IIOSC Secretariat for the IoT Developers, our guest of honor, kindly come forward and receive the token of gratitude.
I request our chief guest, Dr. M. Ravichandran, Secretary, Ministry of Earth Sciences, to come forward and receive the appreciation. Thank you, sir.
Thank you, Balakrishnan Nair, Director INCOIS. We express our heartfelt gratitude to all the dignitaries for gracing this occasion. As we draw the inauguration session to close, may I request Dr. Anish Ratlikar, Coordinator, IOE2 Project Office, to deliver the vote of thanks.
So, respected dignitaries on the dais and the distinguished guests, on behalf of INCOIS, IIOE2 Project Office and the organizing committee, it is my privilege and honor to propose this vote of thanks. First and foremost, we'd like to extend our heartfelt gratitude to our chief guest, Dr. M. Ravichandran, Secretary, Ministry of Earth Sciences, for gracing this occasion and inspiring us with the words of encouragement. His visionary leadership and inspiring address set the tone for this conference. Sincere thanks to a guest of honor, Dr. T. Srinivas, Head of UNESCO IoT WMS, for his valuable presence and mentioning the influence of the ocean value chain and the need for the sustainable ocean management. A special word of appreciation to Dr. T. M. Balakrishnan Nair, Director INCOIS, and our local host for his tireless efforts and commitment in making this event possible. We're deeply honored by the message from Mr. Vidar Elkson, Executive Secretary of IOC UNESCO, who could not join us in person but shared his valuable thoughts through a video message, reinforcing the importance of the global cooperation in ocean science. Similarly, we thank Dr. Brett Maloney, Science Director at CSIRO Environment and Chair of IIOGOOS, for his insightful video message and highlighted the significance of regional partnership and scientific innovation. A special thanks to Dr. Jenny Haggett, Scientist and Head, Biological Oceanography, Oceans and Coasts, Department of Forestry, Fisheries and Environment, and also an IIOGOOS officer, for gracing the occasion with her esteemed presence. Our gratitude also goes to Dr. Sinjay Yu from Korean Institute of Ocean Science and Technology and representing Scientific Committee on Ocean Research, that's SCORE, for his presence and contribution to advancing the ocean science. A special mention to Dr. Nick Damo, who has been with the IOE2 since its inception and for providing a thoughtful reflection on a decade of IOE2, reminding us of the progress made and the future road ahead. We acknowledge with appreciation the International Scientific Planning Committee, comprising of the chairs of the working group and science teams of IOE2 for their meticulous planning for this conference. Our thanks also goes to National Organizing Committee, which comprises of the directors of all the institutes under Ministry of Earth Sciences and leading oceanographers from India. Their guidance and expertise have been instrumental in shaping this conference. A special thanks to session conveners for their time and efforts for reviewing the abstracts and planning the sessions. Also to the session coordinators who will be ensuring the seamless execution during the session. We are grateful to IIOSC and SCORE for providing financial support for international early career scientists, and also to the Ministry of Earth Sciences for providing early career scientist funding, ensuring that young researchers have the opportunity to participate and contribute. Our sincere thanks to the sponsors from government and government agencies and PSU, like MOES, NCPR, CMLRE, FSI, NCMR, WF, IITM, NCES, NCCR, ISRO, NFDB, State Bank of India, and also from private industries, HP, Spray Technocon Private Limited, Pan India Consultants Private Limited, Samhita Marine, Campbell Scientific, Tidal Technologies, DTP, Envirotech Solutions, Swan Environmental Private Limited, Business Octave, and AFCONS for their generous contributions, which have been vital in making this event a reality. Finally, we recognize the efforts of the Internal Implementation Committee, chaired by Sri Pattabi Ramarao, Group Director, INCOIS, and the leads and members of all the subcommittees in various departments. The list is huge, so I may not be able to name everyone, but this is the fourth event INCOIS is organizing in less than a month's time, and there have been more than 250 individuals working tirelessly across various departments. Their commitment and teamwork deserves our deepest appreciation. A special appreciation to our event manager, who ensured the seamless coordination and execution of every detail, making this event truly memorable. We wish you all a very highly productive and insightful conference, filled with invaluable opportunities for collaboration and knowledge sharing, and hope you make most of your time in this vibrant city of pearls, it is Hyderabad, known for its Royal Nizam's heritage to its modern identity as a global high-tech hub, and of course, the world-famous biryani. Thank you.
Thank you, Dr. Lodlikar, for your thoughtful acknowledgements. Thank you all the dignitaries, delegates, and the guests for gracing this momentous occasion. Let the Congress unfold with enriching discussions and groundbreaking ideas. Let the International Indian Ocean Science Conference 2025, IIOSC 2025 begin with science, energy, and sustainability lighting our way forward.
Ladies and gentlemen, now I request all of you to rise for the national anthem. Please remain seated after the national anthem as we have a few announcements to share.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Before we disperse for the parallel sessions, a few important announcements. Your registration kit includes a water bottle. Kindly use it for drinking water. As cups are not provided, restrooms are located conveniently near the main hall. Details of date-wise parallel sessions are displayed at the information desk and outside the respective rooms. The presenters are kindly requested to submit their presentations to the session coordinators well in advance to ensure that we adhere to the time schedule. RO water is available for safe drinking. Do visit the Telangana tourism stall to explore the sightseeing packages in Hyderabad. We invite all the delegates to visit the Kriti Social Initiative Stall, a Hyderabad-based NGO empowering women and supporting children's education since 2009. This enterprise employs around 80 women artisans who craft beautiful products using traditional ikat and kalamkari textiles. Explore their range of products and support this meaningful cause. Early career scientists are encouraged to register for the ECSN workshop on 5th December. Fellowship recipients are requested to submit their original receipts at the registration desk and verify claims form after lunch. Kindly adhere to the timings for refreshment and lunch to ensure smooth conduct of the sessions. And don't miss the popular talk schedule during the conference. After the tea break, we will begin with our sessions. We will be having four parallel scientific sessions from 11:30 a.m. to 1 p.m.
Okay. First floor plenary hall, theme 6, unique geological, physical, biogeochemical and ecological features of Indian Ocean. First floor e-classroom, theme 5, extreme events and the impacts on ecosystem and human population. First floor training room, theme 4, circulation and climate variability. Ground floor breakdown room, theme 2, boundary current dynamics, upwelling variability and ecosystem impacts. Corresponding poster standees are arranged in front of the respective venues with the poster abstract ID. The dignitaries are requested to kindly proceed to the exhibition hall on the ground floor to do the honor of inaugurating the exhibition. With that, we conclude the inaugural ceremony of IIOSC 2025. We look forward to engaging and enriching conference ahead.
Before we disperse, I request all the dignitaries to come forward and occupy the front row seats so that we can have a group photo.
Equipment starting from all the underwater sensors and geospatial equipment also. I know.
Yeah, and they are also a major sponsor.
Okay. Sir.
Welcome, sir. Good morning. So it's
you
from getting into ocean sensors.
Okay.
So basically we are in agriculture, environment and water.
How many can you test?
Now that our ECF is now, I think
What is this one?
So all these are air quality.
Air quality.
Air quality. Air quality.
No, this small one.
This one? This is rain gauge.
No, this one.
So these are
They all have small. Yes. Yeah. So same thing, that sensor also actually is looking like that only. No.
this one.
This one. You have to repair it.
Actually,
we have to replace.
We have to. Yeah, we have to.
Enhance the fish production all along the world. It's 20 blocks. That is to enhance the fish production and livelihood of the fishermen.
Yes.
These shapes have some meaning.
Yes, sir.
Some
Different
scientific
shapes.
backing.
Yes, sir. Fishes go and they breed, thus the production will increase. That is the main concept. Yes, sir. That is Ministry of Sir, 1 minute. Please, sir, please. This is the history of Fisheries Survey of India. It's a very old prior independence. And then we have 11 vessels.
Now, how many is operation?
4.
4.
Yes, sir.
Which are the things?
2 tuna longliners, Chennai and Mumbai, and ours Visakhapatnam.
Ravanika, I sailed Ravanika, Samudraka.
Yes, sir. So, this is the research I have been doing since this ban period, sir. The tuna research.
So you are also putting any sensor and the fish?
No sensor. No sensors, sir. Then we have this data also we have been collecting, sir. All low litter, ALFG, marine plastic litter, abandoned lost or discarded fishing gear data, and the resources. This is our vessel Shikari. Station data. We have 200 meters.
We can put our AWS here, no?
Yes, sir, please.
Yeah, I'm taking. I will come back.
Sir.
Yeah, thank you.
You are from Vizag.
So all of
Which year?
2020. So it has almost all our activities. Come in the younger amateur.
Like buoys, USPs. For the USP, we have been selected for the defense challenge, IDEX spinners, okay, pole monitoring systems, server vessels, meteorology systems. This kind of so interactive dashboard so that it can be more informative. Yes.
Thank you.
Thank you, sir.
You also communicate.
Yes, now we have requirement of using our own science.
So how many is operation?
Second batch there was some issue, which we have given the performance evaluation report. So we are working on it.
I think this we can revolutionize.
Yeah.
Spend some more time and effort
Fine tuning and that's very
It's portable automatic. Automatic.
solutions with us. Thank you.
Hi.
Good morning, sir.
Yes,
How are you, sir?
Yes, sir.
So how many gliders are there now?
10 numbers.
10 numbers. 10 numbers.
So we just got the order for the cruise as well, 50 numbers. So we are hoping you can support us on the new Sentinel glider. New Sentinel.
What is that Sentinel glider?
3 years endurance.
3 years?
3 years. Oh, that's good actually. The first time I'm hearing.
And maximum sensors
Excellent.
we can integrate with this. 8 sensors you can
So you can integrate with our own satellite system?
at this moment, no, sir. It will work with IDD.
No, one requirement is that probably you look into it.
Yes.
Because we'll go this one 3 years is something.
Yes, sir. And recently, sir, one glider has already been deployed by some of the universities, so it's already in progress.
So you can also have the micro rider to it?
Yes,
yes.
Good. This one is very interesting.
Yes, we will also do for every year this Antarctica.
Yes, that's what. That was one major limitation. We want to operate from
We will
South
deploy in Antarctica.
South Pole to.
Yes, sir. So we will share the details of this.
Thank you. So we'd like to start with the first presentation of these 6 presentations that will be given this morning. And the first 3 presentations are related to a cruise that was organized in the Indian Ocean on the Zona, so the cruise 305. So we'll start with Herman Banger, who will present the first results about this cruise.
Thank you very much.
Thank you.
Thank you very much. Yes, I'm going to talk about the cruise we had last year in April, May 2024. So my name is Hermann Banger. I'm from Geomar Kiel in Germany, and down here you see the team of the BioCat cruise, and I'm going to present the results from some of the team members. Okay. Oh, does this work?
The green one.
The green, yeah.
Yeah, this one.
Yeah. Now it works. Okay, thank you. Okay, so the major aim, the major objective of this project was to look for the oxygen minimum zone, to look for the major processes which are maintaining the oxygen minimum zone, including the air-sea interactions. And today, and we had 5, let's say, major topics we wanted to investigate during that cruise. And today I'm going to talk first results about the physical dynamics in the water column and nitrogen cycle processes. This is a cruise track, so we started in Colombo, went south, and we were crossing the equator, then we had a transect section along 88 East, and then we did this zigzagging where the oxygen minimum zone in the Bay of Bengal was found. So this is a plot of salinity along 88 East, and you can clearly see that we had a very nice separation of the equatorial Indian Ocean waters and the Bay of Bengal, so there was a clear separation between the 2 water masses. And then when you look at the right-hand side, you see in the TS diagrams that the TS diagrams were really significantly different. So we had really 2, let's say, some kind, 2 separate ecosystem, to separate oceanographic regions we were investigating. And this is the oxygen along the 88 East degrees transect from the south to the north. And the red color depicts the oxygen minimum zone. That means where we found very low oxygen concentration. And I circled there some kind of a gray region here in the upper water column at about 200 meters. And that's not a failure of the plotting program. It's kind of an eddy which was sitting there and introducing oxygen into the oxygen minimum zone. You can clearly see that the eddy was, let's say, disturbing the oxygen concentrations here. We found other eddies as well. So here, for example, is an example for 2 eddies we found, one cyclonic and one anticyclonic eddy. And the reason why I'm showing this plot here is when you look at the right-hand side of the figure here, then you see that the eddy clearly are driving the distribution of nutrients. For example, nitrate is shown here in yellow, and chlorophyll, which is shown on the very right-hand side. So the eddies are really driving, let's say, the dynamics and the biogeochemical processes in the oxygen minimum zone. We had a microtail sensor with us, and the beauty of this microtail sensor is that it goes very down in the concentration, so we are really able to measure oxygen at sub-nanomolar levels. And we found almost anoxic conditions. Some people may say it was already anoxic in the western part of the cruise track, and the results are shown here. So again, this is a cruise track on the x-axis, with depth on the y-axis, and I've shown 2 example profiles for the oxygen profiles measured with this microtel sensor, and really the concentration were very, very low. So less than 0.05 nanomoles at least. Micromole at least, sorry. Going back from the oxygen minimum zone to the surface areas, these are examples for underway system we had on board. We measured nitrous oxide, carbon monoxide, methane, and carbon dioxide, and the results are shown here. And let's say, so this way, the concentrations were not, let's say, exciting. Were slightly superrated. All these guys were slightly superrated in the surface layer. When you look at the methane plot, for example, it's the second from the right-hand side, then you see that there's kind of enhanced methane concentration right in the center of the Bay of Bengal. That's not that surprising, I guess. So the concentration are moderately high, so it's not a good big surprise. These are the N2O profiles in red. The N2O profiles here grouped into different regional areas. And down here you see the oxygen concentration in blue. And as you can imagine, or as you would expect, the oxygen concentration showed a gradient. So going from the south to the north, we see increasing nitrous oxide concentrations when the oxygen concentration go down. We also had measurements of the N2O production and reduction rates, and they were quite boring, except for one station, which is shown here with the filled circles. So at one station, we saw really significant N2O production and significant N2O reduction in about 150 meters, and this station was located in the northwestern part of the cruise. That's station 32. And again, this is the profile for nitrite, nitrous oxide, and oxygen at station 32. And as you can see, we found a very pronounced, very significant secondary nitrite peak here. So concentration for nitrite in the secondary nitrite peak were up to 0.4 micromoles per liter. In red is the nitrous oxide profile, and you see that where we found the secondary nitrite peak, we found a depletion of nitrous oxide. And this is a classical signal for denitrification, for ongoing denitrification. So nitrous oxide is reduced during denitrification. That's why we see this depletion, we see this very low concentration right there where we have this secondary nitrite peak. And when you plot, for example, nitrous oxide against oxygen, you see this classical distribution of oxygen and nitrous oxide concentration. This could be a figure which you can find in the Arabian Sea as well, or east of Peru, for example, the eastern tropical Pacific. So this is the first time we see that that nitrous oxide shows its double peak structure in the Bay of Bengal, and this is the first time we think that we see a really clear signal of ongoing denitrification in the Bay of Bengal. This shows the N2O, the nitrification and denitrification marker genes. I'm not a microbiologist, so don't ask me the details about this, but what I wanted to tell you is that we found that denitrifiers were dominating in the northern part of the oxygen minimum zone, whereas nitrifiers were dominating the southern part of the cruise, dominated in the south. And there was one station, and again, this is station, the famous station 32, where we find very dominant denitrifying marker genes, or marker genes for denitrification. And we think that here, exactly at this station, we found that complete denitrification was going on. So nitrate was reduced to nitrite, and then this was reduced to nitrous oxide, and then further to, this was further reduced to N2. Okay, and that's kind of surprising. This is kind of a summary, and this is some kind of bridge to the presentation by my colleague Gesa Schulz, which is following me, I guess. She measured the isotope signature of nitrite, and I think we can clearly distinguish between the eastern equatorial Indian Ocean and the Bay of Bengal. So in the Bay of Bengal, we have anamox dominating. We have nitrite reduction. We found, no, not that high, but we found significant nitrite reduction rates. We found nitrite oxidation rates as well. So there's a recycling of nitrate actually going on. But when you look at the rates, when we look at the denitrification rates, we do not find significant denitrification to N2, which is a kind of contrast to what I said before. When we look at the rates, then it seems that there was no complete denitrification. But when we look at these N2O profiles, for example, and look at the N2O production reduction rates, then we indeed could conclude that there was complete denitrification going on in the northeastern corner of this cruise track. Okay, that's a very quick summary. So we see this very clear separation of eastern equatorial Indian Ocean. That came to me for a surprise, I have to say. Maybe for you who are more familiar with the Bay of Bengal, it's not that surprising, but there was really this clear separation between the waters in the eastern Indian Ocean and the Bay of Bengal waters. We see that eddies were all around. We found several of these eddies, and of course they affect the biogeochemical cycles, they affect the biogeochemistry of the oxygen minimum zone. And we found stations where we had very extremely low oxygen concentration. Extremely low means in the sub-micromolar level, lower than 0.05 micromoles. Low rates of nitrogen cycle dominated by nitrite reduction, nitrite oxidation. That's what I told you before. That was concluded from the rates we measured. We had active anamox at station 32. Again, potential rates at further station was and potential anamox rate at station where the oxygen was low. Denitrification was not really detected, so the complete denitrification, but as I said, we really think that there was complete denitrification going on when we look at this station 32, where we see that nitrous oxide was depleted, and we saw this very pronounced, very significant secondary nitrite peak, which is really some kind of classical textbook example for complete denitrification. And anamox was indicated as the main pathways of end loss. Okay, so that's what I wanted to tell you. I need to thank our ministry because they funded the research as well as the German Science Foundation. And this cruise was endorsed by IOE2. It's a contribution to the IOE2 program, and it's also endorsed by the SOLAS program, which is SOLAS stands for Surface Ocean Lower Atmosphere Study. And down here in the footnote, you see all the contributing or the participating partner institute in this project. So it's GEOMAR, University of Hamburg, Herion, Tropos from Leipzig, that's the Institute for Tropospheric Research, SDU, University of Southern Denmark in Odense, and the University of Oldenburg in Germany. Okay, thank you very much for your attention.
Thank you, Aaron. Maybe we have time for a quick question. Yes.
Hello, Herman.
Hello,
Very
Matthew.
nice talk. And we were talking before, and we had taken a similar cruise, not similar, in the same track, and we never found a subsurface nitrate maxima. So this is the first time. And my question is, could you relate with temperature and organic carbon input?
We haven't looked into this data. We have some particle flux data. We need to look into this data, of course. I personally think that this signal of denitrification, which we found at this station 32, is coming from the coast, actually. I think that there must have some kind of anoxia at the coast, and then you had maybe a filament or something like this going from the coast into the more central Bay of Bengal. So I don't know whether this is a temperature effect or not. I can't tell you. I mean, there has been a glimpse of secondary nitrite maximum already reported in the literature. That was back some 3 years ago, 5 years ago. But this is, let's say, the maximum secondary nitrate peak we found last year. So,
Okay.
I don't know whether this is related to temperature or not. I can't tell you.
Thank you.
Yeah.
Thank you. So I think we should move on to the next speaker, Gesa Schulz, and we will continue with data from this same cruise on tracing nitrogen cycling and loss with nitrate isotopes in the Bay of Bengal and eastern equatorial Indian Ocean.
This is the forward, backward, and this is the point.
Okay, thank you. Okay, hello everyone. I'm very happy to be here, and I'm going to go into a bit more detail into the nitrogen cycle process studies that we did in the Bay of Bengal. Just a bit more detail of the cruise that Herman already presented. So I will start with a very quick and simplified introduction about the marine nitrogen cycle. So nitrogen is an essential nutrient for all life. However, in the ocean, nitrogen is often a limiting factor of productivity. And even though that our atmosphere consists nearly of 80% of D-nitrogen, this is not bioavailable for most microorganisms. However, there are very few specialized microorganisms that can actually convert this unreactive N2 into bioavailable forms via a process that is called N2 fixation. And this is one of the main input pathways into the marine nitrogen cycle. And then within the cycle, there are various turnover processes that can convert these bioavailable forms into other bioavailable forms. And finally, we have a few nitrogen loss processes that reduce reactive nitrogen forms back into unreactive N2. And Hermann already told you a bit about it. So we have denitrification, which is the stepwise reduction of nitrate via nitrite to N2. So this one. And we have denitrification, which combines nitrite and ammonium to N2. And as you can already see here from the figure, both processes occur in oxygen minimum zones, as they are anaerobic processes. And this explains why oxygen minimum zones are so important for the global oceanic nitrogen budget. So oxygen minimum zones account for roughly 1% of the global oceanic volume, but they are responsible for 20 to 30% of the global oceanic nitrogen loss. So they are really key players in the global nitrogen cycle. So the Indian Ocean, as you all know, hosts 2 oxygen minimum zones, and we are focusing on the Bay of Bengal. And this is a very interesting area because up to date, no study have shown significant sign of N loss in the Bay of Bengal. And there is the ongoing debate whether the Bay of Bengal is on the verge of a tipping point, where one side argues that an increase of productivity due to enhanced nutrient inputs, for example, from rivers, could lead to crossing that tipping point and lead the Bay of Bengal to become anoxic in the near future, whereas the other side argues that there are various processes like via ventilation, via eddies, that will inhibit the Bay of Bengal to become anoxic in the near future. And I think Hermann already showed us that eddies are really important in that area. So Hermann already told you, we as cruise participants of the Zone 305 head out into the Bay of Bengal searching for signs of N loss in that area. So what did we actually look for? So first of all, obviously, we need anoxic conditions in the water column. Then we wanted to see if we find a nitrogen deficit in the area, which we can calculate using nitrogen to phosphorus ratios. We were hoping to find a secondary nitrite peak. So Hermann already told you that at one station we had one, but I'm actually not looking at that station. And me specifically, because I am a stable isotope person, I was hoping to find an enrichment in the nitrate stable isotope. I guess not all of you are necessarily stable isotope people, so I will give you a very short introduction what they are and why they are so useful. So I'm only looking at nitrate isotopes, and they consist nitrate consists out of oxygen and nitrogen. So I'm comparing the heavier 15N and 18O to the more abundant and lighter 14N and 16O. And isotopes are looked at this isotopic ratio, where you always compare the abundance of the heavier isotopes to the abundance of the lighter isotopes in a sample. And because that number is very small, it is always converted to this delta notation. So why are they so useful into studying the nitrogen cycle? So there is a process that is called fractionation, and it describes the fact that turnover processes preferably use the lighter isotopes for their reaction. Reason for that is that heavy isotopes tend to have stronger bond strengths, and therefore it's more energy consuming for the microorganism to use these heavier isotopes. And for example, for denitrification, we would have which is the stepwise reduction of nitrate. So we would have a substrate pool consisting both out of heavy and light isotopes, and as soon as we have the reduction, preferably the lighter isotopes will move away, and this leads us to what we call it a nitrate pool that is enriched in heavy isotopes. This will shift this towards the abundance of heavier isotopes and lead to heavier delta 15N values. And this increase of delta 15N values is actually also process specific, but I'm not going to go into detail about that. I just want you to remember that N loss shows an increasing delta 15N and delta 18O value. So please remember that if we're going to look into the data. So I have one quick slide about our methods. So we did head out into the Bay of Bengal last year, and we started sampling. now I moved. We started, I'm always pressing the same button, sorry. So we are starting south of the equator and then moved northwards into the Bay of Bengal. And if you remember Hermann's Vortrag, presentation, I'm only focusing on this transect, so I excluded all of these two. At every station that you can see here, we did take CTD, full depth CTD profiles, and we also took nutrient samples at every station that you can see, and at every black station I took additional samples for the nitrate stable isotopes, which were filtered on board and then shipped via air freight to Germany, where I measured them using the denitrifier method and a mass spectrometer. So now let's go through our checkbox to see if we can find signs of nitrogen loss. So first of all, did we find anoxic conditions in the water column? And Hermann already told you quite a bit about it. So we have a pronounced oxygen minimum zone in the Bay of Bengal, and we were not at this functional anoxia level yet, which would be necessary for significant rates of denitrification, or most of the time not. So we had still oxygen levels left to like 1 or 2 micromoles per liter. However, we know that denitrification and Anamox can actually cope with a little bit of oxygen. So Anamox has been shown to work up to 20 micromoles per kilogram of oxygen and denitrification up to 6. So yes, we were definitely at oxygen concentration range where both denitrification and Anamox could occur. Did we find a nitrogen deficit? So here I plotted the values in the depth profile, and I'm only showing the upper 300 meters of the water column because this is actually where the on-site biogeochemical turnover takes place. And I also colored my points to give you introduction about where these samples were taken. So everything in blue is the East Equatorial Indian Ocean, south of 5 degrees north. And the orange and red is the Bay of Bengal, with red showing all the samples that we took in the core oxygen minimum zones, so with oxygen concentration less than 20 micromole per kilogram. And you can see that we actually do have a pronounced sink of nitrogen or an N deficit in the Bay of Bengal that is not there in the East Equatorial Indian Ocean. So at both regions we have a nitrogen deficit in the upper water column, which could be due to primary production, and then this vanish in the East Equatorial Indian Ocean, whereas it persists in the Bay of Bengal. So did we find a secondary nitrate peak? So this actually does not really fit to Hermann's talk because I'm only showing this one profile, but in that area we actually did not find any secondary nitrate peak, only the primary nitrate peak. So far we checked 2 out of 3 boxes. Let's see if we find an enrichment in nitrate stable isotopes. So here you can see yet again the upper 300 meters, and you see the delta 15N values on the left and the delta 18O values on the right. And so we are looking for a significant enrichment, so high delta 15N and delta 18O values. And don't focus on anything in the upper 100 meters. This is nitrate uptake by phytoplankton. So this is not actually an N loss process, it's just recycling. And if you're focusing on the lower area, unfortunately, especially at the delta 15N values, you do not really see anything. However, if you are comparing the delta 18O values of the East Equatorial Indian Ocean and Bay of Bengal, you do not see a significant enrichment, but it becomes clear that the Bay of Bengal values are significantly enriched compared to the East Equatorial Indian Ocean values. And this enrichment in delta 18O is actually also connected to the nitrogen deficit that we found. So please just focus on the lower range here. We can definitely see that delta 18O values increase with a bigger nitrogen deficit that we found. So yes, we did find a small enrichment in the delta 18O values in the Bay of Bengal. So why do we have this decoupling of delta 15N and delta 18O? So why did we find the signal only in the delta 18O? And I'm actually not going to go into detail here because it becomes a bit complicated with inverse fractionation and oxygen atoms that are affected from the dissolved oxygen and the water. However, it has been published multiple times before that this can be interpreted as a signal for simultaneously nitrate reduction and nitrate oxidation. So for example, it is also found for the Arabian Sea. And this simultaneous processes will lead to a little effect of the delta 15N and an enrichment in the delta 18O, and it totally makes sense. I will be done. because, I will come to my final slide. So we definitely find convincing evidence for nitrogen loss in the Bay of Bengal. And here you can see what we believe are the processes that happen in the oxygen minimum zone in the Bay of Bengal. So we believe that significant N loss is still inhibited by oxygen concentration that will lead nitrite oxidation to outcompete nitrate reduction processes for the available nitrite. And we do believe that anamox is the more likely process to lead to the small nitrogen loss, as it can cope a bit better with oxygen. And so thank you for your attention. If you're interested in the paper, you can find it here.
Thank you, Geza. Again, I think we have time for a very short question. If not, we'll move to the next presentation. We will remain in the Bay of Bengal and learn more about the result of this Zona cruise, BioCat. So we'll learn more from Birgit Guy. Is that on sources of suspended matter in the Bay of Bengal and the equatorial Indian Ocean. You can go ahead.
Thank you, Marie, and thank you for giving me the opportunity to give this talk. I will compare data from the Bay of Bengal with data from the equatorial Indian Ocean, and I'm going to show our first results of the suspended matter data. And we have seen this, the ship before, and this photograph was actually taken by a drone during the cruise to the equatorial Indian Ocean, and from the colors of these photographs you can see that it is really oligotrophic and that it is really completely blue and not green in this area. These are the cruise tracks of the Zone 303 and Zone 305. The 303 was actually planned to go to the Arabian Sea, but due to several incidents we had to shift it, and so we went to the central equatorial Indian Ocean. On the right-hand side, you can see that that this Bay of Bengal cruise carried out in April-May was carried out before actually the high discharge period started. So it is still a period of very normal and low, or so to speak, low discharge of the Ganges Brahmaputra. We sampled this particular particles and dissolved matter, and I'm going to show only the results of particle sampling and especially of total hydrolyzable amino acids in these particles, and some results of delta N15 of the particulate matter. Amino acids are the largest identifiable pool of organic matter. They have different spectra between different types of organic matter, and most of the time we use these changes in amino acid spectra to better understand sources, but mostly degradation processes of organic matter. Some instruments are coming. I chose this graph because to show that suspended matter, this is actually different. This is organic carbon sinking particles, remineralization, and then transport of CO2 to the surface. But what happens is that suspended matter is not sinking and probably shows very little interaction with sinking particles, but is also transported with its water mass until mainly this water mass is brought up to the surface ocean. So it can stay in the ocean for different periods of time. And its role, for example, to sustaining organisms is not very well known, but there are, of course, some interesting investigations. Suspended matter also has an important carbon pool, nitrogen pool, but it is about only 5% of the dissolved organic matter pool, which is the largest organic matter pool in the ocean. The results from the Bay of Bengal, these are the suspended matter concentrations, and the interesting part is that in the near bottom samples, this is the from south to north, of course, we have enhanced suspended matter concentrations, enhanced contents of nitrogen, of carbon too, of course, and these are the delta N15 values, and they usually are much higher in the deeper waters than in the surface waters. These are the higher values of between 6 and 8. And very unusual, in the Bay of Bengal, we have lower values also in the near bottom samples. If we directly compare the suspended matter concentrations and POC, particulate organic carbon concentrations, we see those blue dots. So we have these near bottom maximum, and this is completely different from the equatorial Indian Ocean, where, of course, the bottom samples have quite low and quite uniform suspended matter and organic carbon concentrations. Very briefly, amino acids can be used as biogeochemical indicators. When we analyze them, we break this peptide bond, so we analyze individual amino acids, and their spectra can be used as indicators, and they are typical of certain processes. You see the different structures of proteins, and as you know, amino acids are building blocks of ligaments, of muscles, and of DNA, and of many other, also of hormones, or in many other constituents of living cells. There should be some more information here, right? I don't like it if it pops up like this. In an earlier publication, we identified two indicators. One is an indicator of degradation, and the upper arrow shows the degradation and the enrichment of certain amino acids during this degradation route, and the other arrow going down shows how suspended matter changes with water depth. So from, there's one more. Okay, no, it's okay. So, and if we look at the samples, they would group into these boxes. So sediments are in this red box, and sinking particles are in these two green boxes, and suspended matter would be in this shallow box and in this deep suspended matter box. So using these results of the PCA and normalizing all samples, or each sample we analyze with this PCA. And now if we look at, again, at our transect through the Bay of Bengal, these are only the upper 500 meters. In the upper graph, we see chlorophyll concentrations. Below that, amino acid concentrations, typically enriched in surface waters, and also some intermediate enrichments. And in the lower one, we see the first amino acid indicator, and it is higher in red in surface waters, and then it declines because the residence time of the suspended matter increases, and this leads to this characteristic decline in this indicator. And if we now look at the full range from surface to bottom waters, we see that again that amino acid concentrations are enriched in the bottom samples. We see that this residence time indicator indicates that the residence time is shorter, so it is more similar to surface waters, and also some other indicators show that the material in the Bay of Bengal near the bottom is less degraded than you would expect. And again, compared to the equatorial Indian Ocean, we see that this indicator is higher in bottom waters. Both indicators actually are higher, showing that the material is probably surface derived and is not resuspended sediments. So these red numbers, it's a bit difficult to see. The shallow water depths are in the upper box, and in the lower box it's usually deep waters, and the red numbers are those from the Bay of Bengal near bottom samples. So they are somewhere in between. Some of them are even in the shallow box, and they are different from samples of resuspended sediments. These are samples from the South China Sea from another work we have done, and resuspended sediments are more similar, of course, to the sediment box. So what we think and what our results evidently show us is that in the Bay of Bengal we have relatively fresh organic matter in bottom samples, and we believe that this is somehow related to the fast transport of fresh material from the shelf and from upper waters via the channels of the Bay of Bengal. And this is the summary. So we have the enhanced concentrations of suspended matter in bottom waters in the Bay of Bengal. The amino acid derived indicators show that this is not resuspended sediments, but it is relatively fresh material, and it is more similar to surface waters than to resuspended sediments. And so we think that this is material that has been transported probably by active channels, and many of the samples, especially in the northern and central parts, were taken near the main channel of the Bay of Bengal, and some of the samples are not near the main channel but also closer to smaller channels. Thank you very much.
Thank you. Do you have questions? Yes?
Thank you for the nice presentation. I just want to know, so the ballast theory is still applicable in the Bay of Bengal as per your data?
The ballast theory, you mean that it is sinking faster?
Sinking
yes,
faster.
Of course, of course. We also have very interesting trap results from Kiel, from the Geomar group, but I think these would show, of course, that the ballast theory is important. You mean the fast downward transport could also be a reason, right?
Yeah,
yeah,
and
that's
one
true.
more thing is that delta 15N values about 8 to 9 per mil in the subsurface waters. What could be the reason for that? In the Bay of Bengal, in the SPM, you showed intermediate waters are having 8 to 9 per mil of delta 15N.
Yes, and even the deeper waters. In all our samples, also from other areas, we have these high values in the deep water. They are all very similar, and also for other authors, like some studies from Altabet and some studies from Zhang from the South China Sea also have these values, and they're all between 6 and 8. So I believe that this has to do with the long residence time, and that it's not local, but that this is transported with the water mass, and that somehow, for some reasons, maybe exchange with dissolved organic matter or other things, it is, so to speak, a worldwide phenomenon that this is long residence time suspended matter has these high values, and it may not have much to do with the material we find in the surface waters. It is laterally transported.
Thank you. I think we have to move on. We just catch up in time. And we'll go now to the Central Arabian Sea sediment with Medhavi Pandey, who will speak about unraveling the spatial variability in sedimentary phytodetrital fluxes in the Central Arabian Sea, evidence from lipid biomarkers.
Hello everybody, my name is Medhavi, and today the work I'm going to present over here is a part of my PhD work, which is entitled as Unraveling the Spatial Variability in Sedimentary Phytodetrital Flux in the Central Arabian Sea, Evidence from Lipid Biomarkers. So in this work, the presentation basically deals with the phytoplankton that get exported out of the surface water column and they get preserved in the sediment, and what information do we have from them. So of all the processes or the pumps, you can say the migrant pump, the mixing pump, or the gravity pump. So the gravity pump, which also is known as the biological carbon pump, is of utmost importance, and it is to be known for transporting and working more than 70% in this carbon export process. And therefore, it is very much important to know which phytoplankton group contributes to this process. So the major key players in this biological carbon pump process are the marine phytoplankton, which are tiny little organisms that live in the surface ocean and are responsible for fixing food as organic carbon for other organisms to eat. There are 4 major particular phytoplankton groups, which are diatom, dinoflagellate, coccolithophore, and the cyanobacteria. They are very different in their shape, cell size, and the diatoms are siliceous. Dinoflagellates have organic carbon cells, and then coccolithophores are calcifiers, and then we have blue-green algae. So these all organisms, after fixing food and after remineralization, they sink from the surface ocean in very small proportions, but this small proportion plays a huge role in modulating our global carbon dioxide levels, and therefore it becomes very important to understand which organism sinks from the surface and reaches the seabed, particularly in the regions where there is depth more than 4,000 meters. Sometimes what happens, the remnant or the shell of these organisms does not preserve well in sediments. So we go for lipid biomarkers. These are certain lipid biomolecules or organic compounds specific to phytoplankton, and they can be used to trace their distribution in the sediments. For example, brassicas can be used as a marker for diatoms, dinosterol for dinoflagellates, alkinone for coccolithophores, and cholesterol for zooplankton. The first three are primary producers, and the last one, you can consider it as a herbivore. Now, the study area I have chosen is the Central Arabian Sea. Why Central Arabian Sea? Because it is very unique in its biogeochemistry because of the seasonal reversal of monsoon winds. So if you see the Central Arabian Sea, we have two monsoons. Firstly, the summer monsoon, which happens from June to September, and then winter monsoon, December to February. In the summer monsoon, the fin later jet crosses the Central Arabian Sea, and to the north of it, we have open ocean upwelling, which means nutrient-rich cool waters come to the surface and high production occurs in this region. Whereas the region in the south, it remains oligotropic and warm, and low productivity occurs. If you look at the winter monsoon, again the northern Arabian Sea becomes productive because of high productivity, because of the convection process. So overall, if you see, the northern part of the Central Arabian Sea remains productive and the south remains low productive. Also, apart from this, the Arabian Sea also hosts one of the thickest oxygen minimum zones, and studies have suggested that the preservation of organic matter is best in this region, and therefore a study of this type, where we study particle flux, could be best suited. Now, taking you to a little background, what information do we have from this region? From GIGOFS till date, we have enough information available on the phytoplankton community dynamics. Particularly, this region is dominated by diatoms throughout the season in most parts of the year. And few attempts have been taken to study what gets exported out of the surface towards the deep. And for this, sediment trap studies have been done, but they are very much limited and mostly focused on the fluxes which happen during the different seasons of the year. And if you look at the sediment, we have very little information from this region, or approximately none, and this one paper suggests that there is no preservation of any particular phytoplankton group in the sediments. So in order to cross-check this, we have considered this study. These are the key research questions. The first one, which phytoplankton groups dominate? And the second, does their occurrence is related to the physical forcings that take place in this region? And finally, what probably could be the factors for their occurrence? And for this, we have taken a cruise along the Central and the Eastern Arabian Sea. I'm going to tell you the results from the Central Arabian Sea. Here, we have taken the surface sediment cores from 0.5 and 1 centimeter. And the parameters that are done, total carbon, nitrogen, total inorganic carbon, total organic carbon, diatom frustules. These are the siliceous organisms, and nearly more than 500 individuals we have studied, because these are the dominating phytoplankton in the water column. Then we have radiolarians, these are microzooplankton. Then we have done the lipid biomarker analysis, and then the satellite data. So coming to the results, here, what we see is that we have higher inorganic carbon in the southern part of the Central Arabian Sea, and higher organic carbon, nitrogen, and diatom frustules in the northern part of the Arabian Sea. Apart from this, there are two types of diatoms. One is centric and one is pinnate. Centric diatoms usually require higher amount of nutrients for its growth, and we see that their occurrence remains higher in the northern part of the Arabian Sea. And also we have measured individual sizes of all these diatoms, and we see that the highest size was found in the northern part. And the size can even go beyond 200 microns. And this all has been attributed to the physical forcings that take place in this region because of upwelling and convection. Also, we have tried to look at the phytoplankton community dynamics using microscopy. And I would like to show you the SEM images from this study. These diatoms, Costinodiscus and Rhizosolania, these are large centric diatoms which often escape grazing and are found in the sediments. And the region in the south was mostly dominated by pinnate diatoms and chain-forming diatoms. This is Thalassiosira, Cironischia, and Hemidiscus. And all their occurrence, again, is related to the physical forcings that take place in this region. Now, we also have the data from our cruise, which we went from 17 to 18, and occurrences of similar species have also been reported from the water column. But if you look at the relative percentages from the species from the water column and the sediment, there is a mismatch. It is possible that the community that dominates the water column, probably their preservation or it could not be better in the sediment, and some other species can go to the sediment. For example, here you see Costa discus contributes little, but here its contribution is maximum. And therefore, we have tried to look at certain factors, what could be possible for this. So, the large size of the diatoms that occur in the north, particularly Costa discus side Rhizosolania, could be one reason, because the zooplankton which are present, they prefer to eat the diatoms which are smaller in size, because there is an optimum ratio of 18:1 for a predator to go for a prey. Similarly, we also like to eat food, something which is 25 times smaller than us, consider a biscuit. And then, of course, they go for thinly silicified organisms. It is possible that thinly silicified diatoms are dominant in the surface water, but they are preferred to be grazed by the zooplankton because less energy is required by zooplankton to crush them. And then chain formation is, of course, one of the factors where these diatoms sink rapidly. And apart from this, oxygen condition and dissolution, like the amine matrix present in the diatoms, it also plays one of the important roles in their preservation. Now, this is the data which we have observed from the microscopy. We would like to confirm it using the lipid biomarkers, and we expect that the major phytoplankton group that dominates the Arabian Sea, its signatures will be higher in the sediment as well. So, we see brassicastirol, which is a marker for diatom. Its concentration remains higher in the north. As I move from north to south, which means I'm moving from left to right. And here we see the occurrences was higher in orange. But one interesting observation we found was that the concentration of dinosterol, which is a marker for dinoflagellate, its concentration remains higher than brassicastirol if you look at the scale. And similar observations have been made from previous sediment trap results and from a core from this region in this region as well. And we tried to look at the probable factors for it. The dinoflagellates have very smart survival strategies over diatoms. They are case strategists, and this means that they can even thrive the periods when there is productivity as well as non-productivity. Also, apart from that, they have different nutrition modes, which means they can choose to be autotrophs sometimes, and then they can be heterotrophs. They can feed on these diatoms as well. And the benthic biota, which lives in the sediment, it preferably goes to eat diatoms, rejecting the dinoflagellates. So that is why we can see higher dinosterol concentrations in the north. And if you look at the southern stations, which are warm and oligotropic, we have reconstructed the SST temperatures, and we see higher SSTs in the south. And it is related with higher coccolithophore concentrations here as well. Also, the microzooplankton, which are the radiolarians, which occur in warm oligotrophic waters, their concentration also remains higher here, and it is also reflected in their biomarkers, cholesterol, here in the south. Also, we tried to confirm this using the satellite data, and we see here that the north had cooler waters, higher nutrient conditions throughout the year, and higher phytoplankton biomass. And the RD analysis also revealed that the lipid biomarkers, the community, the organic carbon, they all remain coupled together and showed an inverse relation with the sea surface temperatures, the microzooplankton, which remain associated with the sea surface temperatures, and the cholesterol and the TIC, which is coming from foramen and coccolithophores. So, coming to the final summary of this study, I would like to show it in the form of a section plot. Here you can consider this Arabian Sea as a section. This region shows the north and this in the south. In the north, we have upwelling, open ocean upwelling and convection, large diatom blooms occur. They often escape grazing via zooplankton, and they sink from the surface towards the deep sea. Via their passage, they pass through a thick oxygen minimum zone in the north, and here there is lesser microbial degradation and zooplankton fragmentation in this region. And therefore, we see higher fluxes of organic carbon, the diatom crystals. And contrarily, in the south, they are often eaten up by zooplankton, and their passage from the surface towards the deep sea, there is a thin oxygen minimum zone where maximum activity of zooplankton and microbial degradation occur, and therefore we see lower fluxes here. So these are the key research findings. This is the first study of lipid biomarkers and frustules from the Central Arabian Sea, and then the strong spatial variability in physical forcing, it shapes the phytoplankton community dynamics and particle flux patterns in this region. The north, it has higher organic carbon frustules and biomarkers, and it is associated with the physical forcing, seasonal productivity, and intense oxygen minimum zone. In the south, we have small phytoplankton group, lower organic carbon and biomarkers, and it is attributed to thin oxygen minimum zone. And biomarkers also indicated that there is highest contribution from dinoflagellate apart from the diatoms. And then this northern station could be considered as a hotspot for studying the particle flux studies, not for today, but also for the past climate interpretations. And this paper was published last year. If you want, you can give it a read. And this work, it fills the gap which we have from the Arabian Sea. Like the major upwelling systems, we have idea of the community that goes from surface towards the deep sea oceans, but none of it is reported from the Arabian Sea. So this is the first study that contributes to the community dynamics as well as the lipid biomarkers. But then again, it opens the study for other studies to be considered. For example, we have little information of the dinoflagellate and the coccolithophores, and also the 18S RNA should be done for getting to know the contribution from other eukaryotes. And then benthic organisms and their feeding behavior should be studied. And a lot of mineralization process and experimental studies are yet to be considered for the mesopelagic respiration. And thank you to the director, my guide, and the German collaborators we have, then Arif Sardar and Teja Naik, and the committee members at the IIOSC and INCOIS.
Thank you, Medhavi. Again, we have time for one question. Yes, please. Yeah.
Thank you very much. And your presentation was nostalgic for me because I was associated with your sediment trap and particle flux program. So I don't have a question, but the thing is that very, very important this time because morning we were talking about translational and operational oceanography. So how to find out the habitat suitability of all these radiolarians or the coccolithophores or other trichodesmium, etc., and its relation with the fisheries. So what we are in India, we are looking for actually how the climate change is affecting fisheries. So this is one of the link between the both. So I think it should have a more interdisciplinary kind of work. So I think INCOIS is also interested to collaborate this kind of work. Hemandi knows it very well. So anyway, good. Thank you.
Thank you, sir. Actually, sir, ocean color monitor studies have now more processed further, and they are going till community level studies, like the diatom pixel, they are studying the community composition, so it could be useful in that. Thank you.
Thank you. So we'll continue with Rajiv Saraswat on present and past carbon accumulation in the Northeast Indian Ocean.
Good afternoon. Thank you, Mari. Taking you briefly again back to the Bay of Bengal that 3-4 speakers were talking about. They were, just for one presentation, we moved to the Arabian Sea. So in this talk, I'll be basically talking about how all these surface ocean processes that people were talking about, it is leading to the carbon accumulation in the sediments under the modern conditions and also going back in time. We know carbon is something that we can't live without, but also we can't live with too much of it. We need it, but in small quantity. And it's been changing tremendously over a long period of time, if you look at that. There were quite a lot of variations that we have seen over a period of time, but unfortunately we are close to, as morning somebody was talking about 420 or 425 ppm compared to normal range of around 180 to 280 ppm that the variations we have seen. So people are worried, what is it going to lead to? Maybe global warming and other processes, but also there is bit of an intrigue that how does this 180 to 280 ppm variation has happened on the glacial, interglacial time scales? Where does this carbon go and from where it comes out? So this presentation will be touching upon partly on that from the Bay of Bengal. that's the variation in the carbon that we have seen over a long period of time, that it has varied from close to 1400 ppmv and coming down to almost, that's the limit I was telling, that on glacial interglacial time scales 180 to 280 ppmv. So naturally there has been a huge variability in the carbon dioxide concentration in the atmosphere. Of course, of late we are talking that it's all we humans who are contributing to that, and there are reasons to believe that. Now, prior to that, this natural variability in the oceans on glacial interglacial timescales, it's often attributed to the oceans, because oceans, they store a significant amount of this carbon in different forms, in the organic matter as well as in the inorganic form that it accumulates in the ocean. So going further in that part, we try to understand in the Bay of Bengal, how much of it is getting accumulated, or even on glacial interglacial time scale, whether the Bay of Bengal also contributed significantly or in some manner in regulating the atmospheric carbon dioxide concentration. Because those numbers, that from 180 to 280 ppmv, from which ocean contributed how much, that is still debated, although we talk about Southern Ocean being the major driver of that change, but then the numbers doesn't add up. So it's like we had some samples being collected over several cruises along the Indian margins, basically along the eastern coast of India, and also from the Andaman Sea. But then again, instead of writing a small story about those individual samples, we thought, okay, why not collate all the available data from the entire Bay of Bengal? And let's try to look at on a basinal scale how things are varying on carbon accumulation, both inorganic and organic carbon. So we ended up having 718 surface sediment samples, new and whatever has been published so far, and data is available in public domain. Along with that, we also looked at, as I said, on glacial interglacial time scale. So we worked on 3 cores from this particular area. Then we thought that again, let's look at the basinal scale on glacial interglacial time scale. So we had a total of 19 cores collated from the entire Bay of Bengal. And that's how we'll look at both the organic and inorganic carbon variability, as well as some of the factors which led to that variation in the carbon accumulation during different times. So those surface samples, they were starting right from 25 meter. That's how we collect those samples along the latitudinal transit, starting from the coast going up to the deepest points. So we have samples from the shelf to almost 4,656 meters. So that's the modern oceanographic condition. People have already talked about that. You have quite a lot of low, variability during the summer and winter monsoon seasons, that you have huge influx of the fresh water that leads to this change in salinity. Also, we have this huge variability in the dissolved oxygen because of these modern oceanographic processes. So that's the surface samples that we all had from the entire Bay of Bengal, and then that's the inorganic carbon variability. So that's basically the calcium carbonate which is contributing to that. And as expected, we don't have much of it along the shelves because of the terrigenous dilution. You have a lot of these sediments being brought by different rivers, and they are contributing significant part of the sediments. So we are only looking at the percentage. So percentage-wise, there is huge contribution of the terrestrial material. But then if you go into the open ocean part, of course, you have mostly the biogenic carbonate, which sinks to the bottom, and that's leading to the large fraction of the inorganic carbon contributing to the total sediments. No, it doesn't seem to move forward. So coming to the organic carbon, of course, as expected, that you do have a significant amount of productivity in the coastal waters because of the nutrients. So we get some good numbers on the organic carbon here. But I'll show you a plot with depth. That's completely a different picture, that you don't get much of the organic carbon on the shelf, but on the slope part because of the finer sediments and the low dissolved oxygen over there. So coming to the organic carbon to nitrogen ratio, of course, since you have the terrestrial input, so you have the higher numbers here, and then the numbers are much lower in the open ocean. So the total carbon accumulation is definitely much higher in the deeper parts, as I said, because of the inorganic carbon significantly contributing to the sediments accumulating over there. And we are talking over here that the carbon compensation depths that was told earlier based on the surface sediment samples, now that's probably has to be revised, because we do get the carbonate preservation at much deeper depths that people have already reported previously from the Bay of Bengal. And I'll show you some more figures on that part. Now, unfortunately, we don't have much of the data on the carbon and nitrogen isotopes. That's something that people have to really look at to figure out from where we are getting this much of the organic matter, whether it is terrestrial or the marine contribution. Now, that's an interesting plot wherein we looked at the calcium carbonate with the water depth, and of course, as expected, that you do have some good numbers over here because of the calcareous shells that are getting accumulated on the shelf. But then in the slow part, we have very low calcium carbonate. But then what was more interesting was a peak in the calcium carbonate concentration between 3,500 and 4,500 meters. Now that's where people have reported that if it was because of the CCD, which is reported at 3,000 meter, definitely we should not have seen those numbers. But then the good amount of accumulation of calcium carbonate over here, which we feel is basically because you have the favorable water mass that's leading to a better accumulation of the calcium carbonate here. Now, coming to the organic carbon, of course, we have a huge amount over here on the shelf, on the slope part, because you have finer sediments and also the low dissolved oxygen concentration. Both of these factors facilitate better preservation of the organic carbon on the slope part. Now, we do get a good correlation between the organic carbon and nitrogen as expected, because most of the nitrogen is basically contributed by the organic matter, and then the COG by N ratio also, and the delta C13, that shows a negative correlation, but we don't see, really a good correlation between del N15 and delta C13, maybe it's because of some of the diagenetic processes that are operating over here. So that's the modern stuff. Now going back to the older times, as I said, that there were these 19 cores that we looked at. There were 3 cores that we analyzed and then again collated the data from different cores that were published. Now in order to get a meaningful, spatial variability, we clubbed that data into 5 different time slices. The last glacial maximum, that's a time frame from 18 to 24 kiloyears. Then the glacial interglacial transition, so from 18 to 11.7 thousand years. And then the different sub-stages of the Holocene, that's North Crimean, Greenlandian, and the Meghalayan. So accordingly, we have plotted this data. That's all the data put together. As you can see, there's a huge variability depending upon which location you're looking at and which core you're looking at. The data is for the last 50 kiloyears. They were, as I said, again, the isotopic measurements are very less. It's not the large number, only few cores have that data. So we didn't look much in detail of that, but there are people who have looked at the much longer time scales also, going back to millions of years, and again, that data is limited. Now coming back to the different time slices, as I said, this represents the last glacial maximum. Not many cores cover that part. And then coming to the glacial interglacial transition, then the Greenlandian, North Crimean, Meghalayan, and the modern stuff. Now, as you can see that there is a significant change in the organic carbon burial. So it's not that the region which is wherein the organic carbon you find higher during modern times, that region has always been the sink for the organic carbon. No, it changes. It changes with time because of the drop in sea level, because of the shift in productivity and the related processes. Same is the case with the inorganic carbon as well, because although modern times we see again a good amount of the inorganic carbon accumulating here, but then during the glacial times we didn't have that much of the inorganic carbon accumulating at these locations in the similar manner. Finally, coming to the total carbon, and we do see a huge spatial variability in the total carbon accumulation in different parts of the Bay of Bengal during the different time scales. Now that only shows that yes, the centers of carbon accumulation, they change, and what was interesting was that the area over here, it's just the western part of the Andaman Nicobar Ridge and then the central Bay of Bengal. Therein, huge amount of carbon is getting accumulated, and probably that area can still act as, it can accumulate more carbon in both the organic and inorganic form. That's it. So just summarizing that the low CO content in the coastal regions throughout the basin is basically attributed because you have the coarse grains and then the lot of oxygen is available, organisms are thriving and they're utilizing the organic carbon, not letting its deposition over there. And then the finer sediments and low dissolved oxygen that leads to a better preservation of the organic matter. The higher calcium carbonate content on the shelf, definitely because we have more of the calcareous organisms over there. And then once you go onto the slope, because you have low dissolved oxygen, the pH is lower, so the calcium carbonate dissolves partially. But then again, in the deeper parts, you have the favorable water mass that leads to better accumulation of the calcium carbonate in the deeper regions. And we do see a large variability in the total carbon accumulation when we move on different glacial interglacial timescales. Thank you.
Thank you. A question to Rajiv? Yes, Craig.
Yeah.
Yeah, I'm just questioning your use of the term burial and accumulation. I guess in the records that you looked at, how variable was the sedimentation rate that you assessed for different dated cores? How big was the change in actual sediment accumulation rate so that you could convert carbon concentrations to actual accumulation or burial rates?
Yeah, I mean, interesting question, because these cores, some of them had almost 10 to 15 centimeters per kilo a year, and then there were other cores which had almost 50 to 70 centimeters per kilo a year. So that's a huge variability and order of magnitude difference in the sediment accumulation rate. Ideally, we need to look at the flux, and that can be calculated by looking at the calcium carbonate, but then the problem over here, ideally we need to have the bulk density. Though we don't have that data, but we can always make use of the calcium carbonate percentage in the sediments to talk about the density and then convert that into the flux. But then that becomes a bit of a circular hypothesis because we are already looking at the calcium carbonate percentage in the sediments and then calculating its flux. So, I mean, we are still looking at some ways to figure out the flux because that is a better indicator of whether there is definitely a change, a spatial variation in the accumulation or not. That will give us a good idea.
Thank you.
Thank you. I think we should move on to our last presentation given by Sujin Kang on spatial distribution and isotopic signature of particulate organic carbon in the Western Indian Ocean and their interannual variability.
Okay, hello. I'm Sujin Kang from IIOSC. For the last, we will move to the south across the equator. And as you well know, one of the most important role in POC in marine carbon cycle is capturing the atmospheric carbon dioxide and its sink to the deep ocean and stored in the long-term storage. But in this process, not all the POC can be stored in the long-term storage. As you can see in the previous presentation, a portion of the particulate organic carbon remineralized in the water column and go back to the atmosphere as a carbon dioxide form after 10 or 100, even 1,000 years later. So this mechanism, depending on the origin of organic matter and also reactivity, and it also influenced by the physical condition of water columns. So to understand the origin of organic matter is important to understand the biological carbon pump efficiency. So in view of biological carbon pump, we have important region in western part of the Indian Ocean, the shelterless chagothermocline ridge, the famous open ocean upwelling area in western side of the Indian Ocean. So to understand, this region shows the relatively higher productivity due to the rise of the thermocline to the surface. And to understand the variability of this SCTR region, we started the IIOSC Indian Ocean study based on the Kyoto Science Plane, and we started our research expedition from 2017 until now. So under the IIOSC project, we observed the physical environment, epipelagic ecosystem, carbon cycle, and biogeochemistry, and we also try to understand the STTR variability. And I'm in a carbon cycle and biogeochemistry team to understand the organic carbon variability in the Western Indian Ocean. So today I would like to introduce some results from the surface particulate organic carbon research. And in this study, my research question was whether they have spatial and interannual differences in particulate organic carbon variability, especially on concentration and sources. And I also want to see if there is interannual differences in source and production mechanism of POC, and also they're linked to the biological carbon pump. So to get an answer for that questions, I collected the particulate organic carbon samples from 2023 to 2025 along the 65 east line from equator to the 20 degrees south. And after collection of the particulate organic samples, I measured the concentration and stable carbon isotope of those samples. So we also get basic environmental parameters variability, the surface temperature, salinity, and the 20 depth, which is showing intensity of the upwelling in the STTR region. So as you can see in the shaded in blue, the core, the center of the upwelling zone located between 6 to 10 degrees south, and the upwelling intensity was strongest in 2023. So from now, I will show the POC result from top to the bottom. We check the POC concentration to see the amount of the carbon, and we also see the citron ratio to understand their source of organic matter. And for the last, we check their stable carbon isotope to understand the information about their source and carbon cycle processes such as carbon uptake mechanisms. So in 2023, as you can see here, the little variability in POC concentration in upwelling center. In case of citron ratio, we can see the very low and stable citron ratio. In case of delta C13 value, it shows around -24, which means the typical value of marine-derived particulate organic carbon. In case of 2024, the little minimum variability appears in POC concentration, and the little higher citron ratio we saw compared to the 23, but it still low value. Interestingly, we can get 3 or 4 per mil lower value than 23 in 2024. In case of 2025, the POC concentration, citron ratio, and the delta 13C values were similar to those from the 2024. So to answer my first question, whether they have a special difference of particulate organic carbon characteristics, I compared the carbon concentration and their stable carbon isotope divided into the upwelling center and the site. The orange color shows the site result, the blue means the center result. So as you can see in the first column, the POC concentration appears to be a little higher in the core of the upwelling zone, but it is not significant, not statistically significant. In case of the delta C13 value, it shows the weak spatial variation within the same year, but strong temporal shift with the year, but they have a statistically same through the year and within the year as well. So this result suggests the carbon concentration, source, and uptake pathway are regionally consistent with within the same year. So for the next, to see whether they have interannual differences in POC characteristics, now I combined all the result from 3 years. So from the first column, we can see the POC concentration. They have a little variability, but they showing a relatively consistent in concentration interannually. And in case of cistern ratio, they showing a very low value. That means the primarily marine drives organic matter. And in case of delta C13, it was a little different. As you can see in previous slide, the higher delta C13 value in 2023 with the strong thermocline belling in this year, maybe this change in environmental change enhanced the phytoplankton community change, maybe shift to the more large size dominated. So this resulting in the biogeochemical signature, a distinct signature in 2023 compared to the other years. So from this result, at the time I had one additional question, then whether they have same POC sources in 2024 and 25. So to get an answer for this question, I look into the total chlorophyll A concentration. So as you can see in first column, we can see the very highest concentration of chlorophyll A in 2023, and we can see very low concentration in 25, and it results in very high value of the POC to chlorophyll A ratio in this year. Which represent the proportion of phytoplankton with total organic carbon. That this high value means the dominant source of POC in 2025 maybe from the non-living phytoplankton, such as detrital materials or fika pellets. So putting all those information together, we can get a following conclusion. From the cistern ratio and delta C13, we can get the information about the marine-derived organic matter dominate across all years. And from POC, and for the next, the relatively positive correlation between POC concentration and delta C13 value represent the higher phytoplankton productivity, reduce the fractionation, isotope fractionation. And for the last, the low value of the POC to chlorophyll A ratio in 2023 and 24 represent their major source coming from the phytoplankton, but their different isotopic signature means their size is different. Maybe large size dominated in 23, while small size would be dominated in 24. And while more detrital input was dominated in 25. So for the last, when you think about the last question, they're linked to the biological carbon pump. Maybe their concentration was not significantly different. But when you think about the food quality as an energy source to the higher trophic level, maybe it would be highest, the quality was highest in 2023 and lowest in 2024. In case of carbon storage ability, how will carbon POC capture the carbon and sink it to the deep ocean? It also expected to be highest in 23, low in 24, and maybe variable in 25, depending on the detailed composition of those sources. So for this result, we can get the information. Even though they showing similar concentration, their quality and carbon storage ability can be different, and it also results in the difference in biological carbon pump efficiency. So here is end of my conclusion. So we will connect our research to the sediment trap data and higher trophic level data to for the further study. Thank you very much.
Thank you. Xinjing. Questions to her presentation? Yes.
Yeah. I can
Okay,
hear you.
a very, very interesting observation. I have two doubts or question rather that in 2023, the chlorophyll is very low and you have warmer water mass. And when you do right? Yes, so 23, you have high chlorophyll and isotopic signatures are different, right? Delta 13C POC in 2023 is lighter, right?
You mean the...
If you go back to the previous slide. Yes. And then, yes. Yes, you can stay here or the next. So your POC values and delta 13C values, when you compare, have you also considered grazing by single cell? That could also change the isotopic signature when there is low nutrient at the surface.
So you mean the grazing
by
impact?
Yes, grazing by microzooplankton because they will also come in the same particle. And
yes.
that can change also the isotopic ratio, particularly when nutrient levels are low.
Actually, I didn't check that effect. I will check that too. Thank you for your comment.
And the second one is when you do a correlation with carbon and chlorophyll, and if you have the slope values, that also tells about the source. I mean, you didn't keep the slope value of the equation. You have a slope, right? When
yes,
you have
yes, right.
x and y. So if you have the slope value, that also indicates where the source of organic matter is coming from. We have similar observation.
Yes,
and
right.
my question was, do you have phytoplankton community composition?
Yes, the other team in our project, they have a phytoplankton composition, and they saying the diatom was dominated in 2023, while the more small size plankton such as was dominated in 24.
Yeah, that makes sense. Okay, I hope I'm not taking too long. And there is nothing like long-living phytoplankton. They don't live for more than 4 to 5 days. So maybe you can take into consideration. Thank you.
Okay, thank you.
Thank you. Maybe you can continue this discussion at lunchtime. Thank you very much. And I will give the floor to Chandan now.
Thank you for all the presentations. With this, we will conclude this morning session and we will break for lunch, which is done. And for the afternoon session, we have the oral talks and the flash talk. Oral talks will be from the 2 p.m. to 3:30 p.m. I request all the presenters who didn't submit their presentation for the afternoon session, I can please submit to me so that I can make the things easier with all the limited time constraints. And afternoon we will be having the Professor Lynette for this oral session, and for the flash talk we will be having the Dr. Rajiv Saraswat. Yeah. Thank you. We will meet at 2 p.m. I think you had a beautiful lunch. Now we will start with the afternoon session with the theme 6, unique geological, physical, biogeochemical and ecological features of the Indian Ocean. Now this session convener will be the Professor Lynette. Professor Lynette is from the Perth, Monash University in the Perth, Australia. Lynette holds a Doctor of Philosophy degree and her expertise in fisheries science, biodiversity, marine protected areas, biological oceanography and ecosystem. She is very instrumental in the IIOE2 expeditions and all those things. Now in this session we are having the 6 oral presentations. After that a short like a tea break. Then we will be having the 7 flash tags. Now I hand over the session to Professor Lynette to carry on.
Okay, good afternoon everyone. For this session we've put together sort of phytoplankton talks. So hopefully it's a kind of coherent group of talks. And our first speaker today is Hiroaki Seato from Japan, talking about phytoplankton dynamics in the Eastern Indian Ocean.
Thank you very much for introduction. And my talk is like this, and I'd like to introduce my colleague, Fumio Hashiyama. He's carried out very nice high sensitivity nutrient analysis. And Suju-jan is working hard about this incubation and metagenomics analysis. And we have been carried out ecosystem study in tropical ecosystem and understanding the ecosystem structure, dynamics, and the factor influence variations. And we carried out North Pacific cruise in 2017, and that here, and we also carried a 2018 Eastern Indian Ocean cruise. And the objective is the imbalance between the phytoplankton growth and mortality and the induced phytoplankton surface bloom in the North Pacific or Indian Ocean. And this is a result from the North Pacific cruise. We carry out like this, and the Prococcus green is dominated throughout this vast ecosystem. And we carry out a Danish experiment to get the growth rate, and very interesting, nutrient is almost depleted totally, less than 10 nanomole DIN, but the Prococcus did very high growth rate, 1 division per day. And here, this result is already published, but we understand Prococcus can grow very high rate, even very low nutrient concentration. We continue this study in the Indian Ocean 2018, and this is a study area from Bay of Bengal to 20 degrees south, and we divided into 3 regions by physical oceanography properties in Bay of Bengal, Equator, and the Southern Station. And you can see this is the intermonsoon period, so you can see the very strong wiki jet here in the tropic. And this is a movie I cannot move, but we see some phytoplankton bloom observed in tropical area under the wiki jet. So yeah, maybe, this is just a satellite movie, so okay, let's move. So this is an environment, and DIN is almost depleted. Less than 2 or 3 nanomole for nitrite, PO4, so almost totally depleted. But PO4 is relatively high in the southern area and the equator under the wiki jet. And the chlorophyll like this, and you can see some high chlorophyll in the equator under the wiki jet region. And we did a Danish experiment. Mike established, he's here, and obtained the growth rate of the phytoplankton. And this is a result that chlorophyll concentration high equator, but it is very interesting, growth rate is negative. Net growth rate is negative. This means the microzooplankton grazing overcomes the growth rate, even high, even high chlorophyll concentration. By satellite image, we observed this bloom disappeared in a week. So this is a quite imbalance between growth and predation. And this is a Phytoplankton community. You can see the Prococcus green is dominated, as even equator, and dominated. But sorry, we see high. This is a growth rate of each phytoplankton community. DB is a Divini chlorophyll. This means a Prococcus, and you can see in many areas, Prococcus or Synechoccus showed high growth rate compared to the eukaryotic phytoplankton. And because of the nitrate is almost depleted, totally depleted. This is a similar situation in the North Pacific. And this part is published in this paper. And so we are targeting the Prococcus. You know, Prococcus is the smallest phytoplankton and the most abundant in the ocean ecosystem or planet, and mostly distributed in the warm water region, and they are very key player in food web dynamics and the biogeochemical cycles in the oligotrophic, tropical, subtropical marine ecosystems. So Prococcus is we say just Prococcus, but they are very diverse, and their gene sizes are 1,800 to 2,000 genes, very, very small, but the total collective Prococcus genes are 80,000. So we say Prococcus, but Prococcus itself is quite a variety group of phytoplankton. So our question is, can we estimate the physiology and ecology of Prococcus from gene composition? Is one of the questions we had. So we carry out metagenome analysis using shotgun genome sequences, and using the GenomeMaple, we examine the abundance of functional gene module related to the nutrient utilization of Prochlorococcus. We also carry out incubation experiment, a digestion experiment, and using flow cytometry and HPLC analysis, we examine the physiological status and the growth rate of the phytoplankton or Prochlorococcus. And this is a visual characteristic cell size in the Bay of Bengal, equator, and the South Indian Ocean. You can see a big difference. This difference was almost 2 times of the carbon volume. So Prococcus size itself is totally different, and cellular chlorophyll is very different each other. Okay, and you can see in Southern Indian Ocean, size is small and the pigment concentration is low per cell. And this is the growth rate of the Prococcus. You can see growth rate, gray is without nutrient. This is ambient growth rate, and dark gray is with nutrient. So nutrient assimilate some growth increase. You can see in station 1 Bay of Bengal, growth rate itself is very low, and but the addition of the nutrient increase the growth rate. And from station 3 to 5, especially equator station, their growth rate is high, almost more than 1 division per day, and their stimulus by nutrient input is not very high. And in the southern part of the Indian Ocean, growth rate itself was very low, and it is very interesting that the addition of nutrient decreased growth rate. I don't have this very good reason at this moment, but this is also very interesting result we obtained. And this is the ecotype composition. You can see this is the sample is collected from 10 meters. So most of the stuff is ecotype HL2. This is highlight adaptive for Prococcus. So my talk is mostly depending on this highlight to ecotype. And this is abundance of the functional gene related to the photophorus utilization. And this is a relative abundance of the gene, functional gene, so relative to minimum abundance station. So you can see phosphate transport system is almost same, no difference between. And the phosphonate transport system almost no difference between station. But you can see the phosphate starvation response gene is very abundant in the Bay of Bengal. Bay of Bengal is a very low phosphorus concentration and relatively high nitrate. In this region, maybe Prococcus is starved by phosphorus. But in southern Indian Ocean, phosphorus is maybe okay because of the very high concentration in station 9 and 10. And this is a good relationship between the phosphorus concentration and this phosphate starvation gene abundance. Next is nitrate utilization. And urea, no difference. Most of the Prococcus can use urea throughout the Indian Ocean, but you can see the assimilation of nitrate or nitrite or some NIT-30 family transport system. This is also used for nitrate and nitrite utilization. You can see it's very high abundance of South Indian Ocean. It is very strange that because in the northern part, Prococcus have more chance to receive nitrate by atmospheric deposition, nitrification from the waters coming from the coastal. But in the southern part, almost no chance to support nitrate because of the very strong thermocline and very remote from the continent. And this is also very interesting part of this finding. And this is iron related. So of course, every Prococcus can use iron ion. This is very natural. But this is iron complex transport system related starvation. And this is because some iron is some complex molecule with a ligand, and this iron complex transport system is used for not ion transportation uptake, but some kind of ligand-related iron. So you can see the very high abundance of iron complex transport system in the south part of the Indian Ocean. This part is very iron limited, and this is very reasonable result or very easy to understand. And so this suggested Prococcus in South Indian Ocean is leading to the starvation of the iron, and they try to use iron ligand complex. So this is conclusion, and we don't, because of time limited, we don't need everything. But one question is why Prococcus keep genes of nitrate utilization in the south part of the Indian Ocean? This is no nitrate at all. This similar stuff is result was observed in the Pacific or other ocean. So maybe it is still not quite sure, but this redundancy may useful in some very limited stages, but we don't have a very good answer. And of course, we have a different physiology of the responsible nutrient addition between stations. So, and we are very surprised that the decrease of the growth rate in the southern part of the Indian Ocean. And I don't know why still, but the potential influence of high light level, 50%, or luxury nutrient uptake observed in the large phytoplankton, I'm not quite sure. And so we may need longer incubation, not just one day. So this is a conclusion. So one question is, we know more about Prococcus, and I understand Prococcus very wide variety of functions. They are totally different between regions. And one question is very important is, can we make best Prococcus model for food web dynamics and biogeochemical cycle? Because Prococcus play very important role of the ecosystem dynamics and biogeochemical cycles. Without understanding the Prococcus, our model is not very powerful to reproduce and predict the future. And okay, thank you very much.
Thank you very much. We have time for a question. Mike Landry, right in the front.
Did you find any evidence for strain variability in the Prococcus population between your different sampling areas? In the ocean, highlight 2
ecotype is dominated. And in the Pacific, highlight 2 ecotype is also dominated, in my understanding. But of course, highlight 1 type is also observed in the other ocean. But yeah, we have not enough information about the depth distribution of this ecotype and also functional gene composition. So we need further study, I'm quite sure. But this is a very beginning of the study to know how high diversity they have, and their function totally different between oceans or between the same in the region, between region in the Indian Ocean.
Okay, thank you very much. I think we have to move on to the next talk. Are you going to introduce it or?
No, you.
Okay. So our next speaker is Aparna Mol, and she's talking about patterns of dinoflagellate vertical descent in the Indian Ocean, distribution, diversity, and ecological factors.
Next slide, back slide. This is the pointer.
Good afternoon all. Myself Avarna, Senior Research Fellow from CSIR NIO. So today I am here to present my research work. I'm talking about one of the most fascinating marine microorganism, that is dinoflagellate. So my research topic, what I am going to present here is patterns of dinoflagellate vertical descent in the Indian Ocean, its distribution, diversity, and ecological factors. So we know a lot about dinoflagellates in the euphotic zone, but its vertical descent, that is what is happening, how the distribution of these dinoflagellates beyond the epipelagic zone, that is the euphotic zone, are yet to be explored. So let me come to the point. Why study dinoflagellates? So these dinoflagellates are one of the most, we all know they are ecologically significant primary producers in the water column, and they contribute around 20 to 60% of the phytoplankton biomass. One of the unique feature of dinoflagellates are they can perform 3 modes of nutrition: autotrophic, mixotrophic, and heterotrophic mode of nutrition. And they can exist, they are both planktonic forms are also there, benthic forms are also there. Their species statistics says that around 2,000 living species are present. Among them, 200 species are cis producers. Dinocis producers, that is, dinocis means multi-layered walls. Dinocis are their reserved material with the multi-layered walls, resistant structure. They can be used as environmental proxy. And among these 2,000 living species, 45 are toxin producers. So they are important in the aquatic food web, the base of aquatic food web. They are both toxin producers and can form harmful algal blooms. They have symbiotic relationship with invertebrates, and they can also produce bioactive compounds. They are key contributors to marine biogeochemistry, and what I am dealing here today is their distribution beyond the epipelagic zone, and it contains their trait with depth includes morphology, trophic status, and symbiotic association. So to deal with this topic, we have done sampling. Our sampling location is 2 contrasting areas in the Indian Ocean, that is northeastern Indian Ocean and south tropical Indian Ocean. In the northeastern Indian Ocean, I have selected 2 stations, and in the south side, I have 6 stations. And we have done sampling using a multiplankton net, the vertical howling of the water column, the full water profile we have taken. So here, the first zone is epipelagic zone, which is from the surface to 200 meter, and the second one is, the second depth is mesopelagic zone, which is from the 200 to 1000 meter, bathypelagic zone 1000 to 4000 meter, and abasopelagic beyond 4000 meter. We have done a vertical howling in this area. So here comes the environmental parameters. temperature, salinity, density and DO we have measured here using the CTD. Temperature says that there is in both NEIO and STIO, both NEIO and STIO, the temperature is warmer in the surface. As we go down, it is cooling down. Then the salinity in the northern side, there is freshening up of salinity. Then almost consistent in the South Tropical Indian Ocean. And DO remains higher in the southern region compared to the North Equatorial Indian Ocean. And here comes the analysis part, that is the talking about the dinoflagellate species distribution. So here all over we have recorded 156 microphytoplankton, which is above 100 micrometer. So the multi-plankton net what we have used is the size of the mesh is above 100 micrometer. So we have here among the 156 microphytoplankton what we have recorded, 73 are diatoms, 82 dinoflagellates, 1 silicoflagellate. The diatom part, the vertical descent of diatom part will be dealt by one of my colleague. So coming to the species contribution, the South Tropical Indian Ocean has recorded more dinoflagellates. Around 60 species are there compared to the diatoms, where this North Equatorial Indian Ocean recorded a comparatively lesser number compared to the diatoms. And coming to the dinoflagellate descent, regional comparison, the regional comparison states that only 1.1% from the epipelagic zone, only 1.1% of the dinoflagellate species are abundance is reaching the bathypelagic zone, and in STIO around 1.3% of epipelagic abundance from the epipelagic zone is reaching the abasopelagic region. So the analysis states that the STIO, the South Tropical Indian Ocean is supporting higher descent of dinoflagellate abundance into the deeper zones. Then here comes the vertical stratification, how these species are distributed overall the pelagic zone. So in the epipelagic area, in the epipelagic zone, a total of 138 species were recorded, and in mesopelagic 75 species, bathypelagic 51, abaso 19 species. So higher diversity of dinoflagellate was observed in the epipelagic zone around 77, and 18 dinoflagellates in mesopelagic, 13 in bathypelagic and 4 in abasopelagic region. So from the epipelagic to mesopelagic region, only around 46% of loss is there from epipelagic to mesopelagic region. When we go to bathypelagic region, only 36% is reaching in this zone, and here only around 40% of total dinoflagellates are reaching the bathypelagic zone. So here we have to address the question, how do these dinoflagellates distribute vertically across the pelagic zones of the Indian Ocean? So the solution for this question is their functional traits. So this functional trait is addressed with 3 main key points: morphological stratification, trophic status and symbiotic depth barrier. So first we are going to look into the morphological stratification. Here I have classified the dinoflagellates based on their cell wall, that is athicates and thicates. Thicates with cellulosic cell wall and athicates without a cellulosic cell wall. So here what we have observed is the epipelagic area. Epipelagic area supports both thicate and athicate. There both thicates and athicates are present with equal contribution. When we go down in the mesopelagic area, athicates, there is a sharp decline in the athicate distribution, and coming to the bathypelagic, again further reduction in athicates are both athicates and athicates are reducing, but a sharp decline we can observe in the bathypelagic region, and in the abasopelagic region only thicates are present, athicates are completely absent. And one more key observation what we have seen here, there is tripose dominance. Around 36 species of tripose are present, and it contributes 79% of the total dinoflagellate diversity is occupied by our tripod species, and among them 3 key species, Tripos cariensis, then Contrarius and Schrangi are reaching the abasopelagic region. Then coming to the second one, trophic status. So here I have classified again the dinoflagellate based on the trophic status. Autotrophic dinoflagellates, mixotrophic dinoflagellates and heterotrophic dinoflagellates. So here maximum number of dinoflagellates were mixotrophic followed by heterotrophs and autotrophs. So the species regional comparison states that mixotrophs are dominant in both the region. Coming to the pelagic classification, here the epipelagic region supports more mixotrophs, then it's reducing towards the mesopelagic region, again to the bathypelagic, and in the abasopelagic region, heterotrophic dinoflagellates are completely absent, and mixotrophs are more dominating than the autotrophs. The third one, the symbiotic depth barrier, which is supporting the vertical distribution, that is the symbiotic depth barrier. So what we have observed here is there is an environmental filter in each zone. Each zone there is environmental filter. So here only symbiotic dinoflagellates are present only in the epipelagic zone. Among those 82 dinoflagellates, 9 species were symbionts. Among the symbiotic dinoflagellates, they were restricted only to the epipelagic zone. So what are the factors that influences the symbiotic dinoflagellates are? One might be light starvation, because symbiotes that supports symbiotic dinoflagellates requires light. Then ethicate vulnerability. There may be some species, there are ethicate dinoflagellates which are very delicate and flexible, and when it moves down, when it descends down, there is temperature drop and hydrostatic pressure, which is not helping them to survive in the below the epipelagic zone, and their compromised structure, that is mechanical stress, osmoregulation, failure, degradation, these all results in the, these all restricts the ethicates or the delicate cells to descend down. Then these all key points are leading to the one and only principle, pelagic zone filtration. So each major zone possesses their distinctive environment, distinctive filters. It is environmental filters are there, biological filters are there, trait-based classification are also there. So in the environmental filter, temperature, salinity, light, density, these all are playing major roles. The biological filter, grazing pressure is there, predation is there, trait-based classification, what we have addressed before, morphology, trophic status, physiological adaptation, these all are playing major roles. So in each pelagic zone, in the epipelagic zone, here the filters are high light and productivity. High light, which filters the symbiotic taxa. The mesopelagic zone, their physical and metabolic stress is there. Here ethicase declines sharply, and in the abasopelagic pelagic area, their maximum structural resilience and trophic flexibility is required to live there. So only survival of robust acta, that is thickets, are only possible there. So in the conclusion, what we can see is epipelagic zone supports high diversity and abundance, because this area, epipelagic zone, supports delicate and complex species. We can observe regional differences that reflect distinct circulation and productivity pattern. Then the dinoflagellate vertical structure influences carbon cycling and energy transfer. Here we can observe functional trait filtering that reveals ecosystem resilience to depth gradients. Then dinoflagellate vertical descent is a multi-factor ecological process, and pelagic zone filtration. So in this one, it integrates morphology, trophic strategy and environmental adaptation. And in future, we have to address the genomic and metagenomic approaches to explore functional adaptations in the deep populations to identify the factors. So thank you for your kind attention. Thank you.
Thank you very much for that fascinating talk. I had no idea there were abyssal dinoflagellates. Are there any questions? We have time for one. Must be someone with a question. Well, I'm not an expert in this, but how do you get autotrophic dinoflagellates in the abyss, in the abyssopelagic?
Sorry?
You said there are autotrophic dinoflagellates. What are they using to function? What are they, as opposed to, I can't remember what you said. Yeah, I was really surprised to see autotrophic dinoflagellates in the abyss.
Yeah, actually autotrophic dinoflagellates mainly, they are thicates.
Yeah.
So they can survive there.
Yeah.
With their complex structure.
Okay. And mixotrophy was dominant though?
Yeah, mixotrophy was dominant.
In that area. Okay, any other questions? Anyone at the back? No? Okay, well, we better stop then. Thank you very much. Okay, we not quite on time, but we're getting there. The next speaker is Baraja Kumar Sahu, and he's going to talk about a preliminary study of the distribution and diversity of rhizarians in the Arabian Sea.
Good afternoon all. Myself Biraj, and I will be presenting a preliminary work on the distribution and diversity of rhizarians in the Arabian Sea. So you can see a photo, this one. It is one rhizarian, you can tell Acantherian. The name is Lithoptera, means stone wings. So the skeleton is made up of strontium sulfate. So it was initially reported in Indian Ocean in 1967. And to our knowledge, I think this is the first photograph from Indian Ocean region, because previously no photograph was there. So coming to basics of rhizaria, what are rhizarians? These are normally single-celled protists, and that includes radiolarians, foraminiferans, and cercozoans. So in this study, we've just focused on these 6 groups like that: Acantheria, Phaeodaria, Colodaria, Spomelaria, Nesilaria, and Toxopodida. So mostly Acantheria, their skeleton is composed of strontium sulfate, this one, and others mostly it is siliceous skeletons we will get. And their mode of means mostly they are heterotrophic or mixotrophic. Mixotrophic in the sense they are associated with phytoplankton symbiotically. And they represent an understudied group in the ocean biology and also in biogeochemistry. So what is the importance? Why we should study this one? So one study, means one in situ imaging revealed that there is a huge number in the normally you call Giant protist, means that one rhizaria it will come. So in the global ocean, this is a 2016 study, and a lot of papers on their exporters like that, how they export carbon to the deep ocean, and vertical export, and in the California current system. And after that they studied their carbon and nitrogen content. Then in biogeochemical, what they play main role. So that same study initially by Beard et al., it is the study of Tara Ocean expeditions. So what they study is with that mostly the rhizaria, their contribution in the whole zooplankton, it comes to nearly, if we average it, it comes to 33%. And one recent study, this year's study, they are telling that, in quote what I wrote, approximately half of radiolarian diversity remains to be morphologically described. Means in metagenomic studies, we get that some species is there, but morphologically till now it is not described. So what our study area in the Arabian Sea, this is the OMZ area. It was already, I think many people have gone through. So I will skip and go to our sample collection areas. So these are the 7 stations we studied from February to March this spring. And that zooplankton samples we collected through multiple plankton net. So 5 different layers we covered up to 1500 meters. And that 5 means we considered ZP1 means above chlorophyll maxima, then ZP2 means near to chlorophyll maxima area, then after chlorophyll maxima to start of OMZ area, then oxygen minimum zone area, then when oxygen minimum zone means when the oxygen starts to rise and up to 1500 meter depth. So during the study area, what are the SSTs, sea surface temperature? Normally we can see the cooler waters in the northern parts and the warmer waters in the southern part. This is the sea surface height. So we can see the red color, this one, I think Bay of Bengal water may be coming with the current and here dissipating in the northern part. And chlorophyll in that study time may be less available data. So if we see some chunks like that here, high productive area compared to here low, like that low productive area compared to northern part. So this is the in situ parameters CTD data what we get. So initially this 1, 2, 3, 4 stations, we can tell it comes under OMZ area, and these 3 out of OMZ area, if we see. And the chlorophyll also, we can see a peak compared to first station, this IIR14, we get a high chlorophyll peak compared to other stations. So if we see the zooplankton composition from station wise, from north to south, if we compare just see copepods and rhizarians and other zooplankton in other groups, we can see how depth-wise this is the surface and this is the deeper water. So how the rhizarians, they contribute to the whole zooplankton groups in all stations like that. But in deeper waters, we can see in some stations it is high. And in the rhizarian, we can see other groups like that. What is the composition of the rhizarian groups? We can see acantharians, foraminiferans, phaeodarians, and collodarian, nacillaria, spumellaria. So in the surface water, if we see the acantharias is dominant, and in the deeper waters we see spumellaria or nacillaria, means it is a polycystin group, so they are dominant. So if we see why this acantharias dominant in the surface waters, normally they are symbioting with some phytoplankton, so they need light. So in that surface, means in photic layers, there will be more. So as a whole, if we see that acantharias group, it is a high in the surface water, then it continuously reduces. Compared to this polycystin group, it is less in number, and in the deep waters, it is high in number. And if we see this phaeodarea group, we can see one peak we are seeing here and another peak we are seeing here. So in the OMZ layers, after the OMZ layers, we can, means after photic layers, we can see one peak. After OMZ layer, we can see one peak like that. And coming to some new report, because through the study as it was new to this area in the Indian Ocean. So this one, I think these 2 species are new to Indian Ocean, and these 2 species, means it was earlier reported in southern Indian Ocean, but now we got in northern Indian Ocean. And here one important phaeodarea that is the size of 4,000 micrometer that we got only in deeper waters, that is 1,000 to 1,500 meter depth. And in surface water, some peculiar things we got that this colonial colodaria or acantharia, they were more, and they were associated with this photosynthetic algae. So in future prospects and conclusion, what we can tell, as these groups are dominant in the top layers, and if we see from climate change perspective, if stratification is there, so this group, this acantharia or colodaria group will be benefited. So they may dominate also, but we need more studies to that. This is the thing. And these are the Harshita and Pravindra. These two people only done these major works of this one. And this one, what I told you, this figure, this is one colodaria, solitary colodaria. So this was earlier reported in metagenomic study in Indian Ocean. But first time we got that morphological structure. And these are that symbiotic algae like that. This one. Okay, thank you.
Thank you very much. We've got plenty of time for questions. I hope we have someone who can help me out here. Come on, Mike. No one knows anything about Rhizaria in the audience? Jenny, you can help us out.
Thank you. Your photos are beautiful. It's exciting for me to see this. So I've got some samples where we've been looking for some of these organisms that we imaged with the flow cam. So not getting the same beautiful resolution that you're getting with yours. But the one thing we found that was very interesting was we sampled an eddy, so it's sort of mid-ocean eddy that had come off the shelf of Madagascar. And within the eddy there were lots of radiozoans and hardly any on the shelf in comparison, whereas other organisms had been advected from the shelf. So do you know what drives the dynamics of these radiozoans and the concentration? Are they kind of like diatoms in getting fed by nutrients uplifted with upwelling and things like that? Have you got any feel for the dynamics? It's a bit of a left field question, sorry, but
as this is a very preliminary work, still I can answer like that. In our study, wherever we got means less copepers, this group it dominated like that. So whenever this means in any layer like that, wherever copepers were less and the competition was less, so we got high number. But if you see some groups like fjord area, they were down, means bigger. If we compare from surface to down, their size also increases, that fjord area. And it is also, we can relate it with particulate organic carbon, sinking particulate organic carbon, because its food depends on that only.
Yeah,
so maybe if POC is also high, means their number will be high also sometimes.
Thank you. It was a fascinating talk. There's lots to look at still.
Thank you.
Okay, anyone else got a question? Oh, we got one over here. Thank you.
Good afternoon, sir. Mostly I want to ask about how do you preserve your acantharians after you collect them? Because sometimes in my samples, I end up, there's a lot of degradation. After bringing them back to the lab. We do get them. Sometimes if the sample has gone a bit old, we will get the acantharia where the spicules are somewhere else and the body is somewhere else. And then the identification becomes really difficult. So what would do you have any suggestions as to what would be a good preservative?
Preservative means for zooplankton, normally if you are not careful with the zooplankton sample, all will got dissolved. Yes, yes. So for acantharians, you have to use strontium sulfate. Otherwise, you will not get while sampling. Nothing, yes. Not a single one also
goes
you
in
will
formalin
get.
Sample. The first, that's the first thing I noticed.
Yes.
So it won't be there.
So you need the analysis as fast as done like that. Otherwise, you will lose everything. That one. Okay. Because these organisms are more fragile. If your keep and got mixed with something, all cell structure will also get lost like
Yes,
that.
so in the same sample, I would get I would get the dinoflagellates and my ciliates, and they'll be fine. But the acantharians would be the first to degrade. So, so I suppose formalin or ethanol, these won't work as well as. So you suggested strontium sulfate for this?
For Acantharia, strontium sulfate is there, but others you can concentrate and keep it, because otherwise analyze as early as possible. Otherwise, it will be morphology. It will be get lost like that.
Sir, another question. You said most of the acantharians are having photosymbiotic relationships, so we can call them exotrophs. So what about acantharians who do not? There are many acantharians who do not have symbiotic associations. So would we find them in bit lower down the water column, 10 meter, 20 meter? Because I've not finished identifying some that I have got, but I'm very sure they're not having symbionts so far.
No, we are looking into that. In deeper waters also we got the acantharians, but sometimes only without any organic matter, sometimes with only skeletons we got. So we are just looking into that question also, but it will be very preliminary to say that.
Okay, thank you for the question, thank you for the answers. We may have to move on now. Thank you very much indeed. Our next speaker is Akur Sharma, going to talk about embarking on a diatom odyssey. So we've had vertical descents, and now we've got an odyssey with diatoms. Hopefully his talk will pop up soon.
Backslide.
Yep, there we go.
Hi, good afternoon everyone. I'm Ankur Sharma, Senior Research Fellow in CSI NIO and Registered for PhD in ACSIR. So today's topic is embarking on a diatom odyssey, insights from a systematic study across paleozoic zones in equatorial and south tropical Indian Ocean. So first of all, why diatoms matters? So whatever, take a 5 breath. Out of 5 breath, the 1 breath you are getting, that is approximately 20% of oxygen we are getting, is only from diatoms. Apart from oxygen, food webs, they are the primary producers, so contributes in a food web. And even in a environmental bioindicator also, is there is a slight change in salinity pH. They are the one of the most significant that reflect in a environmental bioindicator. That's their contribution when they are alive. And even after their senescence also, they contribute in a biological carbon pump as they die down and contribute significant in a carbon sequestration. So diatoms are so important, but despite of this, most of the studies just focused on the 4.5% of water. That is still epipaleozic. 95% water, that's from mesopaleozic, bathy and abyssopaleozic, is still understudied. So this is the journey of diatoms from the surface, that is from 0 meter to the 5,000 meters. So this is my study area. Here, equatorial Indian Ocean is AIO and South Tropical Indian Ocean is STIO. In stations which are in proximity with islands that are mentioned as A, that is A1, A2, and similarly in STIO which are in proximity to island, that's been mentioned as a A1, A. And this is a bird eye view, and this is our vertical view. Here, vertical view, you can see that equatorial Indian Oceans. Here, depth of A1 is just approximately 1400 or 1500 meter, and that's a bathymetry profile. And here sampling is not done at a single point. We had hauled with the help of multiple plankton nets from one location to the another one. So thousands of gallons of water is being filtered out and during this study. So our sampling was done with the help of RV Sindhu Sadhana during spring inter-monsoon, March to June 2021. And here samples were collected with the help of Hydrobio's multiple plankton nets having a mouth area 0.25 and pore size is 1000 micron. And it was vertically hauled. And physical parameters were CTD sensors that measure salinity, temperature, density, fluorescence, oxygen, And while we collected the samples, they were preserved in a 4% of formalin. And for our convenience, we had divided the depths into the epipelagic, mesopelagic, like that. For example, 0 to 200 epipelagic, 200 to 1000 meso, 10,000 to 4,000 bathy, and so on, abysopelagic. So as the hydrography is that this is distinct area, obviously hydrography is also distinct. We found that temperature in equatorial Indian Ocean is comparatively higher. That probably because of Indonesian through flux, and subtropical Indian Ocean surface salinity is more variable in the equatorial Indian, whereas subtropical Indian Ocean waters more stable, and at a certain depths more coming to a common salinity as a deep water. And oxygen, we can see that in mesopelagic, in equatorial Indian Ocean, there's the existence of oxygen minima, whereas in South Tropical Indian Ocean, there's nothing as such. And fluorescence, we can that chlorophyll maxima is comparatively higher in equatorial with respect to South Tropical. So collectively, the observed gradient in temperature, salinity, stability, and oxygen point to distinct water mass structure between equatorial Indian Ocean and South Tropical Indian Ocean, with likely consequences for regional biogeochemistry and habitat distribution. So what are my findings? These are my findings that I had pasted over here. So finding 1, dramatical vertical diatom abundance decline. So in equatorial Indian Ocean, that is station 1, here we find the abundance was the highest. And not even highest, in Chlamycodium fruelfangium, it was contributing approximately 50% in equatorial Indian Ocean, this station. So why it's so? And as the previous study has been done, Chlamycodium seems to be home in Bay of Bengal. This study also, and previously it's considered to be home in Bay of Bengal, and their abundance declined when we move towards the South Tropical Indian Oceans. And species such like a Planktonella were omnipresent in all equatorial Indian Ocean and South Tropical Indian Ocean throughout the entire depth. But interestingly here we can note that whatever the species that are present in epipelagic zones are not necessary to be presented in abysopelagic zones. So species we are considering that a diatom-mediated carbon sequestration is there. But that doesn't mean all diatoms are reaching to the abysopelagic. Some are already lost in a grazing process. So not all are reaching. And only certain species are able to reach. Sorry, but I'm having some issue. And one more thing. Here, Astral Emperor Murrell indica. I was thinking that why Astral Emperor Murrell indica is present in epipelagic till abysopelagic, and it's not broken, fully integral one. So I was thinking how it's see. So it has a tuning fork-like structure for that is able to bear them this much of pressure of 5,000 meter, which make them intact till 5,000 meter also. So there are several species like Astral Emperor that is having tuning fork structure that make them maintain their integral structure because of the tuning fork, and similarly like Scosinodiscus also were able to present till the bottom of them. Now these are the taxa based, and now I am coming to the morphological filtering. Here all the shapes were classified to complex and simple shapes. Complex one having a red ring, and where simple is a blue ring like that. And complex elliptical prism plus 4 cones, and cylindrical 2 halves, and simple one was a symboloid cylinder box like this. So here we can see that in epipelagic there are complex shapes are presented, but when we comes down to the bathy and abysopelagic, there is only simple shapes are present. Why it's so? Probably because of the they are having their structure is complex. So when they sink down, their resistance increases. Because of them, they are not able to reach to the bottom. Whereas simple shapes, among simple shapes, look into the cylinder, that is the black in color. Here contribution increases when we goes down towards the depth. So shape-wise also, not all shapes are contributing and reaching to the bottom. Only certain shapes like simple shapes, and among simple shapes, cylindrical shape is able to reach down to the bottom. Now, as I have shown you earlier, that equatorial Indian Ocean A1 and A2 was in proximity, and both were in proximity to the island. That means island mass effect should be on both of the stations. But despite of it, equatorial Indian Ocean having a higher abundance and higher species diversity, why it's so? So we reached down to the one of the possible reason that the bathymetry of it. When we comes to down to the bathymetry of the equatorial Indian Ocean, that is having comparatively shallow bathymetry, approximately 1500 meter that I had shown you earlier, and whereas this one is having approximately 4000 meter. So one which are having a comparatively shallower bathymetry, there is a reduced there is a less frictional interaction and advective enhancement, and as well as energetically more efficient, which raises to the, just a minute. Probably because of that also, there's comparatively higher abundance in EIU A1. So till that there was not as such light was it was not in limelight that how bathymetry can be affected. But probably bathymetry also affect their diatoms abundance and diversity. And now I comes to the density trap and mesopelagic seed bank. These are the terms that we had tossed. And so what happens? This is the look into the slide, sorry. Look into slide B, this B and C. Here we can, it's normalized with epipelagic, that epipelagic is considered to be 100%, and this is my abundance, and this is my species count. So here I can see that in mesopelagic, species count is 102%. That's the count is being more than epipelagic. How it can be possible? So while I was going through the data, I was thinking how it can be possible that mesopelagic is having higher abundance with respect to epipelagic. Might be some problem. But then what I had done, I had done a density gradient normalized. So one which is having a comparatively lesser density gradient. That means density, let me explain with one example. There is a point A, B, and C. 100 cars are going through it. At A to B, there's a good highway, but when B to C, there's a full of potholes. So obviously, speed of the cars would be higher during A to B point. But when we comes to B to C points, full of potholes, so there would be traffic over there. So similarly, like over diatoms, here we can see density gradient. That's give us a resistance. So density gradient is very less. So that's the accumulation. When it comes to down, there's a comparatively increase in density gradient. That made it to the accumulation of diatom in mesopelagic, and that's why probably there's a higher abundance. So this is the possible, but what if density gradient is too high? So exactly same opposite we had observed it over here. Here we are getting that density gradient is too high. So we are getting just 3.3% of diatom with respect to epipelagic. So probably as the density gradient had increased, so they got a more time to come down to the epipelagic to mesopelagic. So graduates also got a more time. So there is a decline in abundance from 100% to 3.3%, whereas density gradient is comparatively less, so we got a more diatoms over there. Apart from this, not over here, and we are observed that during mesopelagic, species abundance was declining, but species count was not as that much. Why? So how it can be possible? So we come to the conclusion, for example, species count is declining to the 3.3%. But here we can see that species abundance declined to 3.3%, but count is still from 270 to 36%. How would we? Probably it can be like a mesopelagic seed bank existence, like whenever there's adverse conditions. So there might be a strategy of there to, during adverse condition, whenever there's a prevail of favorable condition, they might be overgrown. So that can be a reason. So that's I'm showing. But how I can show that there's a resistance over there and everything. So this is shown with the help of the Brent-Wessler frequency over here. That's mean higher the Brent-Wessler frequency, more the stratification. So here we can see that this is epipelagic, this is meso, and this is bathypelagic. And station 6, that I'm saying that there's accumulation of diatoms. That's a density trap. So here we can see that in epipelagic, there's a very less Brent-Wessler frequency. This is average of it, Brent-Wessler frequency. Obviously, speed was higher. But when it comes to the mesopelagic, there's higher Brent-Wessler frequency. So that's mean probably there is an accumulation because of the stratification of the diatoms over there. And opposite, we had observed it over here. Here we can see that in EIU A1, there's a higher stratification. So higher stratification, so lower diatoms are able to reaches down to over there. Apart this, and this is the vertical, this is my finding 5, vertical niche partitioning by taxa. So whatever the species that we are observing epipelagic, and what are the, it's not necessary to be going down towards it. For example, here we can see that in epipelagic, there are a number of different diatoms are present. But when we comes to the bathy and abyssopelagic, only limited numbers of diatoms are able to reach. Among them that are Astrolampra, there's Cossinodiscus, only limited. That doesn't mean that all are reaching Sudaram. Only certain ables arise because of their good silica structure, and how they comes from the grazing. And so what's my research significance? So conclusion, broader implications, and here we find that key findings that the vertical abundance is being declining, and there are certain existence of diatom traps due to density, and there's a mesopelagic seed bank. And what are the attributing factor? That's a density gradient that with respect to density gradient, that's mesopelagic and bathypelagic abundance is declining, and there can be bathymetry effect, shallow bathymetry, and there's a deeper bathymetry. Shallow bathymetry probably higher diatoms with respect to deeper, and similarly morphological. Not all shapes are reaching to the down. Only certain shapes like simple cylindrical shapes are able to reach to the down. And at last, I just want to acknowledge Director CSI NIO, RV Sindhu Sadhana crew and participants, and UGC for fellowship, and Project Trace Biome for funding. And thank you, and please, sir, any questions?
Thank you very much. We have time for one very quick question. I think the timing was a bit off in the start. So one quick question, if there is one. No? Okay. Catch him at tea. Thank you very much.
Thank you.
Okay, our next speaker is CB Kurian, talking about seasonality and spatial distribution of secondary chlorophyll maxima in the Arabian Sea based on biogeocarbon BGC Argo data.
Good afternoon. And this work is done in collaboration with INCOIS, and then Dr. Uday Bhaskar and Pavan Kumar, they had helped us with this BGC Argo data. And then part of this work was done by one intern student, Mr. Amin Mohammed. So the title of today's presentation is Seasonality and Spatial Distribution of Secondary Chlorophyll Maxima in the Arabian Sea using the BGC Argo data. Now, this slide I don't have to say much because like everyone knows about the Arabian Sea and also the oxygen minimum zone. And here, this is the 0.2 micromole of the secondary nitrite by Naqvi 1991. So this is the spatial or aerial extent of the Arabian Sea denitrifying zone. And then the difference between Arabian Sea and Bay of Bengal, oxygen minimum zone also is well known. And then morning we heard some talk from Dr. Herman Bange and others about the nitrogen loss in the Bay of Bengal. Now, the main focus of my talk is about the chlorophyll maxima. And we know the primary chlorophyll maxima, it's also called the subsurface chlorophyll maxima or deep chlorophyll maxima, DCM. So that is mostly at around 40 to 100 meters depth. And then this is mostly aligned with the nutricline or the oxycline. But the secondary chlorophyll maxima, which is deeper than primary, that is mostly like 100 to 150 meters, sometimes even deeper. And then this is mostly lies within the or just upper boundary of the oxygen minimum zone. And if we see the vertical profile of this fluorescence, like we can see the primary chlorophyll maxima, this was measured in February 2023 at one station called IIOSC at 13 degree north at 68 degree east. And we see the primary chlorophyll maxima and also the secondary chlorophyll maxima around 120 meters. And then this was reported during Jagovs in 94-95 in the Arabian Sea based on the pigments, marker pigments and flow cytometry data. And then this was identified mainly because of the prochlorococcus, which are adapted to the low light and low oxygen conditions. And then Gorik et al. 2000, they also reported these peaks during 94-95 northeast monsoon, but they didn't find during the next year, and that shows the intra-annual variation. Yeah. Now, in the Arabian Sea, we have BGC Argo floats. These are the autonomous floating instruments having the biogeochemical sensors. So some of them are having the temperature, salinity, fluorescence, backscatter, and some of them also have the nitrate and pH sensors on that. And then earlier studies, Ravichandran et al. 2012, they had used this BGC Argo data mainly to see the temperature, salinity, and then primary chlorophyll maxima, and then the factors responsible for the variation, seasonality. And then they also found at 140 meters from the BGC Argo data, the secondary chlorophyll maxima. And then recently, Garg et al. 2024, they also had seen the BGC Argo data, and then with the in situ observations in the BGC data, the secondary peak at around 140 meters was seen during this May-June in Arabian Sea. Now, under this Cyber India program or India's idea, we had conducted several cruises in the Arabian Sea, cutting across from 9 degree or 8 degree north at 68 degree east to 21 degree north. And then here, most of the cruises during northeast monsoon or spring intermonsoon, during February or March, we see the secondary chlorophyll peak at around 130 or 140 meters. But then that also mostly at the southern boundary or like of the OMZ. At these stations, IA4, 5, 6, those are like 11 degree, 12 degree, 13 degree or 14 degree north at this transect. So now the main objective of this study is to see the seasonal variability and spatial distribution based on the BGC Argo data. So we have contacted Dr. Uday Bhaskar and then Pavan, and then they have derived an automated algorithm to extract the profiles having the secondary peak from the vertical chlorophyll A profiles. This is how they have done, and they have given this corrected vertical chlorophyll A profiles and then smoothen it and then removed the noise from there, and then identify all the local maxima using the gradient based algorithm, and then they removed the spurious peaks from there. And then the advantage over here is like, since it's automated method, it has better reproducibility, noise robustness, and then scalability. It can be used for different oceanographic research applications. And this is the flowchart they have given for this, the extracting the secondary peak from the vertical chlorophyll A profiles, the input raw chlorophyll A profile, and then after smoothing, the maxima is detected, and then quality control, and then finally like the peaks having the primary chlorophyll maxima and secondary chlorophyll maxima were given to us. And then one student, Amin, was there for internship in NIO. So he has physically verified all the profiles what is given by INCOIS, and then these are the distribution, monthly distribution of all the profiles having the secondary chlorophyll maxima from 2015 till 2025 in both active and inactive floats, and January to December. So overall around 438 profiles we got from the Arabian Sea which are having prominent secondary peak. Then here we plotted the month-wise distribution of all these profiles, and then here we can see January, February, March, April, May, June. Yeah, and then July, August, September, October, November, December. So what is seen over here is like the secondary chlorophyll maxima is not only appear during February, March, but it's also in the other months. That's the first thing. But we saw during February and March, we got more profiles, around 140 profiles in the February itself. That is because this particular float, 290-2174, had many profiles, multiple profiles in a single day during the initial days of deployment. And then spatially, these peaks were found not only at the southern boundary, but also it spread in the entire OMZ. Then we have taken one float, 1902458. This is the trajectory of this float from June 2023 to June 2025. And then we found 16 profiles having the secondary peak. And then this is the vertical profile of the first year, that is 2023 June to 2024 June. The temperature corrected data, upper 250 meters. This is June 2023 to 2024 June. Temperature, salinity, chlorophyll A, and then dissolved oxygen. So clearly we can see the seasonality, like during the December, January, northeast monsoon, we have the lower temperature, and then we can see the Arabian Sea high salinity water mass, also the low saline waters from the Bay of Bengal, that is during the February, March, April time. And then chlorophyll, if you see, during the July, August upwelling time, we have the intense chlorophyll and then distributed throughout the upper water column. And then otherwise in the oligotrophic conditions, we can see the primary chlorophyll maxima, but we don't see very prominent secondary chlorophyll peak during this first year. And then this is the dissolved oxygen concentration, we can clearly see the oxygen minimum zone. But if you see the second year, from July 2024 till June 2025, the same seasonality we can see in terms of temperature, the low temperature during northeast monsoon and upwelling conditions, and then the salinity, and then interestingly the chlorophyll A concentration we can see during July, August, and we can see the well mixed water column with the primary, the chlorophyll maxima, means like it's well distributed, and then we have the oligotrophic conditions with the prominent chlorophyll maxima. But interestingly, during this February 2025, here we can see secondary peak also at around 140 meters. And then if we see the dissolved oxygen, during that time, the upper boundary of the oxygen minimum zone is shoaled. Like we can see the 5 micromole oxygen concentration, it has shoaled to the similar, like around 120 meters. So what we find is like, when the upper boundary of the oxygen minimum zone is shoaled, and then under these low oxygen conditions, the optimum light is there. And then the prochlorococcus can proliferate because the secondary nitrite is also present because the denitrifying zone is also shoaled. And then that is in in February 2025. But the previous year, we see the OMZ, the upper boundary of the OMZ was much deeper, 130 to 140 meters. Now, we also had a cruise in February, March 2025, sorry. Yeah, February, March 2025, from 9 degree north to 21 degree north, and then this is the cross section of the temperature for the upper 250 meters, and then the northeastern Arabian Sea, we have more winter convective mixing, and then its temperature is lower, and this is the salinity profile and fluorescence. What we see is the secondary chlorophyll maxima we have seen at station II4 and then also at II7 stations, that is 14 degree north at 68 degree east, and then this at 140 meters we see 0.3 milligram per meter cube fluorescence. And then the dissolved oxygen, here also we can see at this particular station the shoaling of upper boundary of OMZ, and then we can see it's around 110 meters. The upper boundary of OMZ is shoaled, and the secondary nitrite also we can see about 1.3 micromoles of nitrite is present at this particular station. And we also measured the phytoplankton marker pigments using HPLC. So the chlorophyll biomass, the phytoplankton biomass, the chlorophyll is higher in the northeastern Arabian Sea, then mainly contributed by the diatom marker pigments, fucosanthin, and then pyridinine dinoflagellate marker pigments. And this is 19HF and 19BF mostly from the nanoplankton. And then zeaxanthin and then divinyl chlorophyll A more distributed in the surface waters, mainly from the picoplankton or cyanobacteria. And then we see divinyl chlorophyll B, that in the deeper waters we see basically at this particular station II7, where we saw the secondary chlorophyll maxima. So divinyl chlorophyll B to divinyl chlorophyll A ratio is also considered as a marker for this prochlorococcus. And this is the size class contribution of phytoplankton. We see at this particular transect, the microplankton contribution was more towards the northern Arabian Sea, and this is the nanoplankton, and the picoplankton more in the surface waters, and also in this lower water column, means like the bottom waters, means 150 meters in the southern Arabian Sea. And then we also have done the picoplankton abundance using flow cytometry, and we can see this prochlorococcus, they are present at this particular station at this 140 meters where we see the secondary chlorophyll maxima. Yeah, just to conclude now, the secondary chlorophyll maxima usually form within when the upper OMZ boundary is shallow, when optimum light and then optimum low oxygenated conditions, and also the nitrate, because prochlorococcus can utilize both nitrite and nitrate. And recently Vishal et al. 2025, they had reported this pro-noctiluca, that's a heterotrophic dinoflagellate, that's reported in the secondary chlorophyll maxima depth in the Arabian Sea, and then that shows the importance of these prochlorococcus and their grazers. And also Garcia Robeldo et al. 2017, he had reported about the cryptic oxygen cycling in this anoxic marine zone when there is secondary chlorophyll maxima is present. That shows that the tight coupling between the oxygen production and the consumption by the aerobic communities. So the global warming is supposed to lead the shoaling of the oxygen minimum zone, and then this can promote actually the prochlorococcus in the waters, in the suboxic waters. So that can affect the biogeochemical cycling of carbon, nitrogen, and sulfur. Thank you.
Thank you very much. We have time for one question. There's a question over here. Oh, there, yeah.
So I have just a short question. You mentioned that also on the agri-flows are Suna sensors for nitrate. Do you have the chance also look about this and compare if you can use algorithm for nitrite, if they occur with the chlorophyll max together or not?
Yeah, but this nitrate sensors, it's very few in the Arabian Sea, so we have to cross-check that also. Yeah, thank you for that, yeah.
Anyone else got a question? Okay, thank you very much.
Thank you.
For a very data-rich presentation. Okay, the final speaker of this session is Jagadish Patil, and he's going to talk about integrating phytoplankton photophysiological metrics into Indian Ocean monitoring.
Good afternoon. Myself Jagadish Patil from National Institute of Oceanography, Donapola, Goa. I thank the organizer for giving me opportunity for presenting. Actually, now I'll be presenting my research integrating phytoplankton physiological metrics into Indian Ocean monitoring, insights from FRI-based studies in the Arabian Sea. I think in this session, I think many people have told about the uniqueness of the Arabian Sea, but to make the story flow, I'll be just give a brief about the uniqueness picture of the Arabian Sea. Because as we know, Arabian Sea is a distinctive Indian Ocean ecosystem with several defining characteristics like intense monsoonal variability switching between southeast and northeast winds. There is the prominent coastal ocean productivity gradients and the critical productivity hotspot due to upwelling zone and frontal systems. And we also harbor the unique monsoonal estuaries and the rock pools. And also the most prominent, the prevalence of the oxygen minimum zone. Because of this, the phytoplankton in Arabian Sea have evolved remarkable adaptations. And for instance, the phytoplankton has to undergo seasonal stress recover cycling because due to the monsoons, and they have the prominent protection mechanisms to against the severe light stress. And there is a rapid bloom dust dynamics over the stable populations. And many species use mixotrophic strategies, and the notorious one is the green Noctiluca bloom, which is causing a recurrent bloom in the northeastern Arabian Sea. And the species turnover rate are the seasons. Okay, what is the knowledge graph? Why physiology matters? Because historically in Indian Ocean, most of the Indian Ocean monitoring is focused on the quantification. For example, the biomass quantification using the chlorophyll concentration, productivity measurements, nutrient cycling, and the taxonomic composition. But these matrices provide what is there, but does not tell how the ecosystem is functioned. So there actually the health comes into the picture. The critical gap is the physiological health, the stress responses. The stress responses to the nutrient limitation here, and the resilient capacity. Resilient capacity to know, because we know some species, they thrive in one season, but they are struggling in the other seasons. And there are early warning signals and the climate sensitivity. For example, we have distinct variability, monsoon variability is there. The phytoplankton has to cope up this sensitive change in the climatic systems. The benefit of The essentials of why phytoplankton physiology is essential, because one is the ecosystem health, because it reveals the stress before visible biomass change. Because whenever there is a bloom, is the discoloration, that time only we realize, and that time only we have to go and act to what to do about this bloom. Before that, to know, we should know what is the stress level before the occurrence of the bloom. And the monsoon sensitivity, because it tracks phytoplankton responses to variable discharges. We know during the monsoon there is in estuary there is a large freshwater discharge and salinity changes and so many, there is drastic change. So we can track, because those seasonal changes are predictable, and if we track this, their physiological pattern, we can able to predict how the system is. A resilience assessment, it distinguishes the thriving versus the struggling community. So the phytoplankton is like, there is a seasonality in the biodiversity assessment. So we can see like during this season, which population is actively growing and which is not actively growing. And the climate indicator, physiological stress precedes ecosystem collapse. And all having this information, we can enable evidence-based marine resource decisions. So let me talk about the FRF. I think many will know as well as many will not be aware of that. The FRF and the acronym is the FRF, the full form, fast repetition rate fluorometric. The basic is it provides a non-intrusive, non-destructive method for probing phytoplankton photosynthesis and productivity in real time. If you see this is the figure, it gives a typical fluorescence curves for a viable cell, and the initial fluorescence is called an F0, that is the minimum fluorescence, which is also considered to be a proxy of the chlorophyll. And the FM, when all the photosystem is saturated, that is called the maximum fluorescence, and the difference will give the variable fluorescence, which is an indicator of viable proxy. For instance, if you see here, that is F0 and FM, there is no much difference. So this is one, it's like a dead cell. Okay. And the ratio of FB by FM is called a photosynthetic efficiency, and is the primary physiological indicator, which I'll be talking more about that in this presentation. But when we measure this fluorescence parameter in both and the like, by integrating it to mathematical equation, one can estimate the electron transported and the primary productivity. So, which is I'm not going in detail. And all these factors, the fluorescence factor as well the productivity, are affected by the taxonomic composition and environment in the given ecosystem. But the advantage of this instrument, it can be operated in multiple platforms in a different mode. For example, we can make use of the continuous measurement during underway measurement during the ship, and in situ operation where we can use the both light and dark to where we can get the productivity measurements, and the discrete mode, which gives a more option for the experimentalist to use it. So actually, in this presentation, I will be spanning across 3 different ecosystems in the Arabian Sea to cover the entire spectrum of how the ecosystem is in the Arabian Sea. One is the Juari estuary, because this is influenced, it's a monsoonal estuary where we can see the signature of the monsoon very clearly, and I will be showing the snapshot from the daily observation conducted for almost 18 months, covering the one monsoon and the remaining non-monsoon period. And in the open ocean system, the northeastern Arabian Sea, mostly I'll be focusing on the frontal and the non-frontal system in the northeastern Arabian Sea, and the frontal and non-frontal, the fronts occurring at the open sea and within the shelf and the across shelf, and the integrated hotspots and hotspot, it's a rock pool, because that is the environment where the phytoplankton experience the most extreme light condition as compared to the oceanic water bottom. So this gives a wide spectrum of the phytoplankton experiencing the stress environment in the given environment. Okay, there is a spatial heterogeneity in the Arabian Sea. So actually we operated the, we measured the physiology of the phytoplankton in the northeast Arabian Sea during a cruise, and we captured almost the 7 fronts. And we have the fronts occurring in the open ocean fronts and within the shelf as well as the shelf break. What we found, irrespective of the range, we found that higher FUB FM values in the frontal systems as compared to the non-frontal system. But interesting is the FUB FM, theoretically the cells are healthy if the FUB FM values are more than is around 0.65. But interestingly, in frontal xerum, we got the maximum fluorescence up to 0.5. It is only the 75% of the maximum capacity. Whereas in the non-frontal system, it was 25 to 50% capacity. So then, since we have not got the maximum capacity, we carried out some nutrient enrichment experiment in 2 locations, some stations representing the oligotropic region and OMZ region. So the field measurement, what it said that in OMZ area, at all the depths, you see the efficiency is much higher than the oligotropic depth at different depths. In the oligotropic, you see only at the chlorophyll maximum only you get the little higher depth. Actually, chlorophyll maxima in the oligotropic was a little deeper as compared to OMZ region. Though it is coming here, OMZ region, actually it is, the CMAC depth is around 25 to 26 meters during our observation. But still, you will see that the FeV never reach more than 0.5. So we conducted one enrichment experiment within the nitrate and phosphate experiment where up to 10 micromole were enriched. We found in both the oligotropic and OMZ region, the efficiency are improved, performs. But it was more in the oligotropic environment, up to 200% the variable fluorescence are increased and 40% here and up to 20% the physiological appearance. So this shows despite the productivity is more in adsorbed zones, they are nutrient limited. Then I will come to the estuarine area. So this we can see a daily observation of the FRF, the measurement we have taken from 2008 October onwards and to the 2000 May. We see this gray area is referred to the monsoon season. During the monsoon season, you see the several chlorophyll peaks which we are done. That is because whenever there is a lull in the discharge or when there is a rainfall break is there, you see there is sudden increase in the chlorophyll peak. But despite that chlorophyll increase here, but we have found that FeV performance efficiency was reduced. But during the non-monsoon period, if you see, this is a flare, during the non-monsoon period efficiency is increased. And during here, and so for this entire range, we categorize into 3 categories, up to 0.3 as the low, and 3 to 5 is the moderate, and more than 5 is the high. So when we, the right one is the schematic. During the monsoon period, the FeV is reduced, but they are under stress conditions, despite there are few blooms. Then during the transition period, you see the efficiency are increased like 0.3 to 5, and during non-monsoon period, the highest is recovery. That's the recovery phase. So this indicates there is a seasonal stress recovery cycling which is happening in the Arabian Sea. Because of this stress and recovery cycling, you will never sustain a maximum efficiency because the phytoplankton has to need to undergo stress and the repair. So that's why we never get the maximum efficiency. So, during one cruise, we did one microcosm experiment on board to see the effect of the diurnal effect of the solar radiation on the phytoplankton through microaggression. So in the open ocean, we did 2 experiments, one in the South Tropical Indian Ocean, one is in the this OMZ area, and then we are compared with the rock pool which experienced the highest the solar radiation. What we have found is that during all the 3 ecosystems, we found the active PS2 at the morning. The FeV are highest early in the morning. As it comes to the midday, you see a depression in the FeV, then again it will increase in the evening. So this pattern we call as dynamic photoinhibition, and this was evident in all the 3 zones. Okay. And also the interesting was the non-photochemical quenching was present in the antenna bed in the Arabian Sea, but it was not present in the Arabian Sea. So this says the habitat type, prevailing dominant tax and hydrobiotic condition determine photoprotection mechanisms in the Indian Ocean. The unique Arabian Sea signature operating. So when we the maximum capacity, the natural ecosystem maximum is 0.65, but in Arabian Sea we got maximum on an average 0.3 to 0.3. But this suggests that in Arabian Sea, the photosynthetic efficiency is up to 50%. This is not a failure. Okay, this is a hallmark or the signature for the Arabian Sea. In the future, if this value is coming down, then we can consider that the phytoplankton are going under stress. But these are from the limited data sets. But we need to have the more data sets so that we can confirm what is the Arabian Sea, the baseline. And this baseline is consistent with the global oceans, as you can see in the bottom figure. So, and as we know, there exists the natural travels and anthropogenic pressure, natural travels and pressures and the anthropogenic the phytoplankton are experiencing. So it becomes necessary to integrate the physiological monitoring in the governance programs. And another event is the ecological disruptor, that is an Noctiluca blooming. So here what we did, we did the underwater measurements continuously from Goa Tour until the northeastern Arabian Sea and the back. We found we could able to detect the FEV was highest on the wherever the Noctiluca bloom is there. So this gives an added benefit where we can detect the blooms during the on-way also. At the morning of the Secretary Dr. Ravichandran is saying we need to integrate the operational integrator to come up with the new parameter for biogeochemical cycling. I would recommend the physiological one, FRR, because it can also give the productivity measurements should be integrated in the ocean monitoring programs, which is still lacking as compared to world ocean, other oceans. In the Indian Ocean, it is still lacking the measurements. So I proposed in the 3 phases. We need to have a regional baseline for estuaries, coast and open ocean and front in the selected location. We should compensate with time series to identify the stress level alerts. We should make use of ship opportunity, autonomous platforms and real-time dashboards and adapt to measurement. The final slide conclusion. The Arabian Sea has a unique biological feature because it gives the distinctive signature. Phytoplankton 50% efficiency reflect unique monsoon recovery cycle, hallmark of Arabian Sea ecosystem. Spatial complexity, frontal zone 75% capacity and open ocean up to 50, striking biogeochemical gradient within the short range. And early warning system, physiological metric detect ecosystem strike before visible changes occur. Climate sensitivity, monsoon variability, responses inside climate impacts on air. Emerging threats, Noctiluca bloom and management. Integrate physiological monitoring into governance framework to support the SDG 14 framework. Thank you.
Thank you very much. Unfortunately, we won't have time for questions. We'll be running late for the next session. Just a reminder that after tea, which Chandra will talk about in a moment, there will be a flash talks for the posters. And please attend the posters. There's a lot of effort being put into them. And they'll be running after the flash talks. Over to you.
With this, we concluded today this oral talk presentations for the theme 6. And again, the oral presentations will start tomorrow at the same hall for the theme 6, morning 11:30 a.m. As Lynette said that we will break for the 30 minutes for the tea, which is at the ground floor where you had the lunch. And after that 30 minutes, we will have a flash tag presentations for like half an hour. We have like 6 flash tag presentations. Then we'll go for the poster and all those things. With this, we'll conclude. After this, we'll conclude the today's session for the theme 6. Yeah, thank you. We'll see you after 30 minutes. This session will be held by the Dr. Rajiv Saraswat. Dr. Rajiv Saraswat is a senior principal scientist from the CSR NIO Goa, and he did from PhD from the Goa University, and his career has received the several honors, including the CSR Young Scientist Award and the Young Scientist Award from the Indian National Science Academy. And in this session, we are having the 5 oral posters. Flash tag presentations. These flash tag presentations like limited to 2 to 3 minutes. Max 2 to 3 minutes. Then we will go for the poster. By that time, all the poster flash tag presentations, please get ready with your posters outside. Once this flash tag is completed, then we will visiting. Convener will visit and they will listen. He will listen to you your poster presentation and all those things. Okay. Now I over to Dr. Raju sir.
Hello. Good afternoon. Welcome back for this poster session, come flash talk. As Chandra already told, we have 5 people who will be presenting or rather introducing the poster. There will not be any discussion on these talks, it's just for 2 minutes. So we'll start with the first talk, that's by Ignatius Joseph. And he's going to talk about Phaeocystis bloom, an emerging threat to coastal waters of India. Please highlight your poster number and tell people to visit your poster.
Good evening, good afternoon. I am myself Ignatius Joseph. I am from NIO. I am a PhD scholar there. IIOSC Visakhapatnam. So my abstract number is 06 ABS 0603335. So during December 2022, we went a fieldwork in the Digha coastal waters, West Bengal. Once we enter the beach, we found a jelly wave over there. We collected a sample and we analyzed it. It was Phaeocystis bloom. Phaeocystis is a cosmopolitan primacy of it. It is including 7 species are there. In those 7, 3 are bloom producing. Among those 3, Phaeocystis puchetti and Antarctica is blooming in the polar and temperate region. But Phaeocystis globosa bloom reports are available in tropical waters also. This report was started 18th century onwards in European waters. After that, series of reports are available in North Sea, China Sea, Vietnam Sea, etc. Then if you are talking about the Indian waters, more than 150 algal blooms, phytoplankton blooms are reported. In that, 6 are Phaeocystis globosa bloom. During 2000, Madhyaprabha sir was first observed the bloom in Arabian Sea. After that, few reports are available in the Indian Ocean, but none of the reports are continuing. But in our case, it is continuing since 2022, December 2022 onwards. If we are talking about the triggering factors, it's including temperature, salinity, and nutrients, and less grazing pressure because of the colony forming behavior of those organisms. And if we are talking about the impacts, it creates a lot of huge economic and ecological losses all over the world. And it can produce a foam, high foam, due to the wave action and all. So due to this high foam, this was reported a human mortality also in the Dutch coastal waters. Let me conclude. During 2000, Madhyaprabha sir warned it can be impacted the Indian coastal waters. After 20 years, it was happened in the Kerala coast. So it is continuing in our study. So it can be it is an emerging threat to the Indian coastal waters. Thank you.
Yeah, I think the next presentation is a recorded one. So let's play that out.
She is V. Niranjana. She has sent a one recorded video. Play the video.
The title is Comparative Assessment of Field and Satellite Derived Chlorophyll A Concentrations along the East Coast of Tamil Nadu.
Good evening everyone. This is V. Niranjana, Research Scholar, Department of Civil Engineering, Dr. MGR Educational and Research Institute. I am going to present my study, Comparative Assessment of Field and Satellite Derived Chlorophyll A Concentration along the East Coast of Tamil Nadu. The main objective of the study is to compare chlorophyll A measurements obtained from in situ data with those derived from satellite data. This comparison involves data from MODIS, VIRIS, Sentinel-3 and OCM3 census. The study aims to assess the overall effectiveness and accuracy of various satellite measurements when compared to in situ data for the coastal waters of Chennai. The study area covered 3 significant transects along Tamil Nadu's east coast, covering Ennur, Kuvam and Kovalam for 75 km and 20 km from the shoreline. Methodology involves the in situ data collection during the 2023 and 2024 year along 75 km of Tamil Nadu coast, including Kuvam, Kovalam and Ennur, to a maximum depth of 52 meter and 20 km from the shoreline. Water samples were collected using Niskin sampler and stored in pre-cleaned polyethylene bottles. The protocols of AFA and NCCR were adhered while collecting and transporting the samples to the laboratories. The collected samples were kept in ice box and covered with dry ice and then stored in the cold chamber at 4 degrees Celsius. This is the procedure for estimation of chlorophyll A. The water samples were filtered through a membrane filter, that is Wattman glass fiber filter paper GF-F of 47 mm, 0.7 micrometer pore size for estimation of chlorophyll A. The pigment obtained from the algal sample solution was kept in 90% acetone for 24 hours. The chlorophyll A concentration was estimated using UV visible spectrophotometer by measuring the absorbance of the extract at 750, 664, 647 and 630 nanometer by using the below equation, and from that the chlorophyll value will be obtained. Concurrently, MODIS, VIRUS and Sentinel-3 data were collected from NASA Ocean Color Web Copernicus Data Space Ecosystem, and processed OCM3 data were obtained from ISRO for the dates of sampling and were compared with field obtained chlorophyll. Satellite data were processed and chlorophyll values were retrieved using CDAS and SNAP softwares. The results of the study are depicted here. This is the scatter plot of in situ versus MODIS derived chlorophyll A. This holds the R-square value of 0.656, and this picture depicts the scatter plot of in situ versus virus derived chlorophyll A. It holds the R-square value of 0.233, and this scatter plot of in situ versus Sentinel-3 derived chlorophyll A has the R-square value of 0.124, and this scatter plot of in situ versus OCM3 derived chlorophyll A has the R-square value of 0.660. And this figure is the comparison of chlorophyll A obtained from in situ measurements and satellite data. This is the statistical metrics for comparison of chlorophyll A concentration obtained from in situ measurements and satellite data. Here, the MRPD values, R-square values and MAPD values are exhibited. For OCM3 sensors with resolution of 360 meter, MRPD shows the value of 52.58 and MAPD shows the value of 59.43 with the R-square of 0.66. And comparing all the other satellite, OCM3 has the highest R-square value and lowest MRPD and MAPD values. While going to the other satellite, MODIS with resolution of 1 km shows the MRPD value of 72.70 and MAPD value of 60 and R-square value of 0.65. And following that, VIRUS with 4 km resolution shows the R-square value of 0.23 and MRPD recorded as 74.15 and MAPD showed as 55.33. And following that, Sentinel-3 holds with resolution of 1.2 km holds the MRPD value of 87.03 and MAPD value of 63.62 and R-square of 0.12. From this table, we can see that OCM3 holds the R-square value of 0.6, shows the higher correlation with the in situ satellite data. Following that, MODIS, and after MODIS, VIRUS shows some kind of correlation, and Sentinel-3 holds the lowest correlation with the satellite data. Conclusion: the study assessed various satellite sensors for chlorophyll A estimation, showing varied performance level. Oceansat 3 had the finest spatial resolution of 360 meter and lowest MRPD, indicating high consistency with the ground truth measurements. Even VIRUS having the lowest MAPD values, but it holds the lowest R-square value of 0.23. It is not considered as a highest correlation. MODIS and OCM3 showed strong correlations with reference data. In contrast, Sentinel-3 and VIRUS exhibited low R-square values. In conclusion, OCM3 is the most reliable sensor for coastal monitoring, with MODIS as a strong alternative, though challenges in atmospheric correction and complex water body persist. Thank you everyone for the opportunity. Thank you very much.
Okay, yep, we'll move on to the next talk now by Gavin Lee. The title is Particulate Organic Carbon Distribution in the Western Indian Ocean on Biogeochemical Argo Floats. 2 minutes, please.
Okay. Good afternoon, everyone. My name is Gawon Lee from Korea Institute of Ocean Science and Technology. Today I introduce my poster on particulate organic carbon distribution in the Western Indian Ocean based on biogeochemical archetype flows. As you know, the ocean plays an important role in absorbing atmospheric carbon dioxide. Particulate organic carbon, POC, helps us understand this capacity. However, the ship-based observations are limited, so we used an autonomous biogeochemical archetype float to estimate POC from the measurements in Western Indian Ocean. This map shows the ship-based sampling stations and archetype float trajectories from 2023 to 2025. To estimate POC from the float measurement, we use backscattering. We match the backscattering data set with in situ POC and beam transmission data. The backscattering data was quality controlled, and beam transmission data was used to correct the temporal drift of backscattering sensor. Using the drift adjusted data, we built a regression to estimate POC from the float observations. Our results shows the strong air-specific correlations between POC and beam transmission data. And also the drift adjustment significantly improved the relationship between beam transmission-based POC concentration and the backscattering data. Using the binary regression to the full float the backscattering measurement revealed that the POC patterns reflect the interannual variability in shale surchargos in thermocline ridge, where the float repeatedly passed through during the observation period. For more detailed information, please visit my poster number 228. Thank you.
Thank you. The next presentation, as Chandra asked in the beginning, if she is around, Madhurima Paul. No. Okay, we'll move on to the next. That's why Gangme Gaichung Lu. The title of the talk is Surface Sediment Studies from Kalpeni et al., Lakshadweep.
Good afternoon, everyone. My name is Gaichung Lu. I'm a PhD scholar from IIT Roorkee. Today, I'll be presenting on my preliminary research work, which is Surface Sediment Studies from Kalpeni et al., Lakshadweep. For this study, we have collected 25 sediment samples from Kalpeni et al. The objective of our study is to investigate how foraminiferal assemblages are associated with sediment texture, water depth, as well as hydrodynamics of the region. For this purpose, various methodologies were obtained. So the figure 2 shows the thin section images of various components, which shows the foraminifera, then Halimeda coral fragments, gastropods, even the coralline algae. This shows that they are an indicative of reef-derived sediments. In the figure 3, it shows some common benthic foraminifera texture from the Kalpeni et al., the presence of amphiseasonal ovifera, the Amphisaurus, as well as the Texularia species are indicative of high energy conditions. So the granulometric analysis as well as the sediment component analysis shows that grain size fraction of 0.5 to 2 mm are dominant in the region, and then the sediment component analysis shows that coral fragments are the major sediment contributors in the study area. The spatial distribution map highlights the various dominant benthic foraminifera in our study area, which varies according to the water depth as well as the substrate type. This trend is supported by PCA analysis, which illustrates the influence of depth gradient and sediment texture on habitat preferences and species distribution. For further discussion, you may kindly visit the poster number ABS 06100105. Thank you.
Thank you, Gangshi. The last one also, I don't know, Dr. Jagdish, you want to present that? Okay. Yeah, the student is not around, Pranay Paul. Title is Biogeography and Dispersal Dynamics of Dinoflagellate cysts in the Indian Ocean Deep Sea Sediments. Implications for deep sea ecology and resource exploration. Dr. Patil will present this.
Actually, due to personal reason, my student Pranay Paul could not attend this year. On his behalf, I will be presenting. And the biogeography and dispersal dynamic of dinoflagellate cysts in the Indian Ocean deep sea sediments, implications for deep sea ecology and resource exploration. Okay, we know the dinoflagellates forms the dominant phytoplankton groups, and as part of the life cycle, the dinoflagellates they undergo cyst formations, and also if they encounter unfavorable conditions, these dinoflagellates are known to form cysts. Once they form the cysts, they sediment at the bottom. In coastal water bodies, once they settle at the bottom, they form a seed bank, and seed bank for the subsequent bloom. Whereas in the open ocean, the pelagic, and therefore because of this harmful algal bloom research, a lot of work has been done on the coastal areas on dinoflagellate cysts. But there are hardly any information from the pelagic region for this region. And if you see the world map, if you see the most work has been done in Atlantic Ocean, but no work in Indian Ocean. So we did some analysis from this Indian Ocean region, and this comes in different morphological and shapes, and these morphometry can be used as an indicator for any environmental change, and also therefore they have been used as a proxy for the paleo studies also. So what we found is like the dinoflagellate cyst population, they decreased from the northern Indian Ocean to southern Indian Ocean. Interestingly, altogether we found a 48 dinoflagellate cysts, and all the 48 were present in the northern Indian Ocean, but only of that 21 species were found in the southern ocean. So in the entire Indian Ocean, the only 21 dinoflagellate cysts are not to be present cosmopolitan in the Indian Ocean. Why this is very important? Because they can act as a valuable indicator for the reason because in the southern side, it is a major shipping route, and it has been shipping by invasion due to shipping also is possible through ballast water discharge, and also this is a zone for the mineral exploration. So this cyst population can be a good indicator. So for detail, I would request to visit the poster 1 through 139. Thank you.
Thank you. With this, we end this brief flash talk and poster session. Thank you so much for all the presenters, and I request all of you to please visit the poster. If you have any questions, queries, suggestions for these people, please discuss them during the poster session. I think the posters are placed at the same floor, just outside the plenary hall. Thank you so much.
Yeah. With this, we ended today all the talks, oral talks and the flash talks. So, and I request you all the posters like who pasted outside, just be stand there that our convener will come for and listen for 1-2 minutes, because there is some people who have opted for the best poster presentation. So please kindly cooperate with us. Thank you. We will meet tomorrow at same time, morning 11:30 a.m. In the same hall, we are having one popular talk by the Dr. Purnima Jha, which will be at the 17 hours here only. Thank you.
here it can be deposited. There is online plankton trip model. Online plankton trip model is
Coral fragments are the major sediment.
plankton trip model. So there we have to review over the data. Well, if you know the thinking parties of
What is the characteristics of this So this species is observed only here.
Yeah, for this station it is observed here. For this station it is observed here.
So this station is totally different from this one.
And it is the regional one. So the main issue will be the regional one. So if the regional one start expanding, then there is a population. But for all these you 21 species are common. 21 species are cosmopolitan. They are found all area. But here you get additional 29.
B might be because of the last one. Because usually Haldia fruit is there.
Habitat and different species distribution. So like sir, our students were to conduct a study of multiple samples production and also paleontological studies because from the luxury period, the paleontological studies are very different, and I think that we are prepared for the
That's why you are lighting 2 liter, 4 liter also getting that. No. Maybe actually backside is mentioned 3 feet. Frontside is like the backside usually frontside is whenever 2 liters.
About the heat content. Human fatality also reported due to this high flow. The surface when you inside that one, they got inside this one, they look at asphyxiation, the fatality also reported 5 another line. So because these, there is no because of the regional issue impact. There are lot of islands are there. It should be.
How about makeup? Okay, okay. Okay, 3, 2, 1.
This program is a popular talk by Dr. Purnima Jalihal, which will be delivered virtually. Ma'am, you are connected, right? Yeah. So I'll first introduce you to the audience, after which we will play your presentation. Okay. Dr. Purnima Jalihal is a distinguished ocean energy expert and former head of the Energy and Freshwater Group at the National Institute of Ocean Technology, or NAOT, Ministry of Earth Sciences, India. With extensive experience in marine renewable energy, she has led pioneering national projects in wave energy, ocean thermal energy conversion, and seawater-based freshwater production technologies. Dr. Jalihal has coordinated several large-scale ocean engineering initiatives aimed at enhancing sustainable energy solutions for coastal and island communities. She currently serves on international panels and contributes to global discussions on blue energy, including her role as a speaker at ICOE 2024 and advisor for innovation platforms such as Expire Foundation. Her work continues to bridge ocean science, engineering, and policy to advance clean energy pathways for India and beyond. Can you please play the video? Video, please.
I'm Purnima Jalihal, and I have been heading the Energy and Freshwater Group in the National Institute of Ocean Technology for over 2 decades, and I continue to work on energy-water nexus. Thank you to INCOIS for giving me this opportunity to speak to you today. So I'll be talking about ocean technologies, how you can use sustainable and self-reliant technologies today, and also how they are required and why. So let's take this slide. It looks very simplistic, but it defines how air, the land mass, and the ocean are all intricately connected. So every issue that happens in the ocean affects the land and the atmosphere. Everything that happens in the atmosphere in turn affects the land and the ocean. So it is really imperative for the sustainability of the earth that we protect atmosphere, land, as well as the oceans around us. When we start talking about the oceans, we first need to understand that it's a very, very complex system. And there is so much known, yet much, much more unknown today. And especially in deep waters, a lot is yet to be understood, and a lot of efforts also need to be taken to understand what actually goes down in the deep depths. Largely, the ocean sciences can be grouped as biology, chemistry, physics, and geology, and this includes the marine life, chemistry, physics, and the seabed and plate tectonics, which come under the group of geology. For instance, when you talk about biology, who would have thought that, even 1,000 meters and beyond, at those depths, there is life? There is an imagination or an assumption that wherever sunlight penetrates, we have life. But the NIOT ROV has taken actual photographs in deep waters, and these are what do exist over there, and they're all living. Similarly, physics. We need to apply all the principles of physics to be able to understand the oceans, because only sound can help us hear and understand what goes on. Sonar is an acronym for sound navigation and ranging, and underwater acoustics plays a very important role. Seawater is not just NaCl. It's made up of several chemical constituents, and these also have to be understood whenever we undertake any technology development. The large elements of the ocean which are actually visible to us and which we have to navigate when we try to develop anything offshore are waves, winds, currents, tides, and temperature, by which I mean that the surface temperatures are different from those that we encounter below. So these are an important set of phenomena that we need to understand, and world over lots of efforts have been made to numerically and theoretically understand them as well as measure them. So there's a lot of emphasis on observations and data collection. Now, why do we need all these things, and why have I been talking about seemingly simplistic things like sciences and the oceanography? But once we come back to the point of ocean resources, to harness ocean resources in a sustainable manner, knowledge of the ocean is really important, and therefore, what I said earlier has a place in the technology development. Now, what are the resources, first of all? They are, of course, oil and gas, which has been, a big industry, especially in the developed countries. Marine biodiversity, energy, water, minerals, and gas hydrates. These are all the resources that you can get from the oceans. Now let me talk about something slightly different, and which is an important thing as to why I'm going to be speaking on what I am speaking today, and that is climate change and global warming. Climate change has become a buzzword today, and there were a lot of naysayers, but we must understand that climate change is a reality and is here to stay. So global warming, what does that mean? It is a slow increase in the average temperature of the Earth's lower atmosphere to an increased amount of energy being trapped in the atmosphere. And climate change refers to significant long-term changes in the entire global climate. We also talk about greenhouse gases. Now, what are those? The gases released by burning fossil fuels and tiny particles produced by incomplete burning trap the sun's energy in the atmosphere, and these get termed as greenhouse gases. These are the primary reason for causing all the current scenarios, which include sea level rising, then the melting of the polar ice caps because the temperatures are increasing, and the world's oceans and all surrounding areas are also increasing in temperature. So therefore, overall, climate change greenhouse gases, all these have to be mitigated. And it is well known today that, greenhouse gases can be mitigated, or at least we can try to reduce them by the use of renewables. But to sum up, what are the major environmental issues of today? First of all, it's the global warming due to the burning of fossil fuels. Then the GHG emissions. We have, because of all these, the biodiversity loss. The marine plastic pollution has become a huge menace. Deforestation, air pollution, ocean acidification, and etc. etc. So essentially, we have really got to a state where there is so much of environmental impact, and we're really torturing the earth, and this is really now urgent to find ways and means to mitigate these. And we must understand that largely everything that we see today is anthropogenic. And so how do we mitigate? We need to reduce all the effluent and pollutions. We need to reduce the GHGs, and we need to get into sustainable practices and develop safe technologies for water and for the ocean. We need to safeguard environment and biodiversity, and of course, again, it doesn't need a less emphasis that we have to decouple the economic growth from the emissions. We have to protect the biodiversity. So there are a huge number of things that we need to do today to safeguard the environment and biodiversity. And in this scenario, we start looking at the oceans. And if we take renewable forms of energy as the first step towards reducing greenhouse gases, we need to look all around us and not only at the landmass. So look at the Indian scenario. It used to be 7,000 to 8,000 kilometers as our coastline, but now the latest notification has been issued where more detailed and precise measurements have been undertaken, and we now have a coastline somewhere slightly more than 11,000 kilometers. We have a very, very huge EEZ because of the two sets of islands in the Arabian Sea and the Bay of Bengal. And all this makes it imperative that we look at the oceans around us very, very seriously, because about 30% of our very large population lives near the coast. So in this scenario now, we start talking about ocean energies in the realm of renewables. So again, to just backtrack, we saw how anthropogenic interventions are leading to greenhouse gas emissions, which leading to climate change and the global climate scenario change. So can we use the ocean around us to fill in the gap for the additional requirement of renewable energies today? So ocean energies are wave, tide, the thermal gradient, salinity gradient, biofuels, offshore wind and floating solar. Actually, the last two are not really considered ocean energies because there the motive force is not seawater. However, they are all types of energy forms which can be harnessed, and therefore basically we have to look at all this entire list here seriously in the context of reduction of GHGs. So offshore wind, there's very little work yet commenced in India, but MNRE is doing a lot of work and is going to pump in a lot of finances and trying to get offshore platforms towards supporting wind turbines offshore, so that the footprint on land can be saved and more wind energy can be harnessed. Floating solar this is a conceptual set of pictures. However, this can be done. In fact, again, solar is known to be a huge footprint guzzler, and therefore it's time to move to the oceans so that we get enough solar power, but by reducing the footprint on land. And now we come to the actual ocean energy forms. So at NIOT, we have been working on wave energy, marine currents, and also the ocean thermal energy gradient. And these are forms where we have actually done all designs indigenously and developed them, demonstrated them offshore, and we have actually commercialized a few devices as well. So this is one of the devices which came after decades of research, starting from a fixed huge OWC, the oscillating water column in Kerala. We then finally, after a lot of understanding, we developed a navigational buoy, which now it's not only fully indigenous and lower cost than the imported navigational buoys, but it has a value addition that it actually can measure the oceanographic parameters in situ at the entrance of the ports, and this has been commercialized, and then many ports are now trying to install these in their premises. We also have been working on hydrokinetic turbines where the marine tidal streams, so the current velocities, are used to drive hydrokinetic turbines to make power. These have got great value in island situations and remote localities where off-grid powers are required. Now we come to the ocean temperature profile. So the surface of the sea is much warmer than as we go deeper down, and therefore there's always a constant temperature gradient available between the surface of the sea and at deeper depths. Now this difference in temperature can be used to harness power, which is called the ocean thermal energy conversion. It can also be used to make water. I'll come back to that a little later. However, the other resource which I had mentioned earlier is bioenergy from the oceans, and so you can get energy from algae, and there's a lot of work going on even in NIOT on mass culturing of microalgae to be able to harness energy. And in fact, preparation and characterization of a betaine biodiesel has also been done, and this was prepared from a lipid extracted by the Chlorella vulgaris alga. And again, as far as resources goes, so far we talked about energy. We can also get food. That is the biggest resource that we can think of. It's actually the main livelihood in most coastal parts of the world. But then to make the livelihood easier, to make catch larger, and to make it even more market attractive and give employment generation, there are other technologies which need to be developed, like we have developed the open sea cages where a lot of the marine animals can be reared and then commercialized at high scales. So thus far we talked about the food and energy that can be harnessed from the ocean. Now let's talk a little bit about the water crisis, which is again a result of the climate change impacts. In fact, climate change has led to very less water in places and very high flooding, and huge amounts of watersheds are happening in different parts of the world at different times. Now, if you see the India map, you can see the large part of the country is in the water scarcity zone. Very few parts of the country have got no water issues at all. There is scarcity, but there's definitely stress in many places. So we need to find ways to augment water, and this can be done by either waste and industry water treatment or by doing desalination, and these have to be done in a sustainable manner, as I will talk about briefly. However, this is a major challenge in India currently, and therefore the water stress has to be addressed by using as many novel technologies as possible. To this end, NIOT demonstrated for the first ever thermal desalination project in the island of Kavaratti in the Lakshadweep group way back in 2005. This plant was a result of that effort, and this plant is not only producing fresh water for the last 20 years, but it has changed the lives of the people, and literally even the tea started tasting better. It touched the people to at the lowest levels of their life and made them actually healthy, self-sufficient, because they run the plant, And they have really, this is a total actual case where a total indigenous effort has changed and transformed the lives of a group of people. After that, now we have implemented it in all the inhabited islands of Lakshadweep. 10 islands also have the same technology now, because other forms like reverse osmosis did not work in the Lakshadweep group at all. And we are very proud, of course, this is a proud moment for India when we can say that we have developed a technology without aping the West, and which is completely done in-house, indigenously, and which has survived with no environmental impact at all. And we have managed to keep it running for over 2 decades in the very first island. So this is definitely a very good example of a sustainable technology utilizing what is around us, that is the ocean, and serving the needs of a population which was extremely water stressed. Now we have, of course, it was a lot of science. It's a big scientific endeavor, and we definitely had to work a lot towards it. We have also started scaling up this technology. Now, if you look at this picture, these are reverse osmosis membranes, and which is a very popular technology. The seawater reverse osmosis is very, very popular around the world today, especially in the Middle East. But you can see the large footprint. You can see all the various effects of this system where you have to dispose the membranes, they are not biodegradable, and also there's a huge brine formation that happens which needs to be very, very safely and environmentally hazard free kind of disposal has to be undertaken. So for all these methods though, whether it is reverse osmosis or whether it is thermal desalination, though they all work and each one will have its pros and cons, the main thing is that they all require energy. So in a bid to reduce the water stress, we are actually using energy to create systems which are again contributing to the GHGs. And therefore, we have been parallelly also looking at renewable energy powered desalination technologies. The first wave powered desalination system was implemented by NIOT way back in 2003 and was successful. We have done solar desalination, and currently one of the flagship programs is a OTEC powered desalination plant, again back in the Kavratti island, but here instead of drawing power from the grid, it will self-generate the power so that it will be completely off-grid. It's a clean water being generated of green energy using OTEC. And these are some special components of this OTEC project because it's being done for the first time in the world. There's a very complex turbine which has been developed for the first time, and there's also some technological challenges in the offshore for the cold water pipeline. Coming to other technologies, there is now a novel electrochemical desalination that I'm working on, where we are actually producing net positive energy while making fresh water. And it basically, it eliminates the operational energy costs. And it seems like it is a dream, but we are after the laboratory stage, we are now working at a scale in the laboratory, and scaling up is a challenge. But this technology actually takes care of the circular economy approach. We can also generate hydrogen. That is the most required thing now today in today's technologies. And if you generate hydrogen using renewable powers like OTEC, that is actually something that we need to really consider. Apart from the megawatt levels of energy that we try to work on, small energy forms are as important for sustainability and for touching the lives of coastal and rural communities. And to this end, a saline water lantern also has been developed in NIOT. It has been taken by many industries, and slowly work has started towards marketing these. There's another technology right now which I'm working on, that is the air water generation. And actually portable and compact units up to 20 liters per day and 150 liters per day have already been commercialized, but we are improving them and optimizing them and trying to scale down and scale up. And this is simply converting the atmospheric water into fresh water which is drinkable. It is a very interesting and safe technology, and we hope in this coming couple of years we will make many forms and of different sizes and capacities to work as a big move towards sustainability. Now, as far as the niche technologies are concerned, I said there is a huge amount of resources. We have minerals, then gas hydrates. All this work is being done in NIOT. There's work being done on mining of polymetallic nodules. Manned and unmanned underwater vehicles are being developed, and I'm sure this will be spoken of by NIOT people. The first ever manned submersible for 6,000 meters is currently under development. So these are all very challenging, and that's where all the components of the ocean, oceanography and the constituents may play a very big role in the designs of such niche technologies. There is gas hydrates which are difficult to harness. Now, those were all about the resources. What are the issues plaguing the oceans today? So there are various issues: shoreline changes, pollution, acidification, microplastics, and name it, and there are so many happening today as a serious issue plaguing the ocean. But I'll just talk about the shoreline changes. Basically, many locations due to anthropogenic interventions, the shoreline is changing, and therefore shore protection measures have to be undertaken in a sustainable manner. And some of these have been done by NIOT, and they have really been appreciated by the state governments in the coastal states. More such technologies need to be developed so that any anthropogenic changes are actually mitigated by using sustainable, safe methods to protect the coastline. All these works actually require field work, and these are just some pictures to show that in NIOT we actually, all of us, we go to the field, we actually go to the sites, we have traveled in small boats or big vessels, and without doing this, actually, we cannot really develop new technologies for the country. It's a serious combination of multidisciplinary expertise, work, teamwork at sites, teamwork within the offices. All technology developments include various facets of original design, lab testing, simulations, then pilot implementations, and then actual implementations in the ocean where we all sail and go on cruises. So this is a very challenging area, but our responsibility as scientists is to make sure that we develop and harness the technologies in a very sustainable manner. The ocean has a lot to offer, but we also have to make sure in turn that we keep it safe, clean, and we don't damage it more than it already has been damaged. So I urge you all to let us take up the challenge to work towards sustainable ocean technologies for a better tomorrow. And once again, thank you so much for giving me this opportunity. Thank you very much.
Ma'am, we can now take a few questions from the floor. Anybody has questions?
Sure.
There are no questions. Yeah, thank you, ma'am, for the informative talk and your valuable perspectives. Thank you for being with us today. Thank you.
Thank you very much. Bye-bye.
Yeah, bye. So the program for the day has concluded. You may now take a break and relax. Please join us tomorrow morning at 9:30 for another interesting session. Thank you.